good morning and welcome. So, welcome for the discussion here on Geography, General Studies part. My friends, as all of us were well aware about the question pattern in preliminary exam of UPSC, Geography and environment plays a very vital role, very important role. Geography as the new trend since 2012, if you look at, is nowadays more towards applied orientation, more towards the mapping and the application orientation than what it was traditionally earlier only factual things. Fact-based questions also there, definitely, but the questions on map, diagram based and the in fact application based is more now. I would like to discuss with you about what should be our approach for UPSC preliminary exam preparation. In this particular sessions, in complete analysis will be there, as well as some very important areas I will cover. So, my friends, I am inviting you all for complete with wholehearted participation. Please do participate this particular program, and let us start with the basic concepts. What are very important thing as per the plan given to you. There will be a slight modification in the plan as I have just given. They are like universe and the solar system and all these things for today. Some updation is needed. Just I hopefully gradually will able to complete. By the way, in the general studies geography, GS geography part of the preliminary exam, as we know, there are two most important areas. One is the physical geography, and you can say this is the physical geography where you have world physical geography generally you are talking about, and another one is regional geography where you have India part also. By the way, physical geography and another one is human and economic geography. I have divided this into two major parts, human and economic geography and physical geography. And let me tell you, these two areas, physical geography where geomorphology, climatology, oceanography, biogeography, etc. are there. In this application part is in India part also. If you look at the number of questions here, these are physical geography questions are good. Physical geography questions are generally in fact concept based. Their fact is very less except the India part. So, physical geography you have two areas here. Physical geography you have two important regions. One world physical, another one is India physical geography. Okay. So, two major area. This is in the physical geography, world and India two part. In human geography again the same case, world and India two parts you have, India and the world. Now, what we need to do? World geography and geography of India. If I will go for the weightage in the physical geography of the world, majority here it is concept based, but India part is application based. It is mostly application based. And in the world geography part, if you will see, mostly it is map based. Human geography, they are mostly it is map based in the world geography, and it is fact based. India part is mostly fact and application. I will in fact gradually will get to know about this, how it is application oriented and how it is concept oriented. If you look at the previous year paper, you will find out in the physical geography, for example, they are asking about rock types of metamorphism, or the mountain types, and mountain types with this the mechanism related things they have asked. In the India part, on the contrary, they asked about drainage system. Every year you are getting question from drainage system. The networking of the river, how it evolved, what is there. Factual things mostly, application and facts are there, of course both are there. One by one, topic wise we will discuss about this. World and India part, weightage wise if you will see, out of the total question, this part physical geography if you will see in total has almost 60% weightage. Physical geography has 60 to 70% weightage is there, and this is 30 to 40% weightage you are having. Human and economic geography. Gradually what happens, this particular part India fact and application, this part is increasing. ये जो trend है ये increase हो रहा है. This particular India part fact and application based question are gradually they are increasing. So we need to prepare in that particular aspect. We need to see these things. My friends, let us start from a very easy and yes, good morning to all of you. Fine. I got the first WhatsApp here from your batch. I am saying physical and the human geography both, if you will see, this is completely concept based and application. Here is some facts are there, more and more facts are there in the human part. Analysis you have to do and so many things are there. In this coming couple of days, what I will do, I would like to discuss the most important topic and hope we will able to cover whatever the dimension the UPSC is supposed to ask this year, that I will cover. I feel so, and I need your complete participation on that. What type of participation? Every day you have to revise, and the text which I will give you, you need to just the prescribed whatever material I will say or the topics I will say, you covered it from whatever sources you have. Let us first go for this in the physical geography. If you have seen our planner, we have written one thing that today is, for example, universe, solar universe and the earth, and some basic things I have given. That is beyond these two, like general geography used to call. That is for fundamental things. One should know about earth rotation, revolution, latitude, longitude. Okay, so these are the things they have asked on the universe, though it is a part of science and technology. Universe and our solar system, in which you are getting questions also, and hope you will get it because of our lunar mission and all. So we will look at all those things. So today, as our earlier program, which whatever we have given, based on that I can say that in the preliminary exam, the number of questions what is there from geography, I feel you will get 12 to 13 question maximum, out of which we can have some map based question, you can have some concept based questions, application, and fact based. If I will go for weightage, out of this, in fact, 2 to 3 questions you will have. 3 questions on the upper part 0.3, concept based is 0.5, application 1 to 2 questions if it is 4 to 5 questions, 3 to 4 questions you have like this, fact based question. We need to look at, based on this, 12 to 13 questions you are getting. Fact based questions are increasing nowadays. ये जो map based question in this, map based questions are mostly from India. The area which you need to see, people are facing problem on map based question. So for which I will say, while reading the current affairs, please look at the peripheral area in a map. For example, you are talking about Caspian Sea, you must see what are the countries bordering these regions. Aral Sea, what are the most important countries in this region. While you are talking about Bab el Mandab or the choke points of Indian Ocean, for example, Red Sea region, Bab el Mandab, you should see near Bab el Mandab what are the countries are there. Where is the most important countries located in and around the Black Sea, for an example. or Ukraine, the countries bordering Ukraine, countries which are forming boundary with any disputed territory, any important regions. In the mapping part, we need to be very strong and we have to do this. Friends, these are the areas, as I have just mentioned, map-based question, 3 questions nearly, concept-based question nearly 4, and the application 2 questions. These are like, as I feel, this type of question can be asked. Let us see in the exam how we will get it, but most of the questions will be somewhere over around this particular trend. Based on the last couple of years analysis, I can say that they are asking questions sometimes to disturb you. I mean, this fact-based question particularly to distract you from the trend. So, we will see a question was there regarding Ranjit River. Ranjit River was in news because of in the Sikkim, Ranjit River, a tributary of Tista. It was asked earlier. There is a question about national park and river system, questions on the city and the river. So, these are like, map based questions, whatever they have given, map based, these are questions are map based questions, but in a different orientation. So, let us prepare for that. So, my discussion will be on the basis of the exam trend only and weightage of the topics. As you have seen, and as we all of us were aware about this, like what to study in geography, how to go for this. My request to all of you, please look at previous year question paper. Please look at the previous year's question paper while we are going for any of the topic. This will give you some insight into the trends at least. Though we are going to discuss it in detail, but I want that you should have that orientation at least. Friends, on this, I can say from today, as we know that on general geography, in which some fundamental concepts I will discuss today. First, fundamental concepts, general geography. Then I will go for this in detail as per the plan. Friends, as we all were well aware about the question trend of the preliminary exam, one thing, the questions are seldom, very less likely you will get direct. Mostly thought-provoking questions are there. The map-based question is more concept and application from Kashmir to Kanyakumari. What are the major forest type we will came across in a sequential way from north to south? Now, in this, if you don't know the map study, if you don't know the location of Kashmir, location of Kanyakumari and the type of vegetation, what type of vegetation, you will not able to appreciate it, you will not able to do it. You don't have to mug it up, but you should know the concept. So, we need to look at in this particular perspective that the concept you should have aligned with the concept and you should need to go for the application. Fine, let us look at one more in general geography. General geography, I will say locating a place that is latitude and longitude, locating a place that is about latitude and longitude. I will discuss about this one first, locating a place. As my friends, all of us were well aware, this is the globe. Globe is the 3-dimensional representation of the earth or part of it to the scale. Now, likewise, you have a map. Map is a 2-dimensional representation of the earth. Any place over the earth surface can be located 100% accurately with the help of two things, latitude and longitude. And I hope all of you are well aware. So, one important point I would like to say first is globe, it is the three-dimensional representation of the earth to the scale. Okay. As we know, as I have mentioned about to the scale, so it is proportionately you are preparing the globe, radius of the earth based on this, what should be the radius of the globe, proportionately you will go for this. This is the model of the earth, it is the model of the earth, model of the earth, it is the model of the earth. Friends, we will look at this is the globe here, and in this globe, there are, if you look at here, this is the equator. I am not going in detail of this. I am just saying this is the equator at the middle. If you will take, divide into two equal parts, the plane which divides will pass through the center of the earth. The northern part is northern hemisphere, southern part southern hemisphere. So, in the northern hemisphere, if you look at this globe clearly, carefully, you see northern and southern hemisphere has more water bodies. Northern hemisphere has more continental part. Southern hemisphere is known as water hemisphere. Northern hemisphere is called as land hemisphere. Right? Now, if this is the earth here and I have taken this is the plane which is dividing into two parts. I said this is northern hemisphere, this is southern hemisphere. The plane which divides it into two equal parts is the equatorial plane, and this equatorial plane is passing through the center of the earth center, forming a 0 degree latitudinal angle. How it is 0 degree latitudinal angle? From here you see this is, okay, this is forming 0 degree, 10, 20, 30, likewise here up to I will go 90 degree from this side. From this side I am going up to 90 degree. From this side also I can say like 10, 20, 30 up to 90 degree here, isn't it? So, this is here is this part, this is the angle here from the center of the earth toward this side, here it is 90 degree north, 90 degree north here, it is the north pole. Latitude is the angular distance from the center of the earth. ये जो हमने whatever I have just cut the earth into two parts, I said the plane which divides earth into two parts is known as the equatorial plane, my friends. If I will cut this earth into two parts, okay, the plane which divides it into two equal halves here, it will necessarily pass through the center of the earth, and the northern part is the northern hemisphere, southern part southern hemisphere, I said. Now, if I will take an angle here, मैं एक एंगल लेता हूँ, here I have taken an angle here, and this angle I have taken, let us say it is 10 degree angle, 10 degree. Now I will rotate the earth. I have taken 10 degree angle and rotating the earth like this. I will get an angle from the earth interior, it will touch here. Now I will rotate this, I will get these points here, one by one points like this. I will join these points, I will find out a line like this. This line is having, you can see this, I will get this type of points here, all these points, while I will take it from the center of the earth. Imagine the case, from the center of the earth I have taken a angle here of 10 degree, it will touch here, and now I will rotate this globe, I will find all these lines here like these points. So now I will join this with this one, here also I will take an angle, this angle will be 10 degree. This is the 10 degree north of the equatorial plane. So, it is the 10 degree north latitude. This will be 10 degree north latitude. ये जो है आपका 10 degree north latitude हुआ. This is the 10 degree north latitude. And likewise, if I will draw these angles like this up to 45, 60, 90 degree, and here from 0 to 10, 20, 30, 40 up to 90 degree, I will have this type of angles here. So, what I am saying is, in a globe we can show all these latitudes with this, and we can place any location can be done with the help of this. So, first you can see here, as I have just mentioned, globe is the model of the earth, true representation of the earth, and in a globe we have latitude and longitude. What is a latitude here? Latitude क्या है? Latitude, what is this latitude? Latitude, note down here, angular distance from the center of the earth, towards north or south of the equatorial plane, Okay, angular distance from the center of the earth towards north or south of the equatorial plane is latitude. 0 degree latitude is equal to equator, and maximum is 90 degree north or 90 degree south latitude is called as poles. Now, we have a question earlier, how many latitude we can draw? Infinite number of latitude we can draw. The length of the latitude decreases from the equator towards the poles. You can see these things like, as I have just mentioned, latitude are angular distance from the center of the earth towards north or south of the equatorial plane, I said latitude. So, if I will say about this latitude images, if I will draw this, let us say this one here, latitude and longitude, we can look at, in this case we can see from the earth, center of the earth, this is like, these are the line which are there is latitude, they are called as the latitude, which is dividing the earth into different segment, as you know, from the center of the earth. So, angular distance which I said about angular distance from the center of the earth, I hope you got it, that from the center of the earth towards periphery, if you will go, you will have an angle here. This type, here you have an angle, and the same angular value is, it is here. Let us say this angular value is here, this is 30 degree, this one also 30 degree. So, all the line or the points joining all these two, it is 30 degree north latitude. Okay. Likewise, maximum, this is 90 degree north latitude. Have you got these things? Is it clear to you, or anywhere you have any problem, please? First, I am going for latitude, gradually we will enter into other topics. First, we will go for the latitude. What is latitude? Latitude is the angular distance from the center of the earth towards north or south of the equatorial plane. Towards north or south. Ye north way I have taken it in the north. Now I can go for like in the south of this 45 degree. This is 45 degree south of the equatorial plane. Let us say. So this is 45 degree south of the equatorial plane. 45 degree south of the equatorial plane. I am again saying angular distance from the center of the earth towards north or south of the equatorial plane. Now, how many latitude we can draw? We can draw infinite number of latitude, and if it is 1 degree interval, then it will be limited, no doubt. But there is no degree interval, but mean you can have infinite number of latitude. Look at here, in these latitudes, I can say one more point here. The length of the latitude, latitudes decreases from the equator to the poles. From the equator to the poles, the length of the latitude decreases here. Okay. Equator is the longest latitude and is a great circle. Great circle. You can see here, if this is the latitude here, you can see this is the 0 degree latitude, equator. Equator is the greatest possible circle here. It is a great circle. Length of the latitude gradually decreases and finally pole is a point. This side also equator, all these are, this is a equator here, longest, I can say this is the circumference of the earth with this almost equalities. So length of the equator is longest equator is the longest at latitude, and it is a great circle. Okay. Poles are points. North and south poles are points. Poles are points, and rest all latitudes are small circle. Small circles. Rest all latitudes are small circles. Okay. Length of the latitude decreases from the equator to the poles. Equator is the longest latitude and the great circle, it is a great circle, poles are points and rest all latitudes are small circle. This is what I said. I hope these points you appreciate. There was a question long back, in fact there was a question on this latitude and longitude regarding their spacing, their characteristics also. Now, though the number of question is very less, but we need to see some fundamental things, that is why I am dealing. By the way, the latitudes are helpful for what? The latitudes are helpful for climatic division. Latitudes are helpful for climatic division. Okay. Latitudes are helpful for climatic division. Climatic division. We know if this is 0 degree latitude here at the equator, this is 30 degree. Zero degree, 23.5 degree north, 23.5 degree south. This is here is 66.5 degree north, 66.5 degree south. This is 90 degree north and this is 90 degree south. So this region is, in this case, this is the low latitude region, Tropic of Cancer, Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle. This is North Pole and this one is the South Pole. As all of us were well aware about this, this is the tropical region. This is the tropical region. This one here, it is the temperate zone. Temperate zone. This is also temperate zone. Then beyond this you have the polar zone. Polar zone. My friends, you remember one thing, that when you will go away from the equator towards the poles, temperature decreases. So here it is hot, warm, cool, cold. Hot, warm, cool and cold. So The moment you will go away from the equator, temperature will decrease. So, these are climatic division in which is more helpful. I am saying the latitudes are more useful for climatic division rather than any other things. Of course, for location it is playing a very important role, but also for climatic division. The latitudes are more helpful for climatic classification. Friends, as I have just said about these two 0 degree, that is the equator, this is the equator here. From the equator towards north or south, northern hemisphere or southern hemisphere, the characteristic features of both will be different because unequal distribution of continent and the ocean. More water is there in southern hemisphere, more continent in northern hemisphere. Their behavior will be different, their characteristics will be different, their overall geoecological condition will be different. We will discuss about all those things gradually. So, as I have just mentioned about these two, as I said about the latitudes, these very basic, two basic things. Latitudes are parallel to each other. Why? All latitudes are parallel to each other. Why? Latitudes are always parallel to each other. Parallel to each other. Why? Can anyone tell me why latitudes are parallel to each other? It is because the latitude as such, as I said, is drawn with the help of angular distance from a common point, because latitude are drawn because it represent angular distance from a common center. If you are taking angular distance from common center, definitely it will have the angle will be, because of that you will have same, they will be parallel. Dekho yahan pe, because they are from common center, so these are parallel, they will be parallel to each other always. Okay, I hope you got it. Now, in this way, latitudes are more useful for climatic division. So, climatically we can divide the world into different, and latitudinally we can divide the world into different climatic division also. Friends, today itself I would like to tell you, I will link up few things with the coming classes. That is why I would like to say, if here is a continent, let us say we have a continent, here. Let us assume that this is a continent here. Okay, हम assume करते हैं कि it is a continent. Okay, let us say this is a continent. If it is a continent, definitely both sides we have water. So, we have an ocean this side and this side also ocean. I am just demonstrating you with some important one thing where people are many times saying like, sir, it is very difficult to memorize the climatic division and so many things. You just see here, if it is 0 degree latitude, it is 90 degree latitude. This is a continent. If it is a continent which is extending from 0 to 90 degree, both sides you have ocean. So, you have, let us say, another up to here it is 0 to 10 degree latitude. Let us say 10 degree latitude. And here it is, let us say 60 degree latitude. 60 degree, why I have taken 60? Because from 60 degree latitude, generally it is very cold condition, and 0 to 10 degree, the average position of the sun is many times you will get, commonly you will find out average position of the sun is mostly in this particular position 0 to 10 degree. Now, my friends, you see here 10, then let us say this is 30 degree, this is 45 degree. Okay. 30 degree latitude, 45 degree latitude, 60 degree, 90 degree latitude. Now, the 0 to 10 degree, you remember among the climate, I told you earlier, this is hot up to here. This is warm, this is cool, this is cold. ऐसे बोला था ना मैं, I told you earlier, hot, warm, cool, cold. Temperature decreases if you go up. Now there I have taken 23.5 degree, here I have taken 30 degree. ट्रॉपिकल एरिया के लिए हमने वहां पे 23.5 डिग्री लिया था. देखो 23.5 डिग्री, बिकॉज द सन मूव फ्रॉम 0 to 23.5 डिग्री, अगेन कम बैक हियर. सूरज जो है यहां से यहां तक जाते हैं. सन जनरली मूव फ्रॉम हियर टू हियर इन ए ईयर एंड इट क्रॉसेस द इक्वेटर ट्वाइस इन ए ईयर. सो जब इक्वेटर के ऊपर होता है सन, उसको बोलते हैं क्या? इक्विनॉक्स. आपको पता ही होगा. इफ यू डोंट नो, प्लीज रिमेंबर वन थिंग, देयर इज एन अपरेंट मूवमेंट ऑफ द सन बिकॉज ऑफ द दिस इंक्लाइन एक्सिस ऑफ द अर्थ. ये अर्थ की इंक्लाइन एक्सिस है. सो बिकॉज ऑफ विच if there is like sun rays falling here, it is like there is a not this is like in a year you have like from 23.5 degree north to 23.5 degree south, the sun is at fixed place, no doubt, but because of the earth's inclined axis it looks like as if sun is moving from 23.5 degree north to 23.5 degree south. ऐसे लगता है कि सूरज जो है ना मूव कर रहा है, मगर ये ऐसा नहीं है. It looks like as if the sun is moving from 23.5 degree north to south, but it is in fact because of the inclined axis of the earth that there is the apparent movement of the sun, which is called as apparent movement of the sun, because of which you have seasonal variation also. Friends, instead of 23.5 degree north and 23.5 degree south, I have taken here 30 degree because there is unequal distribution of continent and the ocean over the hemisphere, both the hemisphere. So let us take it 30 degree and you have 45, 60 degree and 90 degree. Then a very interesting thing you will get, between 0 to 10 degree you have like always uniform high temperature. Here you will get the hot and wet equatorial climate. Hot and wet equatorial climate. Hot, wet equatorial climate, my friends, you will find out here. And in this region, cold area, cold polar climate, you will find it. Pole polar climate. So latitudes are more helpful for climatic classification. I hope you got it from these two. But in between there is a change in this perspective, change in their characteristics, because you can see here there will be a change in their characteristics here, because this is here climate depends on the impact of the ocean. ओशियन का क्या इम्पैक्ट है उसी रीजन्स पे, वो बहुत इंपॉर्टेंट है. हाउ एंड टू व्हाट एक्सटेंट इट इज इम्पैक्टिंग. ओके, लेट अस से इफ दिस इज हॉट वेट इक्वेटोरियल क्लाइमेट, दिस इज कोल्ड पोलर क्लाइमेट, then you will see this particular right hand side and left hand side. You see this side here. In this side we have different climate also. Let us say यहाँ तक this influence is there. This is L C M. Can you memorize this? L C M. I am saying about Laurentia climate, okay, China type of climate, and monsoon type of climate. Three types of climate I have said: LCM, China, Laurentia, China, and monsoon type of climate. Friends, many times we got questions in the prelim from this particular part, like monsoon characteristics, Laurentian climate, monsoon characteristics twice we got already. I'll read out the questions and I will do this also, how it is. Here we got like, SSS, you remember, triple S, SSS. So we can say like, Siberian climate. This is steppe type of climate, and this one is savanna type of climate. So three types of climate you are having at the middle part of the continent, and you will have like here, same way, you know my name, okay. So this is BM hot desert. Look at here, British type of climate, this one is Mediterranean climate, and here you have the hot desert type of climate, okay. So we have this type of climate here. Now what is the name for this particular area? Now you tell me one thing. If I'll say like this particular corner and this corner, if I'll see, all the climatic types you will find out in these regions. They are in the right hand side, I mean eastern margin. These are eastern margin climate. And this side you have the climate you will get in the western margin climate. And in between we have central continental climate. My friends, you remember that all the climate of eastern margin climate, you can see Laurentia, China, monsoon. There are three types of climate: Laurentia, China, and monsoon type of climate. There are specific characteristics, specifically monsoon. If you will see, monsoon only you will get between 0 to 10 degree here, 10 to 30 degree latitude at the eastern margins. All eastern margin climates at different segment. If I will say, this is hot tropical region, this one. ये जो 30 डिग्री तक क्या है, hot tropical area है, hot tropical region. This is up to 30 degree. So hot tropical eastern margin is monsoon. Hot tropical central continental is savanna. Look at here. Hot tropical eastern margin monsoon. Warm temperate central continental is steppe. Got it? Cool temperate western margin is British. Alternate name of the climate it is given here. My friend, is so easy. I will discuss about all these in whatever needed for our exam. We have already got question from wet equatorial climate, monsoon climate, savanna, hot desert 4 or 5 times we got, Mediterranean we got, British also, steppe, Siberian. We got from all these, even from the cold polar climate. So we will look at, this is the latitude how is responsible for climatic division. I have shown you. At different latitude you are getting different type of climate in the world, my friends. Hot wet equatorial climate at the equatorial region 0 to 10 degree everywhere, wherever you will go, you will find out definitely the hot wet equatorial climate in this region 0 to 30 degree latitude. 0 to 30 degree everywhere in the world, wherever you will go, you will find out this. And is best developed over Africa and South America, Amazon River Valley. These are things I will discuss, but in climatology session we will discuss in detail. I am just giving an input onto this, that why latitude is important. Latitudes are important for climatic classification, I said. Those of you didn't able to memorize the things, characteristics and all, I am requesting you all to just have a glance over this table, whatever I have just given, and try to find out logic behind this, why it is. Now, it depends on the climate, wind system and all other things, that how the climate will be, what type of climate it will be. Many times we are getting questions from climatology, and climatology mostly from this table, whatever I have given. We need to study. I will want to spend some time later on this particular topic as per the schedule. But what I am saying is, latitudes are useful for climatic classification. Latitudes are more useful for climatic classification. All the latitudes are parallel to each other. I hope it is clear about latitude. I will go for now longitude. Longitudes. These are arc and line joining both the poles. These are the arc and lines joining both the poles. Now understand one thing here. Let us say, if this is the earth here, I will take a cross section like this. ऐसे मैं cut करता हूँ earth को. This front edge, and this side you have back side. This side you have the opposite side you are having here. So this front edge, whatever is there, this side and this side, if I will say, देखो आप, in geography we have a coordinate system, as you know. If you don't know, please remember, this is called, this is here is north, south, east and west, you know. If this is like this, हम ऐसे कट किया, this side is eastern hemisphere, this side is western hemisphere. If I will cut this earth like this, opposite side you have, and if I will do it like this, what will be the opposite side? मैंने कहा if I will cut this earth into two equal part, ये जो है, the line which is in front of this, okay, if look at here carefully, from this pole point I have taken this, this is a 0 degree, 0 degree angle, 10, 20, 30, 40, it is 90 degree, it is 180 degree. What is this? This side is east, it is हो गया, ये है eastern hemisphere, east. Right side is western hemisphere. If it is like this, this is western hemisphere. There are two parts. Is this western hemisphere, this side is eastern hemisphere. In between this if I will take 0 degree angle, if I am taking 0 degree, now it will be here. अगर ये 0 degree लेता हूँ, here if I will take it at 0 degree, let us say it is 0 degree, here it is 10, 20, 30, 40 like this, here it is 90 degree, here it will be like, you know, this is 180 degree, 0, 10, 20, 30, 45, 60, 90 degree, 120 degree, 180 degree east. ऐसे होगा ये एंगल इफ आई डू, यू गॉट इट व्हाट आई एम सेइंग. ऐसे में एंगल अगर यहाँ भी लूँ, हियर ऑल्सो इफ आई टेक द सेम टाइप ऑफ एंगल हियर, so it is like 10, 20, 10, 45, 60, 90, 120, 180 degree east हो गया. So I have taken the angle. Now this is the angle I have taken. Same way if I will join these angles, ये दोनों को एंगल को ऐसे join करूँगा, then I will find out longitude here. Okay, इसके लिए mathematical processes है, there are lot of processes on this. I just want to tell you, arc and line joining both, it is an angular distance from the, देखो यहाँ से angle है ये, from this particular axis you will have taken the angular distance here, ये भी angular distance है. By the way, 0 degree longitude is equal to 0 degree longitude, if it is, इसका back side होगा ये, if it is 0 degree longitude this side, it is 0 degree, this will be 180 degree east equal to 180 degree west. ये है ना 180 degree east, इधर से लगे तो east है, इधर से लगे तो west है, इधर east है. So ये हो जाएगा 0 degree, this will be 0 degree. Whether you got it or not, I am in fact whether longitude you got it or not, can you tell me? If not, I will definitely again repeat it. Angular distance क्या होता है? Now you are asking, my friend. Okay. Thank you very much for asking this question. Now I will answer it to you. मेरा एक दोस्त ने पूछा है, ये एंगुलर डिस्टेंस होता क्या है? देखिए आप प्लीज लुक एट हियर. ये अगर अर्थ हुआ, ठीक है, मैं एक रामपुरी चाकू लेके अर्थ को 2 हिस्से में काट दिया भाई, ये देखो, ठीक है, एंड इट विल डेफिनेटली पास थ्रू द सेंटर ऑफ द अर्थ. समझ में आया? नाउ ये सेंटर ऑफ द अर्थ से मैं एक एंगल लूंगा, ये 0 है, 10, 20, ये एंगल कितना हो रहा है, यहाँ एंगल बताओ, 20, 30 करके मैं 90 डिग्री तक ले पाऊंगा कि नहीं? ये जो है ना एंगुलर डिस्टेंस है, ये 10 डिग्री है, ये कितना है, ये दिस इज 45 डिग्री है। लाइकवाइज मैक्सिमम कहाँ तक लिया मैं, यहाँ तक, ये कितना है, 90 डिग्री है। समझ में आया? ये एंगुलर डिस्टेंस है। मैं ये एंगुलर डिस्टेंस लेके अर्थ को ऐसे यदि घुमाऊंगा मैं, तो मुझे ये पॉइंट मिलेगा, मुझे ये पॉइंट मिलेंगे। ये सब को अगर हम जोड़ देंगे तो लैटिट्यूड होगा। मैं इसी संदर्भ में बोला था आपको, ठीक है? यू गॉट इट माय फ्रेंड? दोज हु आस्क्ड मी अबाउट एंगुलर डिस्टेंस होता क्या है, क्लियर है क्या? इज इट क्लियर माय फ्रेंड? द पर्सन हु आस्क्ड मी एंगुलर डिस्टेंस क्या होता है, एंगल से जो डिस्टेंस लेते हैं एंगुलर डिस्टेंस है। दिस आई हैव टेकन इट फ्रॉम द एंगल 90 degree is the maximum angle which I can take because I have to rotate the globe. ग्लोब का आपको अर्थ को रोटेट करना है, अंदर से आप एंगल ले रहे हो, यही बताया था मैं। ओके माय फ्रेंड, ये जो आपको बोला मैं एंगुलर डिस्टेंस, यहाँ भी एंगुलर डिस्टेंस है, ये एंगल लिया ना आपने, ये 0 डिग्री 10, 20, 30, 40 करके 90 डिग्री ऐसे करोगे स्ट्रेट तो 180 डिग्री होगा ना। इधर से 0, 10, 20, 30 करके सीधे लोगे तो 180 होगा। यस और नो? मैं ऐसे किया क्योंकि ये एक साइड से, एक पर्सपेक्टिव से मैं एक कोने से देख रहा हूं, सीधे देखूंगा तो ये पूरे ऐसे होगा, उसका ऑपोजिट में होगा। ओके, तो लॉन्गिट्यूड्स आर लाइन जॉइनिंग बोथ द थिंग्स, लाइक दोनों को जो ज्वाइन करेगा वो लॉन्गिट्यूड है। देखिए friends, one thing I would like to tell you, geography is really practically what you are seeing, what you are viewing, what you are observing in our environment, that is what is geography. Don't worry about this. And the concept is very clear, very simple. Once you get it, if you are not getting, ask me, मैं explain करूँगा आपको, कोई दिक्कत नहीं है, एकदम easy है, this is the easiest thing. And once you got this, why I have taken this topic at the beginning, deviating from certain things, because I found, as per some of the survey also, people are having problem on appreciating these basic things, fundamental things. हम आगे build-up करेंगे और हो जाएगा. And there are questions on this because of that only. Angle is called angular distance. Yes, angle is angular distance. Distance क्यों बोला गया? Why we call it a distance? Because while you are taking this angle, आप जब angle ले रहे हैं, ये angle को throughout the earth surface you are talking about, position throughout the earth surface, that's why angular distance हो गया. Angle is angular distance. Clear है? Whoever said, thank you very much. Sorry. Now ये दो आपको लगा कि भाई ये लॉन्गिट्यूड में हाउ विल गेट टू, कैसे हम इन दोनों को टच करेंगे, कैसे कराया जाएगा? There is an instrument through which you usually join these curves. This is a scientific study on this. Distance which is drawn from an angle is called as angular distance. ठीक है, उसके ऊपर R&D नहीं करेंगे, आपको कॉन्सेप्ट क्लियर है तो वेरी नाइस, थैंक यू वेरी मच. बट वन थिंग इज वेरी क्लियर, क्वेश्चन क्या आएगा यूपीएससी में? क्वेश्चन आएंगे, हाउ मेनी लैटिट्यूड्स वी कैन ड्रॉ? Infinite. At 1 degree interval, how many we can draw? क्या है आंसर? आगे देखते हैं. And how it is? How many longitudes we can draw? Infinite, same way. So, but 1 degree interval में कितना होगा? देखो. And there are so many things. Let me see your one more response. I am just seeing. Just wait. Thank you very much. I am getting answer. Oh, thank you. Yeah, thank you very much. You have good knowledge. Thank you. Someone is saying 1 degree longitude represents how much distance? Someone is saying that okay, 4 minute time. Very good. but my friend, those who are completely new, they don't know, for them I have to say something. Look at here, this is the longitude here. Likewise, you can draw the longitude with the angular distance. ऐसे हम draw कर लेंगे longitude. These are arc line joining both these, है ना? Both these here. So, distance between the longitude gradually decreases towards the pole. Equator में, equator से pole के तरफ अगर जाएंगे आप, that distance is gradually, देखो यहाँ पे देखो distance कैसे घट रहा है. Distance between the longitudes is gradually decreasing while it will go away from the equator to the pole. Equator से pole के तरफ जाएगा, distance घटता जा रहा है ना दोनों, spacing between them. This is what the characteristics of longitude. My friends, इतना याद रखो, ये सामने वाला जो 0 डिग्री बोला मैं, इसको बोलते हैं स्टैंडर्ड मेरिडियन और प्राइम मेरिडियन. ये जो 0 डिग्री बोला मैं, दिस इज कॉल्ड एज 0 डिग्री लॉन्गिट्यूड इज इक्वल टू स्टैंडर्ड मेरिडियन और प्राइम मेरिडियन. प्लीज रिमेंबर दिस. 0 डिग्री लॉन्गिट्यूड इज इक्वल टू द स्टैंडर्ड मेरिडियन और प्राइम मेरिडियन. Prime meridian. Okay, it passes through Greenwich city near London. So, it is also called as Greenwich line और मेरिडियन. ग्रीनविच मेरिडियन. याद रखें, मेरिडियन का मतलब होता है लॉन्गिट्यूड. मेरिडियंस मीन लॉन्गिट्यूड. सो ग्रीनविच लॉन्गिट्यूड और ग्रीनविच मेरिडियन, द मेरिडियन व्हिच इज पासिंग थ्रू दिस. ग्रीनविच को क्यों रखा गया? लेट मी टेल यू व्हाई वी हैव टेकन ग्रीनविच. बिकॉज अगर ये 0 डिग्री है, उसका ऑपोजिट में क्या होगा? 180 डिग्री मैंने कहा. तो 0 डिग्री के ऑपोजिट में 180 डिग्री है. एंड रिमेंबर, इफ 0 डिग्री इज देयर, 180 डिग्री ऐसे होना चाहिए. 180 डिग्री को ऐसे होना चाहिए कि भाई जहां पे कॉन्टिनेंटल पार्ट शुड बी लेस. वी नीड टू सिलेक्ट 180 डिग्री लाइन इन सच ए वे दैट इट शुड कवर लेस कॉन्टिनेंटल पार्ट. अगर लेस कॉन्टिनेंटल पार्ट है तो where you can have, that is what we found out. Finally the scientists they got it like, okay, it is through only Bering Strait का अगर देखोगे उसी लाइन में होगा. So they found out that 180 डिग्री लॉन्गिट्यूड जहां पे कि सबसे कम जमीन होगा, मतलब ओवर द ओशियनिक पार्ट विल बी more continent will not be there, least continental coverage is there, then it will be better. Because 180 डिग्री लॉन्गिट्यूड को they have taken it, we considered it as इंटरनेशनल डेट लाइन आइडियल. उसको साथ साथ आइडियल किया गया कि क्योंकि ये 0 डिग्री इज स्टैंडर्ड मेरिडियन, सो इट इज यूज्ड एज द रेफरेंस मेरिडियन or longitude for calculating global time, global standard time. पूरे दुनिया भर का टाइमिंग क्या होगा? Global standard time we need to find out. For that only we have done this 0 degree longitude. How we will able to do this? देखिए, 180 degree in each hemisphere, 0 to 180 degree, 0 to 180 degree, total कितना हुआ? 360 degree. So 360 degree we are covering in 360 डिग्री हम कवर करते हैं कितने टाइम में? 360 डिग्री ऑफ लॉन्गिट्यूड, 360 डिग्री लॉन्गिट्यूड कवर्ड इन 24 hours time. So 1 degree longitude will be covered in 24 by 360 hour time. which is equal to 24 by 360 into 60 minute time, which is equal to कितना हो रहा है 4 minute time. My friend, someone has already answered this. Thank you very much. So 1 degree अगर आप displace करते हो, if you are displacing for 1 degree, mean you are covering 4 minute time. Okay. So from one longitude to another longitude, we can, for global time calculation, we can use this. For an example, a person is traveling from 0 degree to, let us say 10 degree west. 0 degree to 10 degree west को आ गया, तो कितना टाइम डिफरेंस होगा? 10 into 4 equal to 40 minutes time will be differ. 40 minutes time का डिफरेंस होंगे यहाँ पे. 40 minutes time will differ here. There is a difference of 40 minute times. I hope you got it, friends. तो एक जो है ना, if we are talking about 2 longitude, so you have like the difference जो भी होगा into 4 कर दो, उतना टाइम का डिफरेंस होगा. The time difference will be 4 into the longitude, whatever longitude you have, 4 into the longitude. There are few questions we got earlier about time calculation. Now we are not getting, but there are few issues related to Indian Standard Time. So hope that you may get question. That's why I am just covering this. Longitudes, here you can see there are arc and line connecting both the poles, I said. Now these longitudes are useful for, ये जो longitudes है, ये longitude है, ये सब longitude है, these are the longitudes here. It is, earth is moving like this. So earth की 24 hours में एक राउंड देता है, 360 डिग्री है, तो 1 डिग्री को कितना होगा टाइम? 4 मिनट टाइम है. So on that basis we can calculate the world timing also. And remember, if it is 0 degree is this side, opposite is 180 degree. तो 0 डिग्री में अगर हम लोगों ने टाइम कैलकुलेशन करते हैं, वर्ल्ड के टाइम को रेफरेंस टाइम लिया गया, we have taken world time reference time on 0 degree, 180 degree is taken up as the international dateline. There is bit of variation here. Okay, international dateline. Let me show you. If you have a diagram here, then I can show you. That will be better for you. So you can say in the map, international dateline. If you will see this in the image here, in the image, you can see in the world atlas here. What is there? In the international dateline, you can see here. This is the line here. ये जो this side we have eastern hemisphere, this side we have western hemisphere. It is coming. क्यों? आप देखिए यहाँ पे, अगर ये 0 डिग्री में this side is eastern hemisphere, this side is western hemisphere. ये eastern hemisphere है, this is western hemisphere. So ये 180 डिग्री को देखो तो this side will be western hemisphere, this side will be eastern hemisphere. You got it? While you are looking at, आप ये सामने इसको देख रहे हो, this is 0 degree, then this is eastern hemisphere, this is western. Now ऐसे देखूंगा तो मैं this side will be, as you know, ऐसे अगर मैं देखूं तो क्या होगा? उल्टा हो जाएगा. So that's the case here. So this is 0 degree. When we are talking about this 0 degree, this side is eastern hemisphere, this is western. When it is 180 degree, this side is western, this side is eastern hemisphere. You look at here. Now what happened here? This should be one line here. Straight line होना चाहिए 180 degree, but there are few area where you have bit of, क्या क्या गया है यहाँ पे? There is a change. There is a change in this. Why there is a zigzag line? International dateline is a zigzag line. Let me show you one very interesting thing, that this is 180 degree. This is 180 degree longitude. 180 degree east equal to 180 degree west, let us say. Then the international dateline will be like this. ऐसे यहाँ से इतना आया इसके साथ साथ, ओके, ठीक है. Then can you see this in your atlas? Do you have the atlas with you? this is international dateline. This side is which hemisphere? I have already said this side will be western hemisphere, and this side will be eastern hemisphere. Eastern hemisphere. Now the question is, ये सब क्यों zigzag हुआ? To avoid confusion of two dates, क्योंकि day start होगा यहाँ पे day will start from here. Day starts from here. New day start from here only. यहाँ से start होगा. First day will start from here. Eastern hemisphere में sun rises in the east, you know. Eastern hemisphere में तो यहाँ पे if you can see, Japan is located here. ये जापान है. Japan is also, that's why first sunrise you will get, so Japan is known as country of rising sun. Now, this side western hemisphere, this side eastern hemisphere, लिखो यहाँ पे, international dateline is a zigzag line which deviates from 180° east or west longitude at three important places to avoid. Three important places कौन कौन सा है? 1, 2, 3. पहला क्या है ये? Bering Strait, Aleutian Island, and the South Pacific Island. Can you see this? Three places. Bering Strait, at this is one is Bering Strait, number 2 is Aleutian Island, and number 3 is South Pacific Island. South Pacific Island. Three places. मैंने कहा again I am saying at Bering Strait, then you have Aleutian Island, and third I am saying South Pacific Island. At three places is deviating from the normal path. Why? Deviate to normal path? To avoid confusion of two dates in same day. आप कहे सेम डे, एक दिन में 2 डेट्स का होगा, कंफ्यूजन ऑफ डे एंड टाइमिंग का. दैट्स द कॉज वी हैव टेकन अप दिस पर्टिकुलर इनिशिएटिव. My friend here, someone is saying, sir, I am so anxious about sorry, mapping pattern regarding national park, lakes, mountain. Don't worry, I'll do this. मैं इतना तो एश्योर करूंगा भाई, आप लोगों मेरे साथ प्रैक्टिस करोगे ना, कर लेंगे. गाना गाते हुए करवाऊंगा ये. जस्ट वेट, जब इंडिया पार्ट आएंगे कराएंगे मैपिंग. वर्ल्ड मैपिंग ऑल्सो, दो आई हैवंट रिटन, आई विल डू. Those who are, whatever area is important for us, will do this. On record, I am saying you will definitely get question from the areas. मेरे को पता नहीं क्यों मुझे लग रहा है, sometimes I feel that somewhere because of lot of new development in locational aspect, so latitude, longitude related somewhere sometimes can be asked. Okay, so that's the cause. We will have this. Step by step we will go. And because in the very compact way we need to do, we will do this. अब ये जो है ये तो कर लेंगे आप लोग, आई एम श्योर दैट यू विल एबल टू डू, बट आई जस्ट हैव टू गिव सम इनपुट ऑन दिस. आप देखो कैलकुलेट करेंगे ये about confusion of two dates in the same date is there, three places where it is there now, and the map it is showing. ये जो एरिया देखो, ये किरीबाटी, तोकेलो, समोआ आइलैंड, ये जो रीजन अमेरिकन समोआ, दिस इज एरीज, वो हैव लाइक bit of here changes here ये जगह. सो अभी इसमें चेंजेस किया गया बिकॉज तो ऑस्ट्रेलियन टाइम के साथ इनके साथ बेटर रहेगा रेदर देन दिस साइड. Sorry. These regions, longitudes are useful for time calculation. My friends, in India, if you look at the Tropic of Cancer passes through India, so as the 82.5 degree east longitude is passing through India. Now, it is for time calculation, I said. If you look at India, if this is India here, this is the Tropic of Cancer. The Tropic of Cancer. And here you have this is 82.5 degree east longitude. This is the standard meridian of India. This is the prime meridian or meridian. Indian standard time is through 82.5 because it divide India into almost two equal part. In fact, यहाँ पे clear नहीं है, but let me tell you that India's का जो position है ना इस तरफ, if you'll see, ऑलमोस्ट इक्वल होगा. यहाँ पे थोड़ा सा मेरा मैप तो ठीक नहीं है, बट आई विल टेल यू दिस इज उत्तर प्रदेश हियर, दिस इज मध्य प्रदेश हियर, दिस इज एरीज छत्तीसगढ़, दिस इज एरीज ओडिशा, दिस इज एरीज आंध्र प्रदेश. These are the state through which it passes, and this side if you will see, this is the Gujarat, here it is Rajasthan. You see 8 states are, these are like states are there. You can see this thing, they are asking questions sometimes on latitude and longitudinal extent of India, and matlab, these are like, which mountain is parallel to this, which mapping question, which river is parallel to this, what are the city nearest to the Tropic of Cancer, which capital city is nearest to the tropical Cancer. Tropic of Cancer से कौन सा city, state capital is nearest? Can anyone tell me? The answer will be Aizawl. Aizawl is the nearest one, not Ranchi. You can see this. All these things will be there. So what I am saying, this is like we should know about the states which are there, which are states and which regions is there. ये तो mapping का जहाँ तक है, mapping related things as I have just mentioned. First is you need to know about the these things like latitude, longitude, how it is, how we have to calculate timing, and the time calculation is on the basis of, I told you, 10 into 4, 4 minutes each, 1 of 4, you have to just do the things, calculate the things like, this side sun will rise, sun rises in the east. So time क्या होगा, बढ़ता जाएगा, कैसे बढ़ेंगे? You look at here, you will find out like, sun rises here. यहाँ पे first sunrise करेगा ना, here sun rises first, then it will go to this side. यहाँ आने में टाइम कितना लगेगा? टोटल 30 डिग्री लॉन्गिट्यूड की डिफरेंस है फ्रॉम हियर टू हियर. डू यू नो द लॉन्गिट्यूड्स ऑफ इंडिया? इंडिया का लॉन्गिट्यूड कितना है? इट इज 67 डिग्री 68 डिग्री 7 मिनट है ना, ईस्ट टू 97 डिग्री 25 मिनट ईस्ट. सो अप्रोक्सीमेटली 30 डिग्री का है, तो 30 इंटू 4 120 मिनट्स इज इक्वल टू 2 आवर्स. सो यहाँ पे अगर सनराइजेस होता है किस टाइम पे? इफ द सन राइजेस हियर एट 4 AM, हियर द सन विल कम एट 6 AM. 6 बजे जाके यहाँ पे होगा. यू गॉट इट? सन विल राइज आफ्टर 2 आवर्स बिकॉज द डिफरेंस इज 30 डिग्री लॉन्गिट्यूड. 30 डिग्री इंटू 4 120 minutes. So this type of question they have already asked. So we need to see latitude, longitude and all these things, we need to say we have few questions on this particular thing, latitude, longitude. मैंने पहले देखा है कुछ questions के ऊपर ये, and nowadays though they have given less importance, but we need to see there is a questions on this like where you have the after how much time sun will rise here, this type of question. Hope you will able to solve on this. Okay, latitude and longitude you got it, and as I said, time will be here from the sun rises here, so time from this particular time, यहाँ से time इधर पे जाएंगे तो ये अगर यहाँ पे 4 AM है, if it is time is 4 AM here will be 3 AM, here will be 2 AM, you got it? Here will be 1 AM, like this, you got it? So यहाँ से उधर, you remember timing, sun rises first here, then here, then here, then here, then here, likewise, you remember this. Please do solve few questions, whatever you have about this, we will get to know. Anyway, latitude and longitude, you got to know certain points on latitude and longitude, but today's topic, in which whatever I have said is like 2-3 things I told you. Latitudes are more useful for climatic classification, longitudes are more useful for what? For the time calculation. ये जो latitude वाला जो ये chapter दिया आपने कभी, if anyone has studied or if anyone has some at least input, if we have given chapter 15 of Gcilium, 16, 17, 18, 19, 20, 21, 22, 23, 24 and chapter number 25 of Gocheng Liang Certificate Physical and Human Geography. If anyone has studied this, must be knowing. अच्छा, ये जो यहाँ पे क्या important है? This is very important, this is important, this is important, material is important, BTC is important, mechanism. सवाना में मैप चाहिए, स्टेपी में ट्राइब और मैप चाहिए, ट्राइब प्लस मैप, साइबेरिया भी मैप चाहिए, ये इतने को चाहिए, हमें पढ़ना है. You need to study. I will discuss in detail about this in climatology, but I am just saying how important they are. If you can look at the previous year paper, you have got many times this question from this particular table. यही टेबल से बहुत बार क्वेश्चन आया है, मैं प्रूव करूंगा आगे. We will discuss about this in detail. What I am saying is because you have to cover a lot of things, so I request you all to also simultaneously look at all these points. Let us see now. The topic I will start is about Earth and its interior. What are the most important areas here? What we need to study? What we need to do? Okay, from here the questions is mostly from the physical conditions of the Earth interior. Let me move on to the topic, first topic here. Is it clear? यहाँ तक clear है सभी को? I will start for the topic here. So, topic here is about that universe, solar system we will discuss later on. For that, you know, there are few new development which I am just gathering, very important new development. Let us see जो है, अगर if it is proved, then you can get question from that. Let us see now. Earth and its interior. First topic, Earth and its interior. You must have studied all these things, Earth and its interior. See that the present Earth is developed gradually through the cooling and solidification of molten material, stellar material. And during this process, what happened? The denser material got accreted, they got concentrated at the middle part, and the lighter one towards periphery, which is known as density stratification. Again, I am saying the present Earth gradually developed due to cooling and solidification of molten stellar materials. During this cooling process, the denser materials got accreted at the center, okay, got deposited at the center, and less denser one towards the periphery. Again, I am saying the present Earth gradually developed due to the cooling and solidification of molten stellar material. Stellar material means star-like material. During this cooling process, this is the cooling process, the denser materials got accreted at the center and the less denser one towards the periphery. So, the densest material got accreted at the center and the less denser one towards periphery. So, my friends, what happened here, you see, during this process of cooling, the densest material densest materials at the center and less denser one towards periphery, and the less denser silica and aluminum related material, densest nickel and ferrous, iron and nickel, and intermediate where it will silica and magnesium. They got deposited like this. Less denser one towards the periphery, densest one at the center with nickel and ferrous, mostly nickel and iron. Silica and magnesium at the intermediate level, silica and aluminum material, aluminum rich material at the upper part. So in this way, the densest material got accreted at the center, less denser towards periphery. Again I am saying, the densest material is accreted at the center, less denser one towards periphery. Thereby, it developed three distinct zones here. What are those? It develops three distinct zones of, you can see, the core, the mantle, and the crust. This is the crust, mantle, and the core. This is the crust, outermost crust. Then you have the mantle. This is the mantle. Then this is the core. This is the mantle zone. Crust, mantle, and core. Three different zones it developed. The outermost part is known as the crust. So in this zone, this is the mantle here, and this one is the core here. So core as the densest part, it developed, and subsequently if you look at this, if I'll take a cross section of this, directly I'll come to how you got to know about this, not needed, but direct we should know about the earth interior, composition, physical conditions of the earth interior. If I'll take a cross section of this region, हम एक क्रॉस सेक्शन लेते हैं इसका यहाँ से यहाँ तक. If we'll take a cross section of this, then we'll find out the following. Note down here, the earth interior is not uniform, rather it has heterogeneity with three distinct zones. The earth's interior is not uniform. It has three distinct zones. Number one, the crust, two, the mantle, and the three, the core. I said crust has mostly silica and aluminum, mantle has mostly silica and magnesium, core has mostly nickel and ferrous. Three things, crust, mantle, and core. Three things you have. Now, if you will see this, like there is a change in the characteristics of this material with respect to depth. Crust, we can go for 30 to 90 kilometer. Crust, mantle, and the core, we can have this. ये जो आपको बनाया इसको हम डिटेल में बनाते हैं. For the prelim purpose, what they are doing, they are asking question like what are the physical state of all these matters and all. So let us see क्या होता है यहाँ पे. देखिए आप, if I will take a cross section of the earth surface or interior here, I will get it like this. This is the ocean, this is the continent. I will have first a zone with this is known as the upper crust. Upper crust. This is the lower crust. You remember these zones, in fact, for the preliminary exam, you need to remember. I request you all. Gravity collapse and somebody is saying density stratification. Oh, nebular accretion. Kya baat hai? Thank you very much. Great. Thanks for these inputs here. But lot of things are there. In fact, we have to control our emotion here, isn't it? Lot of things not needed for us. This is, you remember, crust. Here it is mantle, and this one here is core. You must remember that this is the upper mantle, this is the lower mantle, this is, here is the outer core, and here it is the inner core, outer core and inner core. These are, here is the discontinuities. Look at here, This crust can be of two types. Crust can be of two types. This is known as the continental crust here. This is the continental crust. Continental crust. And this part is called as the oceanic crust, below the ocean. Upper crust, lower crust, upper mantle, lower mantle, this is asthenosphere. This is lower mantle, this is center of the earth. I hope it is clear. अब हम देखते हैं what is the name of the discontinuity here. Some brief point I will tell you about these regions also. You remember CMR GL, याद होगा ये CMRGL, and this is the center of the earth. It is the center of the earth. Earth की center है ये. And if I'll go for this, like depth of this one कितना है? 6371 kilometer it is. .550. The kilometers whatever you have, in case of this one is 5150. You know it about this. This is 5150. 2900 kilometer depth. Lower mantle, if you see again, you have like 700 kilometer. Here it is 700 kilometer. Here it is 200 to 400 kilometer. Asthenosphere. 200 to 400 kilometer. This is 30 kilometer. This is nearly 70 kilometer. It may vary. कुछ books में 90 दिया होगा देखो, कुछ में 30 ही दे रखा है. But these are like there is a variation here of this. So silica rich silicate rock you will have in this. By the way, ये जो नाम बोला मैंने, ये CMRGL, this is here. You remember, this is Conard. Discontinuity. This is Moho or MOHORVICH. Moho discontinuity. This is Rapiti discontinuity. This is Gutenberg Wichat discontinuity. This is Lehman discontinuity, Gutenberg Wichat और Oldham कहते हैं. Oldham discontinuity and you have Lehman discontinuity. These are the discontinuity here. Now the question is, what are discontinuity? Where suddenly change in the temperature, change in the pressure condition, change in the composition, such abrupt changes होगा. These are known, where the continuity is breaking is known as discontinuity. Inside the earth interior there are a lot of discontinuity like this. As we know, in the upper crust nearly 2.9 is the density, lower crust 3.3. Here 2.9, 3.3, 2.9, 3.3. Density is in terms of grams per cubic centimeter, you remember, 3.3. Now here is 1.8, 2.5, ये जो ना density is gram per cubic centimeter. This is gram per cubic centimeter. Gram per cubic centimeter, you remember. Now what happened here? This is in the asthenosphere, if you will see, ये ग्रीजी लेयर, asthenosphere में जो एवरेज तो डेंसिटी है बढ़ जाता है. Here it is 4.3 ग्राम पर क्यूबिक सेंटीमीटर हो जाएगा. 4.3 gram. In the lower mantle, gradually it will increase, and in the lower mantle case, if you will see, in the lower mantle it goes up to 5.5 here. ये है Gutenberg-Wichat discontinuity, you can see. At the Gutenberg-Wichat discontinuity, it goes up to, at 2900 kilometer nearly, 5.5 to 10. 5.5 to 10 gram per cubic centimeter, very sudden. After this देखो 10 to फिर बढ़ेगा 12.3 to 13.5 here, 12.3, 13.5 gram per cubic centimeter at this particular point. There is a change. Finally, if you will go deeper inside, you will find out at 13.6, 13.8, 13.8 gram per cubic centimeter. See here, the density is gradually increasing if you will go deeper inside. Material, I said, here silicate matter more in the upper part. Here magnesium, here iron and nickel. Material will get gradually increase. ये इसको आप याद करिए. I'll tell you about this in detail again. That these are the regions here, you know, it is very, very important to see. Earth interior, if you see, the earth interior is not uniform, it has various discontinuity, and there are lot of variation in it. Please note down. The crust is primarily rigid and comprises less denser silica and or silicate matter and aluminum rich material. Outer shell it is like this. Average the continental crust is around 32 kilometer depth. 30 to 32 kilometer depth, continental crust. The crust are of two types, continental crust and oceanic crust. Continental crust is thick, oceanic crust is thin. Remember, based on its density and composition, the continental crust is less denser, oceanic crust is more denser. Oceanic crust is mostly basaltic. No part of the ocean crust is older than 200 million years. No part of the ocean crust is older than 200 million years. And the ocean crust is comparatively recent as compared to continental crust. But continental crust are thick, less denser. Oceanic crust is thin, more denser. Oceanic crust is very young, recently developed. Continental crust is very old. You will get Precambrian and Archean, very old rock strata in the continent of more than 3.6 billion years old. Continental crust has the rocks of 3.6 billion years old. But oceanic crust doesn't have. Oceanic crust has the rock strata of the oldest one is 200 million years old. No part of the ocean floor is more than 200 million years old. Please remember. Okay. I hope you got it. Now, coming to the crust again, crust comprises, I said, very lighter material. Crust can be divided into two parts, like upper and lower crust. They are separated by Conard discontinuity. Remember, the name of the discontinuity is given as per the scientist who discovered this. Conard discontinuity at around 30 kilometer depth. Below this, if you go, there is a sudden change in the density and composition, and here the continental crustal plate, crustal block where end, and this is known as the Moho discontinuity or Mohor-Bishik discontinuity, very important, where the density of the rock suddenly changes from 2.9 to 3.3 gram per cubic centimeter. There is a sudden change, there is a sudden increase. Please remember this. My friends, सर ये डेंसिटी किलोमीटर याद रखना है क्या? ट्रेंड पता होना चाहिए आपको एग्जैक्टली ये वाला किलोमीटर को, ये जो है ना अप्रोक्सीमेट, तो ये तो याद कर लोगे यार, किसमें ये क्या है परेशानी इसमें बताओ, इसको तो याद करिए, ये तो दिस सीक्वेंस याद होगा, सीक्वेंस अप्रोक्सीमेट डेप्थ पता होना चाहिए. यू डोंट हैव टू गो फॉर डिटेल, बट यस वन थिंग यू मस्ट रिमेंबर, आप ये जो एबनॉर्मलिटी है इसको प्लीज थोड़ा देखिए. विच वन? दिस एबनॉर्मलिटी हियर, देखा आपने 5.5 टू 10, ये याद करिए, ये दोनों याद कर लीजिए 2.9 टू 3.5, 2.9 टू 3.3, 5.5 टू 10, इतना याद होगा, ये दोनों को याद करिए. एंड एस्थेनोस्फीयर के बारे में थोड़ा याद करना पड़ेगा हमें, प्लीज नोट डाउन नाउ. एस्थेनोस्फीयर इज लोकेटेड इन upper mantle. Its thickness is around 200 kilometer, 200 kilometer to 400 kilometer depth. Nearly, you have this asthenosphere. Asthenosphere is a greasy layer. Asthenosphere is a greasy layer. Asthenosphere is made up of euclogite. There is molten materials, very molten metallic minerals are there. Remember, it is an elastic layer. It is an elastic layer. When there is a plate movement, it facilitates easy and smooth movement of the plates. The asthenosphere act like an elastic layer, and it in fact facilitate the gliding of the plate, easy movement of the plates. Please remember this. This is in the upper mantle. Friends, asthenosphere is a soft layer. Asthenosphere is known as low velocity zone. Low velocity zone. My friends, you remember, as per the seismic tomography means by studying the behavior of the earthquake wave inside the earth interior, by studying the seismic tomography, by studying the behavior of the earthquake wave inside the earth interior, we found that earth interior is not uniform. Earth interior has lot of variation. There are three distinct zones of crust, mantle and core. And at nearly depth 200 to 400 kilometer, what happened? Sudden change in the velocity of P and S wave. Earthquake wave hota hai primary wave, P wave. S wave is secondary wave. P wave can pass through. जो earthquake जब भी होता है ना, whenever there is an earthquake, the stress energy of the earth, the crust or the rock strata got suddenly released. The release of this stress energy is in the form of P or primary wave and S or secondary wave. Both are body wave, they can go deeper inside the earth. But P wave, you remember, P wave, if this is the direction of propagation, I mean in this direction the wave will move. It will go like this, to and fro like this. It will go like this. So it is parallel to the direction of the propagation. It will go like this. Got it? It is parallel to the direction of the propagation. P wave. P wave passes through solid, liquid and gaseous all, but the velocity is more in solid. In liquid, it will have significant decrease in the velocity. On the contrary, ash wave is just like you take a rope and fix it in one end and another end you just do it like this. It will go, the wave will move like this. So it is perpendicular to direction of propagation. Okay. direction of propagation. एक साइड पे आप रस्सी को बांध लो और एक साइड से ऐसे करो, वो क्या होगा, वेव जाएगा ना ऐसे. that is perpendicular to the direction of propagation. It will move like this, and this particular type of wave is S wave. S wave is perpendicular to the direction of propagation, my friends, you remember. So S wave and P wave both are, we can, if you are able to map their path and their velocity, you will be able to know about the earth interior. S wave cannot passes through liquid or gaseous matter. So, but a semi-liquid में क्या होगा? Its velocity will be less. At astronosphere 200 to 400 kilometer depth, we found both the velocity of P wave and S wave declines. It means it is a low, that's why known as a low velocity zone. Velocity of both P and S wave declines here, so known as a low velocity zone. Astronosphere is called as low velocity zone. It is an elastic zone. It is a plastic or elastic zone which absorbs the stress of the rock during the plate movement or plate tectonics. Remember this. Now, we will go deeper inside. Here are some fluctuation is there, rapid discontinuity is there. Gutenberg, which are very important discontinuity where sudden change from 5.5 to 10 gram per cubic centimeter. There is a sudden change, great change in the density level you can see here. So, in this case, at Gutenberg, which are Oldham discontinuity, very interesting thing happens. इस पे बाद ये रीजन्स पे सडन चेंज होता है. क्रॉस तो लिखा, आप मेंटल को लिखिए. मेंटल के बारे में फ्यू पॉइंट प्लीज नोट डाउन. मेंटल इज द मोस्ट डायनेमिक जोन. Mantle is the most dynamic zone. Got it? Mantle is the most dynamic zone in the earth interior. There are development of molten pockets, molten material zone inside the earth mantle. These are known as magma chambers, and these are very variable zones also. Magma chambers are there in the mantle. Okay, mantle is the most variable zone. Mantle covers largest area it covers. The mantle zone is responsible for almost all endogenetic phenomena. It is responsible for almost all endogenetic phenomena. What are the endogenetic phenomena? Yes. आप याद रखें, लोअर मेंटल इज नोन एज मेजोस्फीयर ऑल्सो. MESO. मेजोस्फीयर मीन मेंटल, मिडिल. मेजोस्फीयर कहते हैं लोअर मेंटल को. Some scientists use entire mental, but most of these use lower mental. I am telling you, this particular zone is most variable zones, mantle zone. And development of this magma chamber facilitate proper smooth movement of the plates also. By the way, so here the means it is variable zone. Below 2900 kilometer it is found, below 2900 kilometer. The velocity of both P and S wave decreases, but S wave cannot pass through beyond this particular zone, which shows that S wave, I mean the core, outer core is liquid. Outer core is liquid. We came to know outer core is liquid because the wave cannot passes through it. Which wave? S wave. S wave cannot passes through it, which means what? It is a liquid one. If it is a liquid one, S wave cannot passes through it. P wave velocity also declines. Friends, why it is so? Because of the impact of more and more geothermal energy. If you go deeper inside, every 32 meter, there is 1 degree Celsius temperature increases. Now you think about 2900 kilometer. So definitely everything will get melted now. Molten materials, liquid, outer core. But it is found that at this particular, beyond this 2900 kilometer depth, there is a refraction, there is a change in the direction of the path of the P wave and S wave. They change in the medium, that's why. But S wave cannot goes beyond this, it means it is liquid. But P wave pass through it with a slight variation in its path, and it shows that there is a liquid one. But inside this, much below this, in the innermost part, the velocity again further increases, which shows that there is a solid layer. At the earth interior, the middle part, inner core is solid. Please note down about the core. Core is the innermost part of the earth interior. Core is the innermost part of the earth interior. Core. The outer core is liquid due to more impact of geothermal energy. Outer core is liquid due to more impact of geothermal energy as compared to the inner core. Outer core is liquid due to more impact of the geothermal energy. So, S wave cannot passes through it. S wave cannot passes through it, and P wave velocity declines. And P wave velocity declines. Okay. Now coming to inner core. Inner core, from 5.50 kilometer to the center of the earth, inner core, most densest part of the earth interior, densest part of the earth interior is the inner core. Maximum density you see 13.5 to 13.6 gram per cubic centimeter. So it is very, densest part. This densest part of the earth interior, nickel and ferrous rich material, is in solid condition. Why? Because of more impact of pressure than the geothermal energy. Please note down. More impact of the pressure than the geothermal energy. Because more impact of the pressure, so it will never allow the particles to move freely. Because it cannot allow the particles to move freely, so it acts like a solid object. It is solid because it cannot allow, it will not allow the particles to move freely because of more and more pressure. You remember this. Inner core is solid because no doubt temperature is more here. Temperature, impact of temperature and impact of pressure, if you will see, impact of pressure exceeds the impact of temperature. Because the impact of pressure is more, that's why it will not allow the particles to move freely. So it is solid in nature. Got it? So inner core is solid. We are discussing about the Earth's interior. Let's look at a few important things. I said, because the Earth interior is not homogeneous, there is heterogeneity. That's why the earthquake waves, they refracted back or they deviate from their normal path. If I will draw a diagram showing this, if this is the Earth here, we found that from the Earth interior, if any earthquake wave is coming in this way from here, right? If this is S wave cannot pass through this one again. S wave is coming or from here, it is going in different direction, but okay. It indicates what? It indicates that there is the presence of this is the liquid one, so it cannot passes through it. This is liquid one, so the ash wave cannot passes through it. It is from 105 degree to 105 degree. There is, in this way, in this particular region, there is no such any ash wave or ash wave shadow zone. Okay, because ash wave cannot passes through the liquid, that's the cause. But we found one more thing, that ash wave velocity is comparatively less at a particular level maybe because of here at a particular level there is a ash wave velocity is less, let us say at this particular level, as well as the P wave. This is known as the asthenosphere, zone of asthenosphere. Here it is completely vanishing, that's why liquid. But in very interestingly, if it is ash wave it's okay, but if it is P wave, अगर ये P wave हो गया तो कैसा होगा देखो, it is ash wave it's okay. If it is P wave, what will happen, you just see here. In case of P wave, अगर ये P wave होगा तो यहाँ से रिफ्रैक्शन होके और ऐसे होके ऐसे जाएगी. Refraction, double refraction will be there. Now I can show you this in this diagram here. Look at here. The P wave in this case see here, P wave यहाँ पे ऐसे गया, you can see this, and here this is the shadow zone, P wave shadow zone. P wave shadow zone, you got it here. P wave shadow zone. This is the P wave shadow zone. So this transformation is because of change in the medium. Here also same way we will have like this. This is the shadow zone, P wave shadow zone. Because of change in the medium, refraction is there. But here again, you see, here again, like this, so it can come here, but not in this particular part. At a particular, no direct P wave, no direct P wave. So P wave shadow zone. 105 to 145 होना चाहिए. 145 is the standard one. 105 to 145. 140 नहीं, 145 होगा ये. 145 standard one. 105 to 145 P wave, and 105 to 105 is S wave, which I have already shown it to you. 105 to 105 is S wave. So this is because of what is there? This is primarily due to the differential composition inside. By the way, because of this, you know, this is liquid outer core, metallic one, and this is solid inner core, solid inner core, solid inner core is solid, outer core is liquid. Because of the solid inner core, what is happening here? Inner core is very solid, due to which very important thing happens here. Because of the solid inner core, which is metallic one, the earth is moving. That's why what is happening, like a dynamo it is arcing, and that's why we have a magnetic field of the earth. Earth magnetic field also you are having, north and south magnetic field, geographic north pole, geographic south pole. Okay, you see here the magnetic field of the earth is primarily because of what? It is due to primarily the geographic the magnetic field of the earth is primarily due to this cause only. Primarily it is due to the differential movement of inner core and rest of the earth. Recently you must have came across some in newspaper that the earth inner core velocity is gradually decreasing. Yes, it will have. I hope you will able to appreciate it now and you will able to answer these things. Okay. So, let us look at one more topic here. This is about your, this topic is about rock, another chapter is rock. Remember, rock is the aggregates of minerals. Different minerals while get aggregates of minerals called as rocks. There are three types of rocks. One rock is known as igneous rock. Igneous rocks are they generally formed because of volcanic eruption and magmatic intrusion. Igneous rocks are formed due to volcanic eruption, derived from magmatic deposits and its cooling leads to the development of igneous rock. It is known as a primary rock. Primary rock because of what? It is known as primary rock because almost all other rocks are derived from this rock. Igneous rock is primary rock because it is almost all other rocks are derived from this rock only. That's why it is called as igneous rock, is primary rock. Igneous rock is very hard, rigid, mostly impermeable, mostly I have written. So, less affected by chemical weathering. It is less affected by chemical weathering because for chemical weathering we need medium, the material, the mineral, the liquid or the water should percolate inside, a chemical should go inside. Most of the cases water, पानी अगर नहीं जाएगा रॉक स्ट्रेटा के अंदर तो कैसे रिएक्शन होगा? केमिकल रिएक्शन. Water should percolate inside, then only it is possible. So, porosity and permeability plays a very important role here. Porous and permeable rock only can do this. Okay. So, these are primary rock, rest all other rocks are derived from this. So, it is least affected by, less affected by क्या लिखा मैं? Less affected by chemical weathering. You know what is weathering? आपको weathering क्या है पता है? वो chemical weathering, or do you need any explanation on this? Yes. Do you know what is weathering, or do you need any explanation on this? Please be quick. Weathering क्या है पता है कि नहीं है? एक बॉक्स के अंदर लिखो, नहीं तो disintegration and decomposition of the rocks in situ. In situ mean in a fixed place. In a fixed place. Disintegration and decomposition of rocks in a fixed place is known as weathering. Disintegration and decomposition of rocks Your friend is asking, sir, does ash wave passes through gas medium? No. In situ mean in a fixed place, in a fixed place. Disintegration and decomposition of the rocks in situ, in a fixed place, is called as weathering. अच्छा ओके ओके ठीक है वेदरिंग का. सो वेदरिंग जो होता है ना, कोई भी यू कैन कीप ए पर्टिकुलर मटेरियल इन ए पर्टिकुलर रीजन. यू कीप आपका जो चेयर और टेबल है ना, यू कीप इट इन योर रूफ टॉप फॉर 5-6 years. आफ्टर दिस यू गो एंड जस्ट give pressure like this, it will collapse because the bonding of the particles between them gradually decreases. It become weak. Disintegration, it will start, and decomposition of the rocks in a fixed place is called as weathering. Weathering are of two major types. One is physical weathering. Physical weathering. Second one is chemical weathering. Third one is biological weathering. Biological weathering. Chemical, physical and biological. Three types of weathering. Chemical, physical and biological, three types of weathering. Physical weathering are due to temperature, and due to physical weathering, it is due to physical factors like temperature, pressure, humidity, etc. Chemical weathering is due to chemical action. Example, carbonation, oxidation, you know that roasting of iron. Example है, you can see like roasting of iron. Iron roasting होता है ना, roasting of iron is a very good example. Roasting of iron is the best example. Chemical action, carbonation, oxidation. Biological weathering by plant and animal. Disintegration. By plant and animal, if it is there, it is biological weathering. फिजिकल फैक्टर्स से जो भी होगा फिजिकल वेदरिंग है, और टेम्परेचर प्रेशर से. एग्जांपल आई विल गिव यू द बेस्ट एग्जांपल. इन द डेजर्ट एरिया व्हाट हैपेंड ड्यूरिंग द डे टाइम टेम्परेचर इज वेरी हाई, इन द राइट टाइम टेम्परेचर इज वेरी लेस. So because in the daytime temperature is very high, the rock strata expand. During the night time temperature is less, so it is contract. Contraction, expansion, contraction, if this will get repeatedly, then there will be development of cracks in these rock strata. The development of cracks you will find out. This development of cracks in the rocks, this is called this physical weathering. Small छोटे छोटे particles हो जाएंगे, and this leads to mostly sandy terrain in the desert. Desert में sand आता है इसलिए. In the desert region you have sand mostly find out because of what? Due to the action of physical weathering. You got it now? So example of physical weathering I will give you. Physical weathering के example. Physical weathering example is the sandy profile development over the arid and desert climatic region. Climatic regions. Arid and desert climatic region has this physical weathering. Arid and desert climatic regions. Okay. Sandy profile. because of expansion and contraction of, as I said, the rock strata. Due to high temperature during the daytime and you have low temperature during the night. In the daytime it expands, in night it contracts, contraction and expansion this continue, and this leads to the development of sandy profile development over the arid and desert climatic region. Best example ये है. So this is can be another one, exfoliation, exfoliation, exfoliation mean onion peeling weathering. In this case what happened, like onion, you peel up the onion layer by layer, there will be weathering. Weathering will take place in layer by layer manner. The best example, if there is load, a particular region has more rock strata with more weight, load ज़्यादा है. When the rock strata got removed from that region, the load became reduced. What will happen? वो क्या होगा, swelling हो जाएगा ऊपर surface में, and layer by layer it will be weathering. This is called as exfoliation or onion peeling weathering. I hope you got it. Onion peeling weathering. Onion peeling weathering. Best example, Kishan ki laddu. There is a such type of rock you will find in Karnataka. Okay, near Mandya, Mysore Mandya. उस पे एक रॉक है, ऐसे पूरा राउंड है. This is like exfoliation के वजह. Exfoliation leads to all these. Exfoliation because of release of the pressure. Because ये बड़ा heating and thawing वजह से क्या हो गया? Physical weathering is due to alternate heating and thawing. Exfoliation is due to change in the pressure condition of a regions. Light weight हो गया तो ऐसे exfoliation होगा वहाँ पे. Onion peeling weathering. Physical weathering are like this. Now physical, always remember weathering leads to helps in erosion also. Now third type of weathering, second type of weathering is chemical weathering. Chemical weathering, my friends, chemical weathering, as you know, chemical weathering, best example of chemical weathering you will find out is the rusting of iron. Rusting of iron. You have cavity formation in limestone rich regions. Cavity formation in limestone rich regions. You have cavity in the limestone rich region. This is also a very important factor. Cavity formation. आप ना दांत में जो केविटी है वो भी है, वेदरिंग है. एंड वेदरिंग लिस्ट इरोजन कभी ये बाहर आ जाएगा, देखो. Limestone rich regions, I said cavity formation. These are chemical weathering. Then you have biological weathering. Third type I said biological weathering. Biological weathering. Particular regions with more and more, as you know, more and more plant and animal action. So you must have seen, if anywhere earthworms are more, earthworm can change the pH value of the soil. Earthworm in a region can weaken the soil. It can change the pH value of the soil. A बहुत important example है earthworm. The best example is earthworm. Earthworm देखा है ना? Earthworm can change the pH value of the soil. And this is the best example here, earthworm ki, wherever is there. Now we have tree. Which tree? People tree. People tree or banyan tree. In a region you have banyan tree or people tree. So the regions of this region, leaves, they will change the pH value. pH value को change कर देते हैं ये. They will change the pH value. And they will have a different rodents in somewhere there. Rodents है तो भी वो चेंज कर देते हैं एक जगह पे soil profile को. And you must have seen in the old temple, if somewhere you have old temple is there, old building, fort structure is there, like when the tree roots goes inside, it will weaken the entire wall and it collapses. Best example, So weathering is like this. So weathering helps in quick erosion. इरोजन में ये फाइनली काम में आएंगे. Weathering leads to erosion. Weathering leads to erosion. Please remember this. You got it what I am saying? Weathering and erosion are very important, and this is like here. So rock formation में, in the rock formation, weathering plays a very important role also. And igneous rocks are resistant to chemical weathering. Why they are resistant? This is all about weathering. I hope you got it. Weathering में समझते तो आया. You got it? My friend who was asking for this weathering part, नहीं समझ में आया क्या? You got it? देखो, dandruff in your hair is best example of weathering, my dear. And weathering leads to erosion. Remember? आप समझ में आ गया होगा. Now I hope you got it. Fine, very good. So look at here, igneous rock, very hard, rigid, mostly impermeable rock, so less affected by chemical weathering. Igneous rock is less affected by chemical weathering because porous is less porous. Okay. So as I have just mentioned about this is very, very important to know that igneous rock are less erosion wise effect. If you look at, it is less. Resistant होगा weathering से. Physical weathering will be more, chemical weathering is less. Igneous rock में. Igneous rock are of different types. You know, there are two major types of igneous rocks. How will you memorize this? कैसे type का? आप देखो, if this is the earth surface here, okay, if this is the earth surface here and you are here, right? Igneous rock from the earth surface towards up, this is known as extrusive igneous rock. Extrusive igneous rock, and which are inside is known as intrusive igneous rock. Intrusive igneous rock. So there are two types of igneous rock, extrusive and intrusive. If the igneous rock is formed over the surface, it is extrusive. Upper surface में है तो extrusive है. Someone is asking, sir, difference between weathering and erosion. भाई, weathering is disintegration and decomposition in situ. Erosion is removal of the rock by different agents. Flowing water, running water, you have like wind, we have glacier, we have sea waves. When transportation involved, this is erosion. Remember, weathering doesn't include transportation. Weathering is in situ, erosion is ex situ. Fine. Okay. Extrusive igneous rocks and intrusive, two types of igneous rocks, my friend. You remember, नाम पूछता है ये एग्जाम में. What are the extrusive? दो ऊपर सरफेस में जो आया वो एक्सट्रूसिव हुआ, जो इनसाइड रहेगा तो इंट्रूसिव हुआ. There are two types of igneous rocks. I hope you know it. Even if there are different igneous rock form also. Let us say here is a volcano. Okay, it is a volcano, and here in this volcano, this is the magma chamber. From the magma chamber, there is volcanic eruption. यहाँ से magma will go out. From here, magma go up, and here it is flowing down. So ये जो बाहर जो ये बनाया, ये एक्सट्रूसिव हो गया. एक्सट्रूसिव रॉक में ये एक्सट्रूसिव में क्या क्या है, इससे ही बनेंगे लॉट ऑफ टाइप ऑफ रॉक्स यू हैव. यू रिमेंबर ओनली बार याद हो जाएगा. वेरी इजी टू मेमोराइज, इज नॉट इट? बार, देन यू कैन सी DGPG गैब्रो, याद होगा ये. प्लीज रिमेंबर दिस नेम्स. बार, DGPG गैब्रो. DGPG गैब्रो इज इंट्रूसिव रॉक, extrusive is bar. Bar is basalt, andesite and rhyolite. याद होगा. I hope you will able to memorize. On the surface you will find out mostly basalt, andesite and rhyolite bar. But inside this there is cooling and there is formation of diorite, granite. You know about granite? This is the granite here. Granite always you will find it over the surface. Inside this you will find out intrusive diorite, granite, peridotite. Then you have gabbro, then you have granodiorite. आप देखो ये सब जितने भी है ना, ग्रानोडायोराइट, पेरिडोटाइट, गैब्रो, ग्रेनाइट, डायोराइट, basalt, andesite, rhyolite, all these, like you know, these are the intrusive, these are the igneous rock. One here it is extrusive, this is intrusive. I am not talking about the igneous rock form, I am talking about only types of igneous rocks. Erosion due to dandruff is which type of weathering? Biochemical weathering. Biochemical, special case है ये, biochemical weathering. Okay. But sometimes you have rashes, sometimes you will have like you know cracks, like you know faulted lips. This is physical weathering. Winter में हमारा body lips क्यों crack आता है? ये best example है weathering का भाई. ठीक है? Practical example I have given. I hope you got it now. Okay. Basalt, andesite, rhyolite, best example extrusive rock. Diorite, granite, peridotite, gabbro and granodiorite, best example of intrusive rocks. If both of them they got cooled down, which one will have more finer texture? जो जल्दी ठंडा होगा, the one which will get cooled down very quickly. Which one will cool down? Extrusive. Extrusive will cool down very quickly. That's why extrusive rock will have finer texture than the intrusive one. So intrusive have coarse grain. Okay. So very important. You must remember the crystalline texture. Crystalline is intrusive rock. And mostly amorphous. I mean finer one is extrusive rocks. Finer grain, extrusive rocks. Hope now it is clear to you all. During the volcanic eruption, I will tell you what are the different forms of igneous rock. Form. The batholith, phacolith, locholith, seal, dike. वो आगे करेंगे, अभी नहीं. आप ये इसको याद करो in terms of the rock type at least. Hope you got it. This is a very important point here, and many times they are asking question even igneous rock. Igneous rocks, I hope you got it. Igneous rock can be formed from any rock due to melting, high temperature. Next type of rock is sedimentary. अच्छा, igneous rock के साथ क्या होगा बताओ? What type of metallic mineral will be more? Igneous rocks has, these rocks are not found in layers. They are generally found homogeneous ये रहेगा, layer by layer नहीं होंगे. First point. These rocks are not found in layers. Layer by layer you will never get this. These rocks are never found in layers. What else? These are mostly rich in the metallic minerals. They are very rich in the metallic minerals. You remember this, they are rich in metallic minerals, my friends, please remember. They are rich in metallic minerals, whether it is iron ore, whether it is cobalt, whether it is copper, whether it is bauxite, everything, mostly igneous rock. I hope you got it. Igneous rocks. One thing to be very clear here, that igneous rocks, no doubt very strong. They are very rigid. Many cases they are very rigid. So wherever you have faulted topography, faulting in most of the regions are associated with igneous rock types. Remember. So this is one part here. Mostly rich in metallic minerals, I said. Okay, fine. Let's look at now another point, please. Let us see. Igneous, no? In fact, the surface rock, igneous rock, depends on nature of the magma. Acidic magma or basaltic magma. जैसा magma है, इसी हिसाब से rock type will differ. Their composition will differ. Based on the composition of the magma, composition of the rock differ करेगा. So we will have like their characteristics or may also differ. In volcano chapter we will discuss in detail about that. By the way, another igneous rock से जो भी plateau बने हैं, volcanic plateaus are there. Major plateau of the most of the plateau, volcanic plateaus are there. Major plateaus of the world with igneous rock. Major, देखिए igneous rocks and its development and its property depends on the composition of magma. Composition of magma. Basaltic lava generally flows very quickly and covers large area, forming major plateaus over the earth surface, earth surface. There are major plateaus over the earth surface because of basaltic lava. Basaltic lava has more temperature. In fact, they move very quickly. It flows very quickly. Because it flows very quickly, it covers large area. Its temperature is much high. Basaltic lava temperature is much high. You remember, बहुत ज़्यादा temperature होता है. Basaltic lava has an average temperature which is more than average temperature जो basaltic lava का ये रहेगा 1100 डिग्री सेल्सियस. Basaltic lava is generally more than 1100 degree Celsius temperature. It flows very quickly. And remember, it forms dome shaped relief and plateau. It generally develops. Dome shape plateau, क्योंकि ज़्यादा एरिया कवर करेगा तो accumulation नहीं होगे. Because there is no accumulation of the lava at a particular place, so you will never have a conical volcano. You will have a dome shaped or maybe a plateau you will find out in these regions. You see, this will be like this. You see here, it will have a huge area with ऐसे होगा cover करके. This may cover large area. You will never get anywhere like conical volcano. You will have a dome shaped plateau relief or plateau. Dome slab mountain and plateau may be formed. Best example of this, I can tell you, the best example worldwide, if you'll see, we have so many examples worldwide. The best example, if I'll go for, best example, number one, our Deccan Plateau, my friends. Deccan Plateau, कहाँ है Deccan Plateau? India. Second, do you know about our Ethiopian highland? Ethiopian highland, do you know about this? Ethiopian highland, best example in Africa is the best example here. Ethiopian highland, my friends. Deccan Plateau. डू यू नो मैं एक डायग्राम ड्रॉ कर दूं बेस्ट रहेगा याद रख लेना प्लीज माई रिक्वेस्ट टू ऑल ऑफ यू प्लीज डू रिमेंबर दिस आप जो है ना याद करिएगा प्लीज आप पूरे को ये नहीं करना है बट ये डेक्कन प्लेटू है ये डेक्कन प्लेटू ये जो रीजन्स है ना दिस रीजन्स मोस्टली ये डेक्कन ट्राप है दिस डेक्कन प्लेटू रीजन्स दिस इज डेक्कन प्लेटू आप बोलेंगे सर इधर क्यों नहीं है ये डेक्कन ट्राप वाला एरिया में दिखाया ओके यू कैन हैव सेम वे यू कैन सी आप में ना याद हो जाना चाहिए ये यू शुड एबल टू मेमोराइज दिस थिंग्स टुडे इज फाइनल यू थिंक एंड प्लीज डू दिस टू स्टडी दिस प्लीज डू रिमेंबर दिस प्लीज लुक एट दिस यू विल फाइंड आउट देयर आर रीजन्स हियर ये क्या है ये देखो नाउ दिस रीजन क्या ये इथियोपियन हाईलैंड Ethiopian highland you have Drakensberg region Patagonia Plateau Parana upland this is Australia here you have this is here is a region known as this is Kimberley Plateau Kimberley Plateau Kimberley Plateau we can see this Okay, is it audible now? Is it audible now, my friends? Okay. So these are the most important few plateaus which are volcanic or which are having igneous rock. ये याद होगा क्या? They are asking question many times. Which one among the following is having igneous rocks? So I have just given this. Hope you got it. Okay. So as I have just mentioned about these plateau and these things, hope you got it. This is here is some of the important areas which I was supposed to tell. Let us look at now sedimentary rock. Sedimentary rock. These are weak and found in layers. These rocks are generally weak and found in layers. Develops due to continuous deposits of the weathered material of the weathered and eroded materials. It develops due to continuous deposits of the weathered and eroded materials. They develop due to continuous deposits of weathered and eroded materials. Okay, they are found in layers. So these are weak soil and greatly affected by chemical weathering. They are greatly affected by chemical weathering. They are greatly affected by chemical weathering. Okay, they are greatly affected by chemical weathering. Right. Okay, sedimentary rocks. Example of sedimentary rocks. Example you can see. अगर पोरस और परमेबल ज्यादा होंगे तो इसीलिए कोल इज ए सेडिमेंटरी रॉक. सैंडस्टोन, sedimentary rock, sandstone, coal, limestone, dolomite, chalk. All these are sedimentary rocks here. Chalk is a sedimentary rock. What else? Is gypsum a sedimentary rock? Dolostone, gypsum. Okay, even petroleum is a sedimentary rock, you remember. Petroleum is sedimentary rock. Please do remember this. Petroleum. Okay. Petroleum is also sedimentary rocks here. Right. So these are certain things. Okay. After sedimentary rock covers largest area over the earth surface. Almost or major area of earth surface is covered with sedimentary rocks. Okay. So this is covering the largest area. Over the earth surface, if you'll see, area was largest area. Volume, if you look at weight wise is largest one. First rank will be igneous rock. Area coverage wise, this one, sedimentary rock, you remember. Okay, I hope you got it. Next one is metamorphic rock. These rocks can be developed due to there is a change in its arrangement of particles. Here, rearrangement of particles takes place due to the impact of temperature, pressure, or both of them. ये दोनों को भी होता है, both temperature and pressure also. Only temperature, only pressure, or both? Here, rearrangements of particles takes place due to the impact of temperature, pressure, and or both. So there is rearrangement होगा, कुछ जगह पे तो chemical compositional changes भी होते हैं. There are two major types of metamorphism. देखिए, एक होता है because of temperature is dominant one, another one is because of pressure is the dominant one. So two types, but they are intermediate also. Let us look at rock में metamorphism से pressure temperature से होते हैं. So metamorphism are of two types मैंने कहा. Let me note it down here, so it will be easy for you. Metamorphism is of two types. Thermal metamorphism, dynamic metamorphism. Contact metamorphism, regional metamorphism. Can you see this? Please note it down. Metamorphism is a process in which there is rearrangement of the particles takes place. Right? If temperature is the dominant one, then it is thermal. If pressure is the dominant one, then it is dynamic. Remember this. Now, कॉन्टैक्ट मेटामॉर्फिज्म कहां पे होगा? जहां पे वोल्केनिक इरप्शन है. रीजनल मेटामॉर्फिज्म कहां होगा? जहां पे प्लेट टेक्टोनिक्स है, प्लेट मूवमेंट. Dynamic only because of compressional force, compressional pressure. Here it is plate tectonics में compression plus compression and subduction. कंप्रेशन से क्या होगा प्रेशर, सबडक्शन से क्या होगा टेम्परेचर, दोनों का रहेगा. वोल्केनिक में यहां पे हो जाए केवल टेम्परेचर प्लेज ए वेरी इंपॉर्टेंट रोल. आप देखो अगर किसी भी मिनरल है, रॉक है, उसे टेम्परेचर ज्यादा, इफ एनी रॉक इज देयर एंड मोर इंपैक्टेड बाय टेम्परेचर ड्यू टू volcanic eruption. Volcanic eruption is there near lava chamber. You have development of a rock, that is contact metamorphism. But if there is plate movement, or if there is like a movement of the plate, compression will be there, as well as if there is like two plates, oceanic and continental plates are moving. There are differences in their density, as I was told you about oceanic crust and the continental crust. Continental plate has more continental crust, oceanic plate has more oceanic crust. Oceanic plate is heavier, it goes down, continental plate is lighter, it ride up, and there you have, when the one plate moved down, and another one is pressure is there, both compression and, because it goes down, it will have temperature also, regional metamorphism. But near volcanic regions, you have mostly contact metamorphism. But whenever two continental plates are meeting with each other, convergence of the plate is there, but there is no subduction. दोनों का density समान है, pressure is equal. If the pressure is equal as well as density of rock is almost equal, in that case, because of more and more pressure, what will happen? You have crustal deformation. Here is known as dynamic metamorphism. Please remember this. Dynamic metamorphism it is. So this type of metamorphism is also responsible for, okay, this type of metamorphism also responsible for different type of rock, metamorphic rock. Vanshika is asking, sir, can any possible by given for why the majority of the area of earth surface is covered by sedimentary rock? It is because the primary rock even, that is the igneous rock even, subsequently got eroded and weathered and form a thin layer. No part of the earth's surface is free from weathering and erosion. If there is no erosion, there is weathering, you remember. Inside the ocean, ocean has maximum area, and in the ocean whatever is dead organic materials, dead oceanic shell and oceanic plant and animal, they are deposit also sedimentary rock, okay. Majority part of the ocean has ooze, OOJD. Ooze mean what? Ooze is the deposits of sediments from the dead marine organism. Okay. Is it clear, Vanshika? Because ocean cover larger area first, and second is in fact no part of the earth crust is free from weathering and erosion. There is continuous weathering and erosion, so there is continuous formation of this. Very thin layer will have. Even in the desert you have sand is sedimentary, loess is sedimentary. In the even the snow covered is sediments, they are sediments, snow is sediments, okay. Again there is like, if you look at it, technically speaking, most part of this is there sedimentary rock covered. Okay, please look at here again, metamorphism, two types, thermal and dynamic, contact and regional, I have just said. So let me go for this in detail, some of the most important things. I will give an example. Ek example I will give you. You know about Taj Mahal, okay? Taj Mahal sab log dikhaya bhi hai. Now history you have studied in the beginning and you know it. Taj Mahal is made up of what type of rock? Metamorphic rock. From where? Can anyone tell me? From where you got this? Taj Mahal, the rock we got it. We have constructed the Taj Mahal with the metamorphic rock, marble. So marble कहाँ से लाया गया? Can anyone tell me? Yes. My friends, please do participate here. Come on. रॉक फॉरेस्ट सैंडस्टोन को देखो. इफ इट इज सैंडस्टोन, it is a limestone, if it is granite, if it is graphite, sandstone will form quartzite, quartz. Limestone is from marble. Granite will form gneiss. Graphite will form diamond. Shell, schist, clay, slate, clay, slate, schist, shell, schist. We are saying clay and shell are same thing, slate and schist said almost equal type you are saying. But these are the things here. Makrana marble, Rajasthan you said, fine. Is these two are correct? आप ये दोनों करेक्ट है क्या? देखो बताओ मुझे. अच्छा, मेरे क्वेश्चन है लाइमस्टोन टू मार्बल, मार्बल बने and a Makrana marble from which you are getting. Best quality of marble in India is Makrana marble, fine. Makrana marble is the best quality of marble in India, fine. Now, you have seen about Italian marble. What is the difference between these two? Italian marble and Makrana marble. Which one has more glaze? इंडियन मार्बल और इटालियन मार्बल में कोई इसका ग्रेज तो ग्लेज ज्यादा है, चमकता है कौन सा ज्यादा? Why people are importing from Italy? देखो इटालियन मार्बल, देखिए both are metamorphic rock, but remember the Italian marble are formed due to what is that? Part of regional metamorphism. Indian marble is primarily due to dynamic metamorphism. If temperature and pressure both are there, both the impact of temperature and pressure you will get in Mediterranean Sea region. You know Mediterranean Sea region has two plates, they are meeting here. African plate and Eurasian plate both are meeting there. And there are volcanic eruption here. Mount Vesuvius, Mount Etna, Stromboli. You know about this? All the Mediterranean region is known for volcanic eruption. We have compression also there, folding is there as well as pressure is there as well as temperature. That's why the particles are of different types arrangement. In case of India, during the, this is like faulting and subsequent formation at that time. Because of Narmada fault line, Narmada fault it developed during the Narmada fault, and earlier during the Aravalli formation, we have formation of this. And आपको बता दूं, marble is of different types here, grade is different, that's why. Friends, type of metamorphism will determine the glaze and the quality of the rocks. And this is what is because of the thermal metamorphism to some extent. The regional metamorphism particularly is better for metamorphic rock, giving better glaze than this dynamic pressure. आपको ये जो बताया सैंडस्टोन, क्वार्जाइट, मोस्टली बिकॉज ऑफ pressure. Pressure is the most important factor here. It is a part of what is this then? Dynamic metamorphism. ये मोस्टली इंडिया में जो मिलता है डायनेमिक मेटामॉर्फिज्म में होते हैं. इंडिया में ये भी डायनेमिक है. एंड ग्रेनाइट टू नीश इज मोस्टली इट इज ग्रेनाइट टू नीश. यू रिमेंबर दे आर प्राइमरली बिकॉज ऑफ ईदर कंटैक्ट और थर्मल. कंटैक्ट इज मोर. आपको बुंदेलखंड नीश जो है, इन बुंदेलखंड इन इंडिया, बुंदेलखंड नीश, it is primarily, it is thermal, it is contact metamorphism. Contact metamorphism ये रीजनल नहीं है, contact है. ग्राफाइट टू डायमंड इन इंडिया इज मोस्टली रीजनल मेटामॉर्फिज्म से हुआ है. क्ले ये सब प्रेशर से होता है, मतलब डायनेमिक मेटामॉर्फिज्म है. माय फ्रेंड्स, यू रिमेंबर द टाइप ऑफ मेटामॉर्फिज्म एंड सब्सिक्वेंटली व्हाट टाइप ऑफ रॉक दे आर फॉर्मिंग. इफ यू विल सी, it is very conceptual things. They can ask the question goes up to this extent. Even in India, you will get this type of rocks primarily based on pressure and temperature, and both of them how they are exercising their impact on the entire rock strata. Fine, I hope you got it. Sandstone mostly आपको पता है, in Madhya Pradesh there is a place known as Panna. Panna is known for diamond. Diamond in Panna regions is primarily because of regional data. You know about Malwa Plateau. In Malwa Plateau is located. It is Malwa Plateau is volcanic one. The volcanism and pressure faulting because of Narmada faulting, both are responsible for this. My friend, you remember these are different types of rock type. They change. The impact of pressure and temperature is responsible for variety of rock, as I have just said like this. Are you getting the things? Are you getting this? Is okay? I hope if at all any question you will get from rock type, you will now able to deal. Yes or no? कोई भी क्वेश्चन आएगा रॉक का, कर लेंगे क्या? Is it possible? Can I believe? Can I trust you that you will able to do the things? क्या हम आपसे ऊपर इतना उम्मीद कर सकते हैं कि आप कर लेंगे इसको? रॉक टाइप. Is it there? Yes or no? आप लोगों से मेरा उम्मीद है कि कर लेंगे आप लोग. इफ नॉट देन लेट मी नो, बिकॉज बेस्ड ऑन दैट आई विल हैव टू डू. रॉक टाइप इज वेरी वेरी इंपॉर्टेंट फॉर योर एग्जाम. लेट मी टेल यू माय फ्रेंड्स, रॉक टाइप कैन बी आस्क्ड. ओके, इंट्रूसिव क्लोरिन से रायोलाइट, एंडीसाइट, गैब्रो, ये सब चीजें जो anyway there is like a formation of different rock based on this. I hope you got it. Any question on this, please let me know. कोई क्वेश्चन है क्या इग्नियस रॉक के ऊपर, मेटामॉर्फिक रॉक के ऊपर एंड ऑल? शेल स्लेट बनता है, सिस्ट बनते हैं और नीश भी बनते हैं. आपको बता दो, अंडर सर्टेन कंडीशन ये यहां से नीश भी बन सकते हैं. देयर आर केसेस ऑल्सो वी फाउंड. दीज आर एक्सेप्शनल केस. जियोलॉजी में कोई है तो पढ़ सकते होंगे. यू मस्ट हैव स्टडीड इफ एनीवन फ्रॉम जियोलॉजी. ये क्या लिखा है? सर आई क्यू शरीक और सर आई वन क्वेश्चन, क्या लिखा है भाई? एनीवन हैविंग एनी क्वेश्चन टेल मी. नहीं, इट इज योर नेम शरीक. ओके माय फ्रेंड्स, लेट अस सी नाउ ए वेरी इंटरेस्टिंग थिंग, रॉक साइकिल. कैसे है? इन योर एनसीईआरटी बुक वेरी क्लॉमजीली इट इज गिवन लाइक वेरी डिफिकल्ट वे, बट यू सी सो इजी दीज आर. Example of this, igneous rock, metamorphic rock, this is sedimentary rock. Melting. Melting of any rock leads to metamorphic rock. Melting of same rock will form metamorphic. Okay. Weathering, erosion and deposition. Weathering, erosion and deposition. Weathering, erosion, deposition. Pressure and temperature. Pressure and temperature. Both are responsible for development of this pressure and temperature. Combined effect of pressure and temperature may leads to this. Sir, please quickly go through sedimentary rock again. Okay, okay. Your friend is asking, so let me do. Sedimentary rocks are generally weak and found in layers, develops due to continuous deposition of weathered and eroded materials, weak soil and greatly affected by, these are weak soil, weak zone karo, these are weak rocks generally and greatly affected by chemical weathering as well as physical weathering, both are there. Chemical weathering is much more. So it covers largest area. ये जो है ना, coal, sandstone, limestone, dolomite, chalk, petroleum, all these are best example. Major area of earth surface is covered with sedimentary. If you look at the entire coverage, thin layer but largest area you have. Thin layer but largest area, sedimentary rocks. We have glacial sedimentary rocks, we have fluvial sedimentary rocks, we have sedimentary rocks of different type, glacial till pata hai na, glacial moraine, all these are also. Rock salt is a sedimentary rock, organic rock is there, inorganic rock is there. यहाँ पे rock salt भी होगा, rock salt, or the salt is a sedimentary rock, you know it. I hope you are well aware about this. Aqueous rock बोलते हैं, sedimentary rocks, argillaceous, CEOUS, argillaceous sedimentary rock. किसको कहेंगे? Like if it is deposited by, if it is formed by or developed by or developed due to action of water. पानी से अगर कुछ भी होता है, इसको बोलते हैं आर्गिलासियस. Clay, sand, silt, clay are very good example of argillaceous. Okay. Conglomerate, mud or shell, they are mud or shell. Conglomerates, conglomerates भी होगा ये. Conglomerates, shell or mud, they are also comes under this. और क्या चाहिए बोलो भाई, क्या हुआ आपको? क्लास्टिक रॉक है, नॉन क्लास्टिक है, वो सबको ऊपर डिटेल जाने का जरूरत नहीं है, नहीं आते हैं क्वेश्चन, इसीलिए हमने डिटेल में वो नहीं गया. मेंस के लिए ठीक है, प्रीलिम के लिए दिस मच इज मोर देन सफिशिएंट फॉर यू. इज इट ओके? डन? एनीवन हु आस्क्स मी, प्लीज क्विकली गो थ्रू द सेडिमेंटरी रॉक. आई हैव गन. इट्स ओके, फाइन. नाउ आई विल गो फॉर मेटामॉर्फिक रॉक. ये बोला मेटामॉर्फिक रॉक से ये हुआ. रॉक साइकिल पे आओ. देखो इग्नियस रॉक व्हेन मेल्टिंग टेक्स प्लेस इग्नियस बनेगा. सेडिमेंटरी रॉक से हाई टेम्परेचर मेल्टिंग इग्नियस बनेगा. मेल्टिंग ऑफ मेटामॉर्फिक विल मेल्टिंग igneous rock. After cooling down, definitely it will form the same igneous rocks. If there is weathering and erosion of any rock, weathering and erosion of metamorphic rock, weathering and erosion of igneous rock, or even weathering and erosion deposition of the same sedimentary rock, it will have again sedimentary rocks. इसमें क्या है? And metamorphic rock, if there is pressure and temperature of igneous, metamorphic, sedimentary होगा metamorphic, even metamorphic became metamorphic. You want any, I hope you need some example of metamorphic, I think. देखो आप यहाँ, ये जो है हमने बनाया sandstone to quartzite. Sandstone is sedimentary, quartzite is metamorphic. Limestone is sedimentary, marble is metamorphic. Granite is igneous, igneous is metamorphic. Graphite is sedimentary, diamond is metamorphic. Clay is sedimentary, slate is metamorphic. Shell is sedimentary, schist is metamorphic. कुछ जगह पे क्या होता है, मैंने जैसे कहा था, you have this what you call shell. Shell will turn into slate. Slate will turn into schist. Schist will turn into gneiss. There are certain cases we found like this also. देखो metamorphic became metamorphic, chain of metamorphic rock, my friends. Under certain condition it is found, and very rare case. You got it? That's why I have written metamorphic became metamorphic. Metamorphic became metamorphic. Is it okay? Now it is clear to you? Be quick on explaining, please. If you have any problem, let us know. Yes. My friends, those who are from West Bengal, Karnataka, Maharashtra, there are few friends from Maharashtra, please let me know. My friends from Odisha, hi, tell me here. Friends from Andhra Pradesh, Telangana, Hyderabad, hello, tell me. Delhi, there are few people from Kashmir, please let me know. Tamil Nadu, please tell me, come on. Himachal, friends from UP and UK, Uttarakhand. My friends from Delhi, Haryana, Punjab. Anyone from Jammu Kashmir? Yes, from Ladakh you have. Jammu Kashmir I don't know. So please let me know. Anyone from Andaman Nicobar? Hi. Please tell me here. Give me answer. Anything needed, let us know. Friends from Bihar and Jharkhand. Jaipur, Rajasthan. Hi. Jaipur Center. You are from West Bengal. Tell me यार, उड़ी बाबा की होलो दादा, बोलो समझ में आया कि नहीं? You got it? From other centers, my friend, those who are. Aha, thank you very much. Pure India, Kashmir, hi. Thank you, yaar. Come on. You're from Kashmir. Thank you very much. I got some SMS from Mumbai, and some people are from I got it. Thank you very much, my dear. And some of you are even Vivek. Manipur, hi. Yo, thank you very much. You're from Manipur? Oh. Bhopal, Indore, aha, okay. Indore, Bhopal, Madhya Pradesh. My friends, my friend from different part here, please let us look at here. Come on. Hyderabad, Bangalore, Indore. Oh, by the way, friends, as I have just mentioned about this, let us promise one thing, you know. दिल्ली वाले भाई लोग है, भाई लोग, हाँ, इंदौर की भाई लोग है. अच्छा, one thing, let us do this, like, you know, we should not miss out a single question from rock. कहाँ problem है बोलो? Where is the problem? Please let us know. We should able to, from the earth interior, that was the most important area. From the rock type, metamorphism is very important. And from different part of, you know, rock type which you are getting, a question can be asked, yes. About this time, so many times it was, we have seen in G20, the Konark wheel. Now the Konark wheel, so Konark temple is made up of what type of rock? Can anyone tell me? Konark temple is made up of what type of rock? Yes. Hey, my friend from Odisha, nobody is responding from Odisha, but you have called me earlier. So if you are there, please let me know. Bihar ka bhai, thank you. Yes, Neha, can you tell me? Give me the answer. Anyone? Vanshika, tell me. Anyone who can give me the answer that what type of rock from which the Konark temple, which is called as the Black Pagoda, isn't it? Black Pagoda, you called it. So black stone hoga, isn't it? It is made up of what type of rock? Yes, thank you very much. Khondalite, Vanshika is saying Khondalite. Khondalite is now what type of rock? Khondalite is there. Thank you very much. Khondalite is what type of? Igneous or metamorphic or sedimentary? Khondalite rock. What type of rock is Khondalite? Do you have any idea? Black granite. Someone is saying metamorphic, someone is black granite. Black color, no doubt. No doubt it is black color. Sir, recently Ram temple is made up from what type of rock? Yes, yes. You tell me. Ram temple, sedimentary rock. Khondalite is sedimentary, pink sandstone Ram temple, yes. Oh, thank you, my dear. Thank you very much. So many good answers here. Thank you very much. But the Khondalite is what type of rock? It is a metamorphic form of the igneous rock itself. Sedimentary nahi, sedimentary Ram temple is sedimentary, but let me show you in a geology paper, Khondalite rocks. What type of rock? Composition. देखो यहाँ पे meta-sedimentary rock of Archean era. Khondalite are considered to be meta-sedimentary, metamorphic and sedimentary rock formed during Archean era according to Louis Legge. Charnokites, Khondalites. Now what happened here? Jagannath temple is there, Konark Sun temple is, both are from Khondalite. Jagannath temple, Puri, and Khondalite, Karnataka, your Konak Sun Temple, both are of Khondalite formation. Meta-sedimentary rock. Now what happened? Metamorphic and sedimentary put together, metamorphic and sedimentary mixed. But it is mostly metamorphic, you will see. Now what happened? There are also igneous rock which got eroded forming. Igneous rock got eroded from sedimentary and got subsequently transformed into metamorphic rock. It is a hard rock, it is a metamorphic rock. Foliated metamorphic rock. Thank you very much. Thank you, thank you. Foliated metamorphic is the best answer. Thank you, my dear. Thank you. Foliated metamorphic rock. NCERT class 11th book where you must have seen or must have studied the metamorphism. So, ये जो rock type which you have just seen and what type of rock in which region we have there, you need to see this, and believe me, we will able to get, if you will get any question, I hope we will able to answer that. आपको ये तो rock type हो गया, 4 types of rocks, 3 types of rocks I told you. Now, I believe that you will able to do. Let me see if any questions you have on rock, if you have any questions on the rock of this, like very important question. कुछ question है क्या किसी का? Previous year question, please, I request you all to see the previous year questions also. Previous year papers. Endo and axiomatic forces are there, and so many things are there, but sorry. Earth's magnetic field, you have a question. There is a question here in 2009. In the structure of planet Earth, below the mantle, the core is mainly made up of which of the following? Aluminium, chromium, iron and silicon. You got the question? Very simple. Here is a question here, lithification, layer by layer formation. Lithification, sedimentation, lithification, compaction, then the formation of the sedimentary rock. Lithification is the process of gradual cementing of layer by layer. Lithification in the sedimentary rock formation. Now my question is, in the structure of the planet Earth, there is a question in 2009. In the structure of the planet Earth, below the mantle, the core is mainly made up of which one of the following? Aluminium, chromium, iron and silicon. I think this type question if you will get, कुछ नहीं है, आप तो ऐसे 100% आप सही करोगे. I am sure you will able to do. I don't think you will have any problem on this. Iron, yes, iron is the answer. Someone was asking me about Goldilocks zones. I will discuss this. It was asked, I think, in 2015 in the universe part when I will discuss. Earth's magnetic field, their reversal also there was a question, but in the plate tectonics we will do certain things. There is a question. On 21st of June, the sun, 2019, on 21st of June, the sun, A, option is there, 21st June, you remember, position of the sun, doesn't set below the horizon as the Arctic Circle. Doesn't set below the horizon at the Arctic Circle. 21st of June. A ये है. B is doesn't set below the horizon at Antarctic Circle. C is shines vertically overhead at the noon on the equator. D is shines vertically overhead at the Tropic of Capricorn. क्या होगा आंसर बताओ? 2019. I will request all of you to even see the previous year paper, so that we will do with the topics, we will complete the entire area. Got it? Previous year question you must do, and I am sure if you will see this, it will be easy for you. यहाँ पे आंसर क्या होगा? Up to 2019. Today you will go and you will solve all this. Who is saying, sir, please explain once again rock cycle. Again चाहिए? Okay. Vanshika is saying A. Yes, it is correct. आप क्वेश्चन को देखा नहीं? द पर्सन हु सेड डी, साइंस वर्टिकली ओवरहेड द ट्रॉपिक ऑफ कैप्रिकॉन बोला ना. कैप्रिकॉन इज साउथ में. इन 21st जून इट इज ऑन द ट्रॉपिक ऑफ कैंसर. सो ट्रॉपिक ऑफ कैंसर होता तो ठीक रहता. सो इट इज डजंट बिलो सेट बिलो द होराइजन एट द आर्कटिक सर्कल विल बी द आंसर. यू विल चेक इट आउट, यू विल गेट इट. थैंक यू वंशिका, यू हैव गिवन राइट आंसर. रेस्ट इफ यू लर्न. सर प्लीज एक्सप्लेन वन अगेन द रॉक साइकिल. क्या हो गया भाई रॉक साइकिल में? तुम्हें कहाँ परेशानी है? डोंट लुक एट दैट एनसीईआरटी मटेरियल्स. अभी यू लुक एट हियर. Okay, you will see that question. See here, igneous rock, metamorphic and sedimentary, three type of rocks, my friend. देखो, the person who has asked me repeatedly, please look at here. थोड़ा ध्यान दो. अच्छा, one more thing you have to do. Please don't engage yourself with any other activity. पढ़ने के टाइम में इधर देखो, मुझे देखो. देखा आपने? See here. आप the igneous rock, metamorphic and sedimentary, right? Igneous rock will have from the metamorphic due to melting, high temperature and melting, and even because from the sedimentary rock because of melting you have igneous rock. Now it is okay. Igneous rock also because of melting, if it is there, again it will have the igneous rock. Are you getting the things? अभी A ocean floor है. Ocean floor is basaltic. Ocean floor is igneous rock. It will goes down. अंदर जाए क्या होगा? बिकॉज ऑफ सबडक्शन इट गोज डीपर इनसाइड, इट मेल्ट अवे. देन वोल्केनिक इरप्शन हुआ, वोल्केनो, देन यू हैव द बसाल्टिक लावा, और लावा अगेन इट विल कम आउट. शेप विल डिफर बट सेम रॉक विल रिसाइकिल. नाउ गॉट इट? नाउ igneous became igneous. क्लियर? नाउ मेटामॉर्फिक को देखो. इफ इट इज igneous rock, प्रेशर एंड टेम्परेचर आर बोथ, it will be metamorphic. I have given example, granite into niche, metamorphic है. Sedimentary rock also with temperature and pressure turn into metamorphic. Best example is sedimentary rock. क्या है? I told you, shale will turn into slate. Sedimentary rock is your sandstone, turn into quartzite. Sedimentary rock is your limestone, turn into marble, like this. Now metamorphic became metamorphic. Shale to schist, slate, slate to schist, schist to gneiss. आप देखो, marble to marble, metamorphic to metamorphic, it will be there because of pressure and temperature. Same way, if any rock has sedimentary rock, it is there. Sedimentary rock अगर कुछ है, so it became because of weathering, erosion and deposition. Weathering, erosion and deposition. Again, weathering क्या है? Gradually it will wear down in a particular region. With erosion, it will shift from that to another place, get deposited. So same sedimentary rock became sedimentary, or even igneous rock will get eroded and weathered and deposited somewhere, forming sedimentary rock, or even metamorphic rock get eroded, weathered and again get deposited, forming sedimentary rock layer by layer. This is what is the rock cycle. One rock type is changing into another one. Sharik, thank you very much. But my friend, please write your name here. You said that repetition. Sir, please explain once again the rock cycle. My friend, those who asked me, have you got it? If not, I will prescribe you some medicine for you. क्या है पता है? You will study 2 pages from a book. Oh, you got it? Very good. If not, I will prescribe you one thing. NCERT, there is certain things on rock. Just पढ़ लो. And mark it, you ask me. No problem at all. So, as I just mentioned about this type of rocks here, metamorphic, sedimentary and igneous rocks, you have different varieties of rocks you are having. These rocks, they change from one form to another form. My friend, it is clear to you. So, rock chapter is done. I hope you will be able to do. So, 3 things I have done today. One, the basic things on, very basic things I have given on your latitude, longitude, their utilization and all. And also I did said about the earth interior rock type. Friends, one thing, and always we feel that what is our universe made up of? हमारा universe में है क्या? हमारा solar system में है क्या? Many times we people are bothered about this. क्या है universe में? I would like to say certain very basic things. Theories I will discuss later on. Some basic concepts. Friends, our universe is incomprehensibly very large. Our universe is incomprehensibly very large, and our universe has billions of millions of different stellar materials, star-like materials. Friends, large in size, large in dimension, so many things you don't know, you have no much idea. It contains everything that exists from the tiniest particles, from the tiniest subatomic particles to the galactic supercluster, huge regions, whatever you are having, everything is in our universe. Okay? Nobody knows how big is this universe. We can imagine even, we just said like Indro, that it is estimated we have 100 billions galaxies in our universe, 100 billions galaxies. Each comprises hundreds of billions stars. 100 billion galaxy, each galaxy has 100 billion stars. So, you imagine about the universe. That's what we can say. My friend, we don't have much more idea, as such much more idea we don't have. But whatever idea you are having, based on this you can say, galaxy is a huge galaxy. What is this galaxy? Huge block of mass of star, variety of star. With interstellar particles you are having, gases and all particles, between 2 stars the particles are there, and all these things are there here. Galaxy is a huge mass of star. Nebulae and interstellar dust particles. Galaxy has nebula. It has interstellar dust particles. My friends, so many things are there here in this particular galaxy. Major building blocks of our universe is the galaxy. Galaxy is the major building blocks of our universe. Major building blocks in our universe is the galaxy. A giant galaxy has millions of billions of stars. They are held together. They are held together by their gravitational attraction. They are held together by their gravitational attraction. And this is like, as I have just mentioned, our galaxy, our solar system is in Milky Way system, Milky Way. Milky Way galactic system, in which our solar system is there. Milky Way galactic system, in which our solar system is there in the Milky Way. Anyway, as I have just said, there are different types of galaxy, my friends. Galaxies are of different types. Spiral galaxies, irregular galaxies, elliptical galaxies. There are a lot of varieties of galaxy. Let me see if we have an image of a galaxy. If we have an image of a galaxy, variety of galaxies you are having, how the galaxies are formed, and how these galaxies are, like, this is like a composite image of the measurative and galaxy. Dekho, galaxies. It can be a variety, various types of galaxies you are having. Some are circular shape, some are elliptical, some are irregular, some are variable. So many variety of galaxies you are having. It is up from National Geographic. I have taken this. Spiral galaxies. Great galaxy of Andromeda. Our galaxy is Milky Way. Our galaxy, Milky Way. Milky Way. And another one is Andromeda. These galaxies are spiral galaxies. Spiral galaxy. Spiral galaxy क्या है? Milky Way and Andromeda spiral shape में होंगे ये. Their shape is completely different. This is a spiral galaxy, my friends. This is a spiral galaxy. Like this you have here billions of stars you have in these galaxies. And there are Milky Way, Andromeda. Best example galaxy का हमने दिया spiral galaxy. Good example Andromeda. Large spiral galaxy, disc shaped, greater concentration of star near their center. 1/4 of all galaxies on the earth have of this shape. 1/4 of all galaxies are spiral galaxies. So these galaxies, at the middle more concentration you have. At the middle part you have more concentration. Okay. Of all rotating spiral pattern होगा ये galaxy. Towards the arm you have bright young star. Here it is young star. Young star at the margin and old star you will get at this. This is here is the old star. In this old star at the middle part, young star at the periphery. Old one at the middle, young one at the periphery. You have stars concentration is there. Got it? So this is here is the galaxy, spiral galaxies. Spiral galaxies you have. This spiral shape. My friends, the most abundant galaxies is elliptical galaxies. Spiral is clear to all of you. Elliptical galaxies. A star, how it explode and how this is magnetic, this is like, star explode and this type of galaxy it formed, you see. Hubble Space Telescope से ये है एक how galactic location 11 million light years away on the constellation of Camarilla. Okay, it is forming new galaxies, new stars are forming in this galaxy. You look at these are infrared image of the galaxies you have. Hubble Space पे देखिए Antennae galaxy नाम का एक galaxy है which NASA has pointed out this galaxy. दिस इज ए ब्लैक आई और इविल आई गैलेक्सी. ये जो ब्लैक आई दिखाई दे रहा है ना, इविल आई, दिस इज ए ब्लैक आई. दिस इज लाइक दिस इज ए फॉर्मिंग absorbing dots that appear in the front of the star system's bright centers. ये जो ना, this is here is subsequently they may form a black hole. They are saying this is like galaxy. Cosmic dust wheel है ये, wheel pull galaxies. आपको ये जो galactic system है, Hubble space की, I'm just showing these galaxies here. Like you see here, what is this galaxy? Milky Way galaxy, our galaxy you see. NASA's Milky Way galaxy. हम किधर हैं देखो, this is a spiral galaxy. Milky Way is a spiral galaxy, my friends, and you can see this how this galaxy looks. आपका प्रीलिम में possibility of asking this particular galaxy here. Okay. It is a spiral galaxy. It is also the same Milky Way. That was, ये जो है ना galaxy infrared image में है. It is an infrared image, and the same galaxy shows a color composite image in which you have same galaxy looks like this. Andromeda galaxy. Andromeda, largest neighboring galaxy from us. This is Andromeda galaxy. You see how it is. Andromeda is also a spiral galaxy. At the middle you have old star, towards the periphery you have new star here. Galaxy can be asked, elliptical galaxies are there. Elliptical galaxies are generally smaller than the spiral galaxies. Most of the elliptical galaxies are smaller in size because they are turning towards a black hole. Elliptical galaxies are smaller in size than the spiral galaxy, and elliptical galaxies are only old star, no new star. Spiral galaxy has new star, but elliptical galaxy doesn't have the new star. Please remember this. Let me show you elliptical galaxy. Images if I will go for elliptical galaxy. Now, in this elliptical galaxy, this galaxy, this elliptical galaxy, which is very different from rest. It is completely different from the rest. In terms of the elliptical galaxy में क्या होगा, छोटे होंगे, and these galaxies has like this will be like highly elliptical, and interestingly smaller one. This galaxy doesn't have more. Majority are the old star. You remember, this is what is elliptical galaxy. Elliptical galaxy, the biggest and the brightest galaxy in the universe are elliptical. Biggest in the sense, what is elliptical? They are generally smaller than the spiral. Biggest in the sense, ये क्या है ना, ये elongated होगा ना जो elliptical में, area कम है, मगर length होगा. Elliptical galaxy. They are most common galaxy on our universe. It is the most common galaxy. Elliptical galaxy. Most common galaxy is elliptical galaxy. Then third type of galaxy is irregular galaxy. Irregular galaxy. This galaxy doesn't have any proper shape. ये galaxy का कोई proper shape नहीं है. Irregular galaxy. Irregular galaxy comprises about 1/10 of all galaxies. 1/10 of all galaxies are irregular galaxy. Remember one thing. In case of this your irregular galaxy, comes
They are composed mostly of young population. I star.
Okay, मैंने कहा only young population, young star are known as I star. Young stars are more. See, in case of irregular galaxy, young star are more. In case of elliptical galaxy, old star are more. In case of your circular galaxies, we have what type of star? Both are there. At the middle part, you have old star. At the periphery, you have the young star. In case of spiral galaxy, spiral, elliptical, and irregular, 3 types of galaxies I said. Okay. On a very clear sky, when there is no moon, from horizon to horizon, you will find out sometimes light. Okay. This is the Milky Way. सदर्न हेमिस्फीयर में थोड़ा ज़्यादा दिखाई देता है क्लियरली मिल्की वे. Milky Way, our galaxy I said. Anyway, now what are star? Star, they are the celestial body where you have their own power to illuminate energy, whether it is hydrogen and helium rich as you know, and there is continuous process of star, glowing gas and born of nebula you have in the star. Star enormous in size, mass, temperature is very high. These are like, for an example, the star are formed due to nuclear fusion in their core, as you know. All of us were well aware about this, the process of fusion. Nuclear fusion in the star's core leads to the emission, it emits energy. Energy it emits. And as you know, the best and the most important nearest our star is the sun. Sun, and the sun has different things like, you know, in this at the middle, what is there? Star. You can see our solar system. Our solar system, which comprises the sun and all its family members. Sun and all its family members. Sun is the head of the family. And this is because of hydrogen and helium that you are getting energy due to fusion, as I said. Sun is the central body in our solar system. And sun is around 5 billion years old. Okay? 5 billion years old. Our sun is around 5 billion years old, and it will again continue for 5 billion years more. At the middle part of a life it is. Approximately I am saying. And the core of the sun is completely made up of hydrogen and helium. Hydrogen and helium, the most important two products. Okay. There are different layers of the sun, you know. So, sorry. If I will go for the images here from the NASA, we will see what is there inside the sun. We have different facts about the sun here. The prominence, you see here the innermost part, internal structure, core of the sun, this is. Radiative zone, convective zone in the upper part, photosphere is upper visible part. chromosphere. Solar flares are there. Sunspot, you will have dark patches you will find out in the sun also. Dark patches sometimes you will find out in the sun. The dark patches are known as sunspot. आप एक काम करो, ये just write down about 4 things. One is your core of the sun. Core of the sun. Photosphere of the sun. Sunspot, chromosphere, corona. Prominence will be there, no doubt. Convective zone and radiative zone. Now, what exactly is these zones speak about? क्या है इस पे सन में? You remember that in this sun is made up of different gases. Hydrogen atoms are converted to helium in a nuclear reaction, and they are like, continuously fusion process is going on there, and because of this energy get released surrounding the core. Radiative zone is there. Core के radiative zone through which the energy pass to other part, convective zone को पहला है core, then radiative zone, then the convection zone. Please, 1, 2 and 3. Number 4, beyond this you have the, then upper part is your photosphere and you have the chromosphere. So, आप ये 3 को तो पहले करो, 1 core, radiative zone and the convection zone. 3 things are there. Remember, radiative zone through which the energy passes to the surface. Energy passes to the surface through radiative zone. Through the process of convection, the convection जो है energy exchange होता है. Process of convection. Okay, fine. आपके लिए important core and the radiative zone. Then you have the photosphere. Uppermost visible layer is photosphere. Can you see this? Photosphere. Photosphere, a layer of about in the upper part, visible surface of the sun is called as photosphere. The transparent atmosphere above the photosphere is chromosphere. Photosphere के ऊपर है chromosphere. After the photosphere, you have the chromosphere, my friends. You want PDF? Okay, fine, no problem. But you must remember, see these things. ये तो you can download it, NASA की photo है from NASA, but we will provide. Okay, I'll see. Photosphere. Photosphere के बाद chromosphere. Chromosphere, I said, transparent, lowest part of transparent atmosphere lying above the photosphere is chromosphere. The upper part which is seen only during the solar eclipse is called as corona. The upper part which we can see only during the solar eclipse is corona. Corona is visible only during the solar eclipse. During the corona only we can see the solar eclipse. Solar eclipse, corona is visible during the uppermost part in the transparent. Just above the chromosphere you have corona. What are sunspot? These are dark patches in the photosphere developed due to around low temperature region, nearly 1500 degree Celsius less than the surrounding part, and that's why 1500 degree cooler than the surrounding part, this temperature on an average. That's why it looks black, dark in color. During the magnetic storm only it happens. Solar flares are
transfer of, this is like flare, solar flares are there. What are the solar flares? Solar flare is the energy, get radiated energy here, is the solar wind. They are photons, energy from the sun. My friend, these are the things, because you are having so many projects in the science tech, you must have studied, but still I want to just remind you, because you have different projects now to the sun, we are studying about this, about moon, lunar project and all, possibilities there, you will get questions either from science tech or from the astronomy or from geography. So please be prepared. If you have the material, then please see these things. These are the area where it is important. We should have some basic idea about these regions. We don't want in detail. हमें पूरे नहीं चाहिए, मगर as a layman whatever one should know, we should know about that. Okay. After this, we should look at our solar system. All the 8 planets which you have, plus the sun, there's and our planets, all the satellites, including all these, it is known as the solar system. So in the solar system, the major member is the sun, rest all are the smaller one. We have 2 groups of planet, terrestrial planet and Jovian planet. Terrestrial planet are smaller one, Jovian are larger planets. So we'll go for the solar system now. Is it clear to you? Sun के ऊपर इतना काफी है. You must remember few these things only. Okay, regarding this, I request you all to have a glance over this. अब देखो आपको बहुत कुछ पता चल जाएंगे. Lot of things you will get to know about the sun. Many times I feel like, though it is not a part of geography, but sometimes possibilities they are related. During your childhood, you must have studied about atmosphere, our solar system and all. Okay. Radiation is the process through which the energy moves, Mansika. But the photon, capsules of energy while it thrown out, energy pockets when it thrown out, solar flares, packet of energy, photons, energy capsule throughout. This is known as solar flare. Wind is the general pattern of radiation of the solar energy, that is solar wind. These are technical terms only, nothing else. So, solar wind, solar flares and all, as I have just mentioned, intense burst of radiation coming from the release of magnetic energy associated with sunspot. These are, as it is saying, you can see this is the solar wind and solar flares. Differences is there. Solar wind and solar flares. This is the solar flares. Solar flares where it is the energy capsule is throwing out, capsule of energy like, it is throwing out by the solar wind and by when it has like, the process through which it usually comes out like, this is solar flares. Process through which is coming out. ये solar flare है. Energy will go out. By the way, these processes which I have just mentioned, my friends, you remember, the sun and its all family members, which includes all the planets also, which you called it as solar family or solar system, which you called. If you look at them, there is a cigar-shaped arrangement of all the planets in our solar system, my friends. If you will see, You know, there is a news. Interstellar mysterious cigar-shaped object spotted tumbling through the solar system last year. Is it an spacecraft or what exactly is this one? If you have seen, ये CNN में न्यूज में है. This is it a spacecraft or what is this? It reminds us Boyce Ballot law. Boyce Ballot law में बोलता है ये क्या? Cigar shaped arrangement of different what you call our different kind of different shape of our planets. If you look at our planets, there is cigar shaped arrangement. कैसे है? देखिए, ये like if you'll see, Mercury, Venus, Earth, Mars, देखिए आप Mercury, Venus, Earth, Mars, then you have the asteroid belts, Jupiter, Saturn, Uranus, Neptune. ये अगर मर्क्यूरी हो गया, वेनस, अर्थ, मार्स, आपका प्लैनेट जो है, as you know, their size if you look at, Jupiter is the largest among all, you can see this. Now Mercury, Venus, Earth, Mars, then you have the asteroid belt, then the Jupiter, asteroid belt, then the Jupiter, Saturn, Uranus, Neptune. So all these are the planets here. You will find out their size, then they looks like ये जो है ना cigar shaped जैसा लग रहा है कि नहीं? This is what cigar shaped arrangement. I was talking about this one only. If you'll see, they looks like as if arrangements of all planets in our solar system. Sorry. This is a lot of new theory and other things came out, like planets arrangement in our solar system is like this, why it is, how it is. Mercury, Venus, Earth, Mars, along with the moon, known as terrestrial, rocky planet. They are, here is, these planets are, these are terrestrial planet, rocky planet. These planets have solid surface with volcanic landforms and tectonic activities. टेरिस्टेरियल प्लैनेट, टेरा अर्थ लाइक, इनके बीच में यहां पे है, ये क्या है भाई, ये दिस इज नोन एज एस्ट्रॉयड, एस्ट्रॉयड बेल्ट बिटवीन, this is asteroid belt, Mars and Jupiter, between Mars and Jupiter you have asteroid belts. Mars are terrestrial rocky planet, these are volcanic surface hai, volcanic activity there, folded mountain there, this region have the proof of solid surface. But these other, other planets doesn't have the same characteristics. They have variable surface. One by one we will see about this. First is Mercury. My friends, I would like to say one thing. Mercury, okay, sir, what is Pegasus dwarf galaxy? My friend, name of a galaxy, and this is like, they are having dwarf, means it is dying gradually towards black hole. Is it name, but it has like a special type where you have it is going towards black hole, it will get destroyed. What is solar storm? My friends, solar storm, what happens? Sometimes the solar magnetic property, solar wind became very strong, and the sunspot cycle developed at that time more. Okay, sunspot cycle, solar storm. Let me show you on this. Solar storm, that is the geomagnetic solar storm. These are which can hit the earth, and it will have like more impact, solar storm. NASA is preparing for a huge solar storm that could hit earth by 2025. It will raise the temperature, it will have, in the technology part you will study, in the science and tech part, but solar storm is intense release of this energy, solar energy with magnetic field. These are like, our ionosphere playing a very important role on protecting us. In the earth atmosphere you have ionosphere, ions, free ions and radicals, they are playing a very, very significant, very important role on this. Okay. By the way, let us look at these planets now, and one line on each thing. Mercury, we don't have to know for in detail. Mercury is smallest one, nearest to the sun. Mercury, god of commerce and skill. Otherwise, ये कभी पूछ रहा है, ये god of commerce and skill, Mercury. ये जो traditional thing Greek people they believe, and they thought like this is a very important one. For what? Mercury. Mercury is smallest, innermost, and the swiftest planet among all. It is the, I said, smallest, innermost, and swiftest planet. You know why? Swiftest, because it is nearer to the sun, so it is swiftest planet. Okay, it's similar to that of the moon, but only it is still like, it is very quickly it is moving, right? Very interesting. This is the nearest to this. High temperature it is having. Very interesting. The temperature in the night and day it is more range. 430 degrees Celsius temperature, minus 170 in the night, 430 degrees Celsius in day, minus 170 degrees Celsius in the night. Highest diurnal range of temperature. Highest diurnal range of temperature here. Very high temperature. Average temperature. See, if this is the case, क्या रहेगा और? Temperature is 430 degree in the daytime, तो क्या रहेगा बताओ आप? Temperature drops very quickly because the planet atmosphere is almost non-existent. Okay. Life form is non-existent in these regions so far. We don't have any proof. Diurnal mean day and night temperature range is much high. Now, here is the planet, smallest planet nearest to the sun. This planet doesn't have life, and there is no atmosphere here. Because there is no atmosphere, this is the cause, temperature range is much high. जब sun daytime में, that's why temperature is much high. In the night time, temperature became less. Sudden radiation leads to low temperature at that time. Okay, next one. Mercury के बाद आते हैं Venus. अच्छा, Mercury doesn't have also any satellite. बहुत छोटा है, मून जैसा है वो भी. Okay, satellite नहीं है. No satellite of Mercury. Now Venus, goddess of beauty, veiled planet. Veiled planet, the goddess of beauty. The goddess of beauty. It is not veiled planet means पर्दा. पर्दा है. I said it is the goddess of beauty, known as the veiled planet. Parda, veiled, because of the atmosphere in which you have more carbon dioxide. Venus, rocky planet है, second planet from the sun, no doubt. Okay, have you seen the Venus? Anyone? Second brightest object you will find in the sun, in the sky after the moon in the night. Venus. Second brightest object found in the night sky. Venus. Earth's twin it is called as, because of size and this, it is known as Earth's twin. Venus is called as Earth's twin. जोड़वा है, अर्थ की जोड़वा है. Earth's twin it is called as. Venus is called as Earth's twin. I hope you are well aware about this. Earth's twin. It has thick deposits, thick atmosphere. It is the hottest planet among all, temperature may goes up to 480 degrees Celsius. वहाँ पे कितना था देखो? Here we have 430, here 50 degree more. 480 degrees Celsius because of carbon dioxide gas. Venus. Because of more presence of carbon dioxide, it traps the heat energy. And temperature is more as compared to the Mercury. It is the hottest planet, I said. It is the hottest planet. Venus is the hottest planet. And the atmosphere of Venus works as a greenhouse effect, like a greenhouse effect. Its atmosphere acts like greenhouse effect. That's why Venus is like this. Earth's twin, I said. Venus slowly orbits around the sun backward.
रोटेशन होता है इसकी. एंड वेरी इंटरेस्टिंग, ये क्लॉकवाइज रोटेशन, बाकी एंटी क्लॉकवाइज तो क्लॉकवाइज रोटेशन है. It is completely different. It has a different characteristics. We'll continue with the session whatever we have discussed in the last session. We did discussed about the universe. We are discussing about the universe and the solar system, and where I did mention about Mercury and Venus. Earth, as you know, our planet Earth, shape of the Earth is geoid shape. Geoid shape. Neither it is perfectly circular, nor it is pure elliptical. So, the geoid shape Earth is primarily because of what are the factors? Why it is a geoid shape Earth? Earth is geoid shape because of what? Neither it is like this, rather it is like this, is not it? Geoid shape Earth. Why you have the geoid shape Earth? Shape of the Earth is like this: equatorial bulginess and polar flattening. Equatorial bulginess and polar flattening. Here it is, I will say equatorial bulginess and polar flattening. Why it has happened like this? Why this shape? The major cause for this shape is this type of, the shape of this Earth is due to Earth rotation and the centrifugal force. When the primordial body from which the Earth was formed gradually got cooled down and solidified, during this, because of the Earth rotation, centrifugal force which is gradually it gain and it is more at the equatorial part, it throw out all this, because of which you have this side you have flattening, here you have pressure, this side you have deformation. So, this shape is called as the geoid shape of the Earth. As all of us were well aware about this, Earth shape is geoid shape, I said. The geoid shape of the Earth is primarily because of what? Earth rotation. During its formation itself, the rotation of the Earth and its subsequent impact. Okay, geoid shape Earth, polar flattening and equatorial bulginess. For this region, the Earth is unique also, and as I told you, on the Earth's surface you have two hemispheres. Northern hemisphere is called as your land hemisphere, southern hemisphere is the water hemisphere, and there are a lot of other factors, other impact of this one. Geoid shape Earth. Like, look at here again. In the overall position of the Earth, if you will see, Mercury, Venus, Earth, and then you have the Mars. Earth position is unique between two important, planets. By the way, we have our own satellite, natural, this is Moon. Regarding Moon, I can say the Earth is called as a biplanet, biplanet like, because the Moon diameter, if you look at, almost 1/4 of the Earth. And the common center of gravity between Moon and the Earth is known as barysphere or barycenter. Barycenter. The common center of gravity between the Earth and the Moon, barycenter. And because of this, the attraction, the Moon is moving around the Earth because of this. Some facts about this, like, the rotational revolutionary period of Moon is almost equal. For that reason, we can see one part of the Moon only, always visible, as we know. and moon plays a very significant role on different phenomena, particularly on the ocean tidal phenomena. By the way, regarding moon, these are certain things which I would like to say. As I have mentioned earlier about this, in case of moon, our moon, I said 1/4 of the diameter of the earth it is. The moon takes same time to rotate as it takes orbit around the earth, and so the same side always faces rotation and orbit around the earth. Revolution is almost equal. So same side is always visible from the earth. Earth का same side इसलिए दिखाई देता है because of that reason only. Are you all with me? Is it audible to all of you? Is it clear to all of you? Sir, please change the background. Okay. Just then tell me which background you need. Will it be okay if I will go for black and in which white one? Will it be okay for this? Bari center I said, and this is here is the moon. The common center of gravity between the moon and the earth is the Bari center. Common center of gravity between moon and the earth. Is it okay now? This background is okay? Or I will go for any other color, tell me. This color? I hope it is clear to you. Okay, fine. So, both the earth and the moon revolves around the Bari center, I told you, common center of gravity. One thing here, the students are asking. Is it okay? Is it okay to all of you? Yes? Audible but lagging. Is it okay now? Okay. So, as I just mentioned about this, like in the moon, you will find out one more thing, like there are volcanic evidences of volcanic eruption. There are a lot of impact hole like meteorites and the other celestial body which strike over the moon surface, lunar surface. We have crater and cavities are there. Very irregular surface you have here. Very irregular surface. It has very irregular surface. Okay. If you see now density of moon, if you see 3.3 that of water, I mean it is less denser than the earth. Density of moon is lesser than the earth density. Please remember this point. And moon has billions of crater, I said, because of impact of all these and all. There are a lot of Maria is a very important crater inside this huge one. Because of impact of the meteors you have this type of phenomena, this type of surface. Okay, after this I will go for the next next one is after this Mars, red planet Mars. Red planet. Mars is the ruler of God, as you know. It is a It is the first of the all gaseous planet I am saying. First of the all gaseous planet, Mars. And remember, this planet has two most important satellites also. Two important satellites on this Mars. One is Deimos, another one is Phobos. Deimos and Phobos, these are two important satellites of Mars. There is not much important fact about this particular planet, but one thing is there, that these two satellites, you must remember, Martian atmosphere of the Mars is just 1% of the Earth's atmosphere. You please remember, only 1% of the Earth's atmosphere is Martian atmosphere. Okay. Phobos and Deimos are two important satellites here in the Mars. After Mars, we will go for the next planet. As you know, between Mars and Jupiter, I told you there are what is that? Asteroids. But I will go for first the Jupiter here, the giant planet, the ruler of the god Jupiter. Where is the Jupiter? Jupiter doesn't have much, there is no solid surface, gaseous surface it has the maximum number of, one among the maximum number of Saturn and Jupiter. If you look at, like, we have recently discovered more number of satellites in Saturn than the Jupiter. So some scientists are of the opinion that Saturn has more, and some people they are saying like, okay, Jupiter has more. But anyway, it has huge number of satellites and natural satellites I am saying, and Jovian satellites, particularly Jupiter satellites, which are 4 satellites very important: Ganymede, Callisto, Io and Europa. That is the most important satellites: Ganymede, Callisto, Io and Europa. These are the natural satellites who are known as the Galilean satellite. Galilean satellite. Why? But Galileo, in fact, he discovered this first time. Since then, it is like, it is named as the Galilean satellites. These are the Galilean satellites Jupiter says. And you remember, Jupiter has nearly, as per the report, 65, 66 satellites Jupiter has. Some of the scientists are saying the Saturn has 57. Some even claiming more than that. So there is disputed fact on this, but if there is a question on this, like, Jupiter and Saturn, Jupiter at present, we have maximum number of satellites as per the till date whatever we got the information. Jupiter largest one, and Jupiter has gaseous, I said, the surface. Likewise, we have next one is Saturn. Saturn is ring planet. Saturn is known as a beautiful planet, diamond ring or ring planet. Ring planet. So here you have this planet has some certain, as per these, there is rings on these planets. So these rings are completely made up of, these rings are composed of dust particles. Dust particles and frozen materials. Now we will say, like, what is that frozen material, dust particle, किससे बने हैं? Made up of what? These are like, interstellar dust particles are there, solid. These are like, sometimes individual, they are moonlet, they are called the moonlet. Satellites are
They are very fragmented materials with interstellar dust particles. Between the star, the dust particle, likewise you have some unknown, not properly identified materials, and the frozen materials are also there. So, these are composed of this particular ring, and if this is a planet here, planet has some rings here. These rings are in different shape, they are in different way. Like they are also seasonally, they have, we came to know that their thickness also varies, their property changes with respect to टाइम, कैसे कब कहाँ पे ये प्रॉब्लम जो है ना यहाँ पे, व्हाट आर द प्रॉब्लम्स ऑफ दिस पर्टिकुलर रिंग फॉर्मेशन, समथिंग related with not only solar wind, which is also associated with the position of where exactly this planet is now. These rings, in fact, their thickness varies. I am saying this ring's thickness varies because the concentration of particles, how it is based on this. But again, we have very rough idea about this. Now, Saturn के बाद होगा Uranus. Uranus is, अच्छा इसका 36 the proven satellites are 36 here in Saturn. There are more satellites also as per the opinions of different scientists. By the way, one I would like to say again, Neptune. Neptune is Uranus को जरा, Uranus, then Neptune. यूरेनस को हम बताते हैं क्या, ग्रीन प्लैनेट बोलते हैं. दिस इज द प्लैनेट गॉड ऑफ हेवन और द ग्रीन प्लैनेट. दिस इज बिकॉज ऑफ द दिस इज नोन एज द ग्रीन प्लैनेट. ओके, we are of the opinion that these are like composition of this one, composition of this planet is completely different. Okay, it was discovered by Herschel, a German, in fact, astronomer who discovered this. Okay, this particular Uranus composed mostly of ice, frozen ammonia and methane. Okay, I am saying this is composed of frozen ammonia and methane. Because of the presence of methane, it is greenish, it looks greenish in color and known as the green planet. Because of the presence of methane, it is greenish in color and is known as green planet. Please remember this. Due to the presence of methane, it is known as the green planet. Okay, Uranus is there. Neptune. Neptune is the farthest among all. Neptune farthest among all. Farthest among all planets. Farthest among all planets here. Neptune is the farthest among all planets. Remember one thing, this planet, as you know that this is the farthest one at present among the major planets. This planet having maximum temperature, if you look at the variation in the temperature, it is much more. And this planet discovered by Adam and Lewis, it is not needed of course. This planet is considered a twin. Neptune and Uranus are called as twin. I think that is the satellite is Triton, which is the moon of the Neptune, and is one of the coldest, one among the coldest satellite, or one of the coldest satellite in our entire Triton. Triton is there. Triton is a satellite, you remember. We are saying that it is the coldest among all satellites in our solar system, Triton, among the planets. Now, we will say like, sir, what about Pluto? Pluto is no more considered as a planet because of which, this is like the Pluto's satellite is not considered here because of that only. But Charon, Pluto's Charon is like, Pluto, planet X बोलते हैं इसको. planet X. This is satellite is Charon. Charon is the satellite. But this satellite and Triton, if you look at, sometimes Triton is farthest than the Charon itself. Okay. So Triton became very coldest one. That's why Triton is the coldest, I said, in our solar system, among the major satellites. Pluto, Charon is the satellite, you remember. Pluto is no more considered as a planet because of some, as per the new definition, it should have clear path on its way. So it is because there is no clear path, and that's the cause, one among the factor that you are not considering it as a planet. Okay, so these are certain things about the planetary system. Comets and asteroids, you know that they are also other celestial bodies. Asteroids, between Jupiter and the Mars, there are more than 1500 heavenly bodies, rocky materials. They are present between Jupiter and Mars. In between them, they are known as asteroids, believed to be a remnants of an earlier existing planet. Anyway, these are certain views on this. What are comets now? Comets are, if this is, they are in our solar system. In fact, you will find them. These are glowing objects, like they will see they have a tail. Most spectacular they are, unpredictable bodies. They are composed of volatile materials, frozen gases, water, ammonia, methane, carbon dioxide, all these they are frozen gases. Comets, they are made up of frozen gases, carbon, ammonia, methane, etc. So these are like, when they comes near the sun, when they reaches near the sun, because of the solar wind, they develop tail. Okay, a nucleus जो होता है उसका nucleus से tail आ जाएंगे, and it will have like a different path. It will look at here. I'll tell you how it is. If this is the sun here, ये सन की जो टेल होता है ना, वो ऐसे होगा. Tail will go away from the, this is the tail of the comets. Here it will be very smaller one. जितना पास आएंगे उतना ये, wherever it will come to near to the sun, because of the solar wind, it will have like, this is the comets. If it is, this is the tail of the comet. This is the nucleus of the comet. At the middle we have nucleus. This nucleus is completely made up of carbon, ammonia, methane, etc., frozen gases, etc. When they come near the sun, like, we have the solar wind. Because of the solar wind, here we have the solar wind. Because of the solar wind, they deflect away. Due to the solar wind only they deflect away. This is the cause. Okay, very interesting one phenomena here, that comets, their tail direction is opposite always from the sun. Sun का opposite में ही रहेगा वो direction of comet's tail. Okay, these are certain things. As all of us were well aware, there is a ring of debris similar to the asteroid belt, consisting mainly of objects composed of ice, nearly एक बोलते हैं ना कुपियर बेल्ट. देयर इज ए टर्म नोन एज कुपियर बेल्ट.
there is a term, yesterday somebody was asking me about Kuiper belt, I think. Like from 20 to 50 astronomical unit distance from the sun, we have a zone of like asteroid, like this type of one zone, but mostly frozen ice and all other things. We have planetoids, or whether it is cosmic materials, they are made up of this, and all these are called, this is a belt, zone of debris, great ring of debris, similar to the asteroid belt. Great belts of debris similar to the asteroid belt. Asteroid belt generally found from 20 to 50 astronomical unit from the sun. From the sun, outside the sun, ये जो है ना सन से दूर, ये जो है ये मिलते हैं, कुपियर बेल्ट कहा जाता है इसको. We have like some idea about this, but many Kuiper belts objects have multiple satellites orbits in the plane of ecliptic. You have like, we found out in some out of our solar system, we found out all these things. By the way, these are certain things about the planets and the universe, certain things I was supposed to tell you. We will have a discussion about the origin of the solar system later on. Origin of the solar system, because some theories which are related with, very important theories are there, like after the Big Bang theory, what are there, the God particles and whatever we have discovered now, and so many opinions you are having, we will look at that. Okay, so today's topic, it was in the last yesterday's, like what we are supposed to discuss this, that's why I just have given some idea. Let us come to today's topic. As per the planner, we are supposed to discuss today certain things. Let me first give you, based on the topic, what are the topics one is supposed to do. First one is crustal deformation, earthquake, volcanism, plate tectonics. Today's topic is crustal deformation, first topic. So, I will go for this. Friends, from this particular topic, you are getting questions many times in the prelim. Crustal deformation represents the folding, faulting, and there are like a deformation of the earth crust because of both compressional and tensional forces. Let us look at this. It represents the deformation of the earth's crust due to endogenetic and exogenetic forces over the earth's surface. My friends, to know about this, let me first tell you the basic forces behind the crustal deformation is the endo and exogenetic forces. Primarily, it is the endogenetic forces. Let us first discuss about what are endogenetic forces, what are exogenetic forces. As I told you earlier, when the earth formed due to cooling of the stellar material, the densest material got accreted at the center, it got cooled down and it got squeezed gradually. The squeezing of this because of cooling leads to pressure from outside and a reactionary pressure from inside. The pressure coming from the earth interior is known as endogenetic forces or endogenetic pressures. Okay, the pressure which originates from the earth interior is endogenetic forces. Okay, next point, Earth's
Earth's crust is greatly influenced by the forces develops within the Earth's interior, which is called as endogenetic and Earth as well as exogenetic forces, which develops outside the Earth interior, outside the Earth's interior. I mean, that is outside the Earth interior mean over the atmosphere, that is over the atmosphere or lithosphere and the hydrosphere, whatever you have. So in the atmosphere, so let me first differentiate between these two. Question can be asked here about these forces. So endogenetic forces and exogenetic forces. What exactly are these two forces? We'll see now carefully. This is endogenetic, this side exogenetic. Endogenetic forces. This is exogenetic forces. First point here is in the endogenetic forces, its origin. Origin is Earth's interior. This is over the Earth's surface and the atmosphere. Second point is, this is Earth, it is energy. From where it get energy? Endogenetic forces gets energy or energized by geothermal. It is geothermal energy. This is generally energized by the sun. Energized by the sun. Okay. Next one. Endogenetic forces. Relief features. What type of relief features it gives? It develops first order and second order relief. First order relief, what are those? First order relief includes here continent and ocean. These are first order. Second order relief includes mountain, plateau, trenches, etc. देखो, first order relief are primarily developed by the action of endogenetic forces, mostly continent and the ocean. Inside the continent, major relief are known as second order, that is mountain, plateau, trenches, etc. They are also endogenetic in nature, their development. A mountain can be formed because of volcanic eruption, it can be formed due to faulting, it can be formed due to folding, etc. So, plateau also like this, it forms trenches formed because of convergence of two plates. So, second order are found inside the first order. Another is third order. Here you have like an exotic forces, they are responsible. It generally helps in the development of third order landform and relief. That is like mostly landforms you have. Third order landforms में like a V-shaped valley, a U-shaped valley, a waterfall, a river valley, a plain, erosional plain, etc. All these things will have like in the relief features these are. So, the exogenetic forces are responsible for mostly erosional plain landform development. Let me tell you one more thing about these two, differentiate the things, that one more point we can say, fourth point, nature of the forces. ये कंस्ट्रक्टिव फोर्सेस है, कंस्ट्रक्टिव or what are constructive in nature, and these are like constructive, mostly they built up new relief, they form new relief here. ये हो गया mostly destructive in nature, constructive or leveling of forces, destructive of leveling down forces. So, कोई भी relief है, any relief wherever it is there, the relief will increase height. Leveling of forces these are mostly, even if subsidence is there, a force which is responsible for construction of new particular theme with more relief may be. Here is the relief, the relief variation will be less, leveling down forces, erosion is there, that is the cause, because of erosion and subsequent characteristics. Oh, Avi, now I got a question, comets are asteroid? No, comets are different, they are outside our belt, sometimes they enter into our solar system, like they are they enters our path of, in some cases we have seen even the path of the planetary path in which also it enters. They are highly elliptical, and asteroid is different from the comet, please. They are completely, I will discuss about this, just give me some time. At the end we will do. I have already started. Why so late? I am getting the answer and response in very late. Okay, by the way, nature of the forces based on this constructive and destructive I have just said. Constructive, you must be thinking like, sir, volcano is a destructive one. No, volcano also form a landform. Landform relief wise it is a constructive one, leveling of forces. Okay, can you see this? Now I will go for different forces. I said forces responsible for
endogenetic forces, here it is exogenetic forces. Weathering, erosion, mass wasting. Weathering, erosion, and here it is mass wasting. Endogenetic forces are of first two major types. Endogenetic forces can be of two major types. One, catastrophic, another one is diastrophic. Diastrophic forces, another one is catastrophic. Diastrophic mean slow, catastrophic mean quick or sudden. Sudden here you have. Diastrophic can be mountain building, or it can be continent building. Diastrophic slow and catastrophic is sudden. Sudden may you can have like in the catastrophic volcanism and earthquake. Mountain building forces are again of two types. It can be compression, it can be tension. It can be due to compression or it can be due to tensional force. Compressional force or it can be tensional force. continent can be upwarping, it can be downwarping. Compressional force पे you can have folding and faulting. What type of fault? Reverse faulting. In case of tensional force, only faulting. Now, in this case, let me explain in detail of this. आप पहले ये इसको बना लीजिए, मैं I'll explain it in detail. Forces of crustal deformation, two types, endogenetic and exogenetic forces. Endogenetic forces can be diastrophic, means slow, or sudden, catastrophic. It can be mountain building forces, or it can be continent. Mountain building forces can be compressional force, or it can be tensional force. Compressional force can be folding, or it can be faulting or reverse faulting, and here it is faulting. It will be normal faulting. ये faulting जो होगा ये, this will be normal faulting. Upwarping and downwarping is there. I hope you got it now. This is the, in fact, sequence. I would like to discuss in detail about this. Each of them, endogenetic forces are, I said, in the crustal deformation, you must remember, बहुत ही slowly जो movement है, diastrophic movement है. For example, the east coast of India is gradually rising up. Emergent coast है. The sun temple are built up inside the ocean. Today it is away, 4 kilometers away from the ocean. Diastrophic. Gradually continent is coming up. On the contrary, the diastrophic can be mountain building or continent building. How the continent is gradually rising, we don't know. You cannot feel this. Same way, the Himalaya is rising every day and every year 12 centimeter. So it is very slow. Mountain building, mountain formation is going on. It is not, we cannot realize, very slow. Continent also very slow. Okay. The Dwarka is now submerged. We didn't realize even, gradually it got submerged. So submerged हो गया, downwarping है. Upwarping is the Odisha coast, as I said, upwarping. Downwarping is in case of gradually continent is going down here in the Gujarat coast. It is going up near the Odisha coast. This is downwarping and upwarping. In fact, submergence and emergent coast they are forming. This is what it is forming here. Upwarping in emergent coast. Downwarping is submergent. Emergent and submergent. Upwarping,
emergent, downwarping, submergent. Now, mountain building, here you have like two types, compressional and tensional. If it is like pressure from both sides, compression, going away from each other, tension. Compression leads to folding, reverse faulting, tension due to only normal faulting. This is the things I have just said. I will explain in detail about all these also. So, endogenetic forces can be of two types, slow or sudden. Volcanism and earthquake are very sudden, quick. They are very sudden and quick. You remember this. This type of forces are also there. Planner you haven't got. Planner, in the planner we have given, I have already given this. If not, then day wise I have already given. Okay, I will see, I will ensure that today you will get it. Okay. So, today's planner, as you are asking, planner wise, I have said the topics here. After today, in fact, we have the crustal deformation as the first topic, then earthquake, volcanism and all other things are there. Okay. If it is not given, before one day I will tell you what are the topics you are supposed to do. I thought that you got the planner, if not then I will definitely do it. Okay. So, today as per the plan, we have the topics on crustal deformation, volcanism, earthquake and what else, let me see. These are the topics here, my friends. If you haven't got, I am sorry. I have every day for the entire session, I have the plan here. Yes, here you will get it. मैं आपको प्लानर आज का दे देता हूं, आप उसी के हिसाब से देखिएगा. In the last class, as per the planner, roadmap to GS geography, universe, our solar system, earth's interior, rock and minerals. And today it is crustal deformation, earthquake, volcanism, plate tectonics, current places in news, world map. First today we are having world map. Crustal deformation, earthquake, volcanism, plate tectonics, current. So, I have to go very quickly, and these are the point, these are the things is very important. Prelim point of view, whatever is there, like it's very important for us. This concept they are asking sometimes. Mountain building, example of the mountain they have asked. If you have seen the previous year questions, fold mountain, block mountain, where it is, arrangement of this in terms of their age and all, continent building. That is why I am just giving this. Diastrophic is very slow. Very slow, there are two types, mountain and continent building. Mountain building can be compressional and tensional, two types. Compressional is folding and faulting. Faulting भी होता है compression से. कैसे हम discuss करेंगे. This is okay. Endogenetic forces, you got it. From there I am coming to this. Endogenetic forces are those forces which are formed inside the earth interior. First point. Second, these are energized by the geothermal energy. Third, these forces are constructive forces. These forces develop continent and the ocean first. And of course, in the continent you have mountain, you have plateau, etc. Large structural platform you will get. Inside the ocean, trenches and mountains you will get. So, all these things are endogenetic forces responsible for this. Endogenetic forces are of two types, diastrophic or slow and catastrophic or sudden. The diastrophic forces are of two major types again, mountain building force and continent building force, my dear. Mountain building force they are because of two important other aspect they are associated, like compressional force in which mountain will form, or tensional force, in this also it is formed. So, compressional force, because of compressional force you can have folding or it can have faulting. Faulting is reverse faulting, my dear, you remember this. जो आपने if you give pressure to a rock strata, you have folding, or it will break into one part, one segment move upward, then another one is downward. This is reverse faulting. And tensional force, always if you drag them both on, if it will have divergence, it will have definitely subsidence here and faulting will be there. So, this is here is the faulting. continent building forces, it can be upwarping, matlab the continent will move upward gradually, like forming the emergent coast, and downwarping submergent coast. Please remember this. Catastrophic volcanism and earthquake. Let me discuss from mountain building forces. Compressional force पे आते हैं. Compressional force पे what is there? In the compressional force, folding मैंने कहा, and reverse faulting. How it is? How it is coming like this? Let us see now. This is a continental block, let us say, a huge block of landmass. It is affected by compressional force from both sides. It is affected by compressional force from both sides. Now what will happen? There are two possibilities. If the rock strata will get squeezed, there is a possibility that these rock strata may get folded like this. And in this case, this is anticline, syncline, anticline. Likewise, you have this type, the rock strata will get folded. Folding is there. This is called folding. This is the folding. Or you can have another one as another possibility, faulting. If the rock strata is not flexible, there is a possibility of faulting. There is a possibility of faulting. In case of faulting, what will happen? You see, in case of faulting, what will happen? It will develop crack here. It will move like this. There is a possibility that this rock strata may rise up to this level. Because of more and more pressure, this may goes up. Because of more and more pressure, it will break and it may goes up. The rock strata may go up. This block will move upward here because of more and more pressure. There is a possibility, if more pressure is there, this will break and it will move up, and this leads to formation of a different landform here, and this is here is called as the rift valley or graben. Graben or rift valley. Graben or rift valley. And this side you will have, same way, this side you have horst or block mountain. Block mountain.
here also host or block mountain, host or block mountain. You have the graben here, this is as the graben, this is as the host or the block mountain, graben or the ribbling. These two are present. This type of faulting because of compression is called as reverse faulting. This is called as the reverse faulting. Please remember this. This type of faulting is called as reverse faulting. फोल्डिंग फॉल्टिंग डिफरेंट समझ नहीं आया, चलिए ठीक है अभी कराते हैं. आप folding and faulting you didn't got it, okay. Let me do one thing. You take a piece of bread, okay. ब्रेड को ब्रेड ले लो और जस्ट गिव प्रेशर, ऐसे एक फोल्डेड स्टेटा बन जाएगा. बट द सेम थिंग, सेम ब्रेड को अभी टोस्ट बना लो, देन यू गिव प्रेशर, one part will break, another part will move upward and downward. That is folding. Folding में क्या है? If you look at, if you say the folding part, folding is what? When there is strata will be like this, because of pressure it will have like the it will have bended strata. ये अगर ऐसे है, प्रेशर के वजह से क्या होगा? Because of the pressure, the strata whatever is there like, you will have like lineation. Same way में ये प्रेशर से ऐसे रहेंगे. बिकॉज ऑफ प्रेशर एंटीक्लाइन एंड सिंक्लाइन, एंटीक्लाइन सिंक्लाइन लाइक दिस यू विल हैव. अगर फॉल्टिंग अगर टूट जाता है, आप शीशा ग्लास को लेकर अगर प्रेशर दोगे तो क्या होगा भाई? इफ यू विल टेक ए पीस ऑफ ग्लास एंड गिव प्रेशर, टूट जाएंगे. जब टूट जाएगा तो जहां पे टूटा वो है फॉल्ट लाइन. फॉल्ट लाइन इज नथिंग बट द क्रैक्स ऑन द अर्थ सरफेस, ओके. दो फॉल्ट लाइन के बीच जो एरिया है नीचे अगर चला गया, इफ इट इज गोज डाउन, इट इज ए रिफ्ट वैली. दोनों साइड जो ऊपर उठ गया अगर प्रेशर के वजह से, ये हो गया क्या है? ब्लॉक माउंटेन. द बेस्ट एग्जाम्पल फॉर अस वी कैन से वी हैव द रिफ्ट वैली ऑफ नर्मदा, तापी, दामोदर, सोन, ऑल दिस हैव रिफ्ट वैली, ओके. एंड ब्लॉक माउंटेन विल हैव लाइक दिस बिकॉज ऑफ कंप्रेशन. कंप्रेशन के वजह से अगर ऐसे फोल्डिंग एंड फॉल्टिंग होता है रॉक स्टेटा में, ये हो गया फोल्डिंग है ये. यू सी दैट दिस इज द फोल्डिंग, फोल्डेड स्टेटा. अब मैं प्रेशर दूंगा तो ऐसे होगा ना. दिस इज नोन एज एंटीक्लाइन, दिस इज नोन एज सिंक्लाइन, एंटीक्लाइन सिंक्लाइन, फोल्डिंग में होगा ये. फॉल्टिंग डिफरेंट टाइप है. नाउ रिवर्स क्यों बोलते हैं? रिवर्स इसीलिए बोलते हैं क्योंकि ये जनरली फोल्डिंग ही होता है. एंड दिस केस बिकॉज ऑफ कंप्रेशन इफ इट इज देयर, दिस इज वेरी यूनिक केस. दिस इज नोन एज द रिवर्स फॉल्टिंग. रिवर्स फॉल्टिंग, रिवर्स फॉल्टिंग, ओके. बिकॉज फोल्डिंग नहीं होगा, फॉल्टिंग होगा. बट मोस्ट कॉमनली इफ विल सी, सबसे कॉमन अगर हम इसको ऐसे ड्रैग करते हैं, आप सोचो यहां पे, माय फ्रेंड दोज हु आस्क्ड मी, प्लीज रिमेंबर दैट दीज आर द वेरी फंडामेंटल एंड बेसिक थिंग्स व्हिच वी आर सपोज्ड टू नो. ये ऐसे होगा ब्लॉक. द ब्लॉक विल बी लाइक दिस, इट विल मूव, इट विल हैव, देखो आप ऐसे पैरेलल फॉल्टिंग, एक क्रैक डेवलप होगा. ग्रेजुअली क्या होगा? दिस विल डेवलप. व्हाट इट विल डेवलप यू सी हियर. ये यहां पे अगर ऐसे था ये लाइन, दिस इज द लाइन हियर. this part will sink down. ये हो गया फॉल्ट लाइन, ऑल दीज आर फॉल्ट लाइन, फॉल्ट लाइन, ये भी एक हो गया फॉल्ट लाइन, ये हो गया फॉल्ट लाइन, दिस इज ऑल्सो ए फॉल्ट लाइन। आप एक पीस ऑफ ब्रेड ले लो, दोनों साइड पे खींचो ऐसे, बहुत सारे क्रैक्स आ जाएंगे, ये सब फॉल्ट लाइन है। और दो फॉल्ट लाइन आप लो ना, एक पीस ऑफ पेस्ट्री लेके आप दोनों साइड खींचना ऐसे, मिडिल में सिंक कर जाएगा, ये हो गया रिफ्ट वैली। द मिडिल सिंकिंग पार्ट इज कॉल्ड द रिफ्ट वैली, इट इज कॉल्ड एज द रिफ्ट वैली, दिस इज व्हाट इज कॉल्ड एज द रिफ्ट वैली, this is called as the rift valley or graben or rift valley. This is known as the block mountain or host. This one is also HORST, host or block mountain. ये एरिया धीरे धीरे करके इरोजन होके ये बन जाएंगे माउंटेन जैसे से ब्लॉक माउंटेन। बेस्ट एग्जाम्पल वी कैन गिव हियर इन इंडिया इज हियर इज विंध्यान रेंज इज ए ब्लॉक माउंटेन, सातपुरा इज ए ब्लॉक माउंटेन, इन बिटवीन नर्मदा is a rift valley. Narmada river is a rift valley. It is flowing through a rift valley. Best example is this one. This is because of what? Divergence. So this is called as, normally it will happen normal faulting. Normal faulting का किसको बोलते हैं? जब faulting which normally develop, generally they develop, they are called as normal faulting. The faulting which develops normally or generally is known as normal faulting. Faulting which develops generally or normally is known as normal faulting. Normal faulting का best example मैंने आपको दिया है भाई. In India you are having all these things, you can see that. Can you see? आप ये तो याद हो जाएगा अभी. Is it clear to you, my friends? It generally happen, that's why it is known as normal faulting. Is it clear? Rivers क्यों बोल रहे हैं? Because ये नॉर्मली नहीं होता है. रिवर्स फॉल्ट इसलिए कहते हैं कि देखो यहाँ पे ये भी देखो, एंगल देखो ना, ये कैसा है, इसका एंगल देखो ऐसा है. नॉर्मली क्या होना चाहिए? एंगल ऐसे होना चाहिए. इस पे देखो, दिस विल मूव फास्टर, ये उल्टा है, रिवर्स जा रही है. फॉल्ट लाइन की डायरेक्शन देखो, जनरली क्या है, इस टाइप का है फॉल्ट लाइन. यहाँ पे प्रेशर की वजह से यहाँ पे फॉल्ट लाइन कैसे बनेंगे? ऐसे फॉल्ट लाइन बनेगा. देख रहे हैं आप, ये फॉल्ट लाइन देख रहे हो ना, ऐसे बन रहा है. फॉल्ट लाइन इज फॉर्मिंग इन दिस वे. बट यहाँ पे देखो उसका उल्टा है, बन रहा है फॉल्ट लाइन. कैन यू सी दिस? बिकॉज ये जो अपर पार्ट का जो मेटेरियल है ना, इट मूव फास्टर देन द लोअर पार्ट, अपर पार्ट. And here also the same things, upper part move away faster than the lower part, and this is normally it will happen because of the tensional force. Normally you will have crack known as faulting. So normal faulting, generally you will not get it like this. In case of compression, mostly folding is there, and this is very rare case, that's why known as reverse faulting. Are you okay with this? आपको समझ में आया क्या भाई? My friend who asked me this question, you got it? Now let me give you example. Mountains are formed due to folding or fold mountains. Fold mountains. Fold mountains are example are, you have your Himalayas, they are in Asia. You have Atlas mountain in Africa, Alps mountain, Alps mountain in Europe,
we have same way Andes in South America. Likewise you have Rocky Mountain, Rocky is in North America. Same way we have, these are like, all these are young-fold mountain. They are called as young-fold mountain. Number 6, you can go for Appalachian mountain. Appalachian in the USA. Number 7, Ural mountain, Ural in Russia. Number 8, you have your Aravalli is in India. So all these 3 are called as, these are old fold mountain. These are called as the young fold mountain. Young fold mountains are those mountains which form between in the tertiary period. I mean, if you look at the age of this mountain, they are very young as compared to this one. These are formed somewhere nearly 56 to 1.6, 56 to 1.6 million years ago they develop. ये आज से करीब 56 to 1.6 million years ago ये बनी है. Old fold mountain are, these are older than or more than 650 million, more than 320, more than 320 million years. और ये तो आरावली को बोलते हैं प्री कैम्ब्रियन फोल्ड माउंटेन. प्री कैम्ब्रियन फोल्ड माउंटेन, प्री कैम्ब्रियन ओल्ड फोल्ड माउंटेन सबसे ओल्डेस्ट है. ओल्ड फोल्ड माउंटेन, it is around 650 to 2600 million years ago it was formed. ये बहुत पुराना है. Aravalli is the oldest among all. ये हिमालय, all these mountains were formed due to foldings known as fold mountain. Please remember, Appalachian, Ural, Aravalli, all these are there. These are the mountains here. Are you got it? Now it is clear. So young old fold mountain के भी 3 सब डिवीजन है. हर्सेनियन आपको पता होगा. सो प्री कैम्ब्रियन आपका वो सब डिवीजन में नहीं जाएंगे हम अभी. अपलेशियन, यूरल, अरावली, तीनों ओल्ड फोल्ड है. ओल्डेस्ट वन इज अरावली, यू रिमेंबर. उसके बाद अपलेशियन, यूरल ये जो आएंगे. ठीक है ना, इतना याद हो सकता है. आई होप यू एबल टू मेमोराइज दिस मच. फोल्ड माउंटेन्स, यंग फोल्ड माउंटेन्स, Himalaya, Atlas, Alps, Andes and Rocky. These are very young fold mountain these are. And the older one is like Appalachian, Ural and Aravalli. Appalachian and Ural are they are old fold mountain, but generally younger than the Aravalli. Aravalli is 650 to 2600 million years ago it was formed. It was much older than the existing rest of the mountains. Is it clear to you? Hope it is clear. So in the crustal deformation part, as I did said, ये जो आपको मैंने कहा crustal deformation में diastrophic force and catastrophic. पहला मैं mountain building compression से बोला, then tensional force, normal faulting. I hope mountain building के compression, folding, reverse faulting, normal faulting ये हो गया. You got it now? Clear है? Okay. Please do respond when you are getting the things. If नहीं आया तो बोलिए. Thank you very much that you asked me. समझ नहीं आया था तो. I will go for now discussion on continent building. Continent building में देखो बहुत ही important है ये. These are very slow and it is not at all, you cannot perceive it, imperceptible होता है, बहुत ही slow होते हैं, very difficult to imagine even. My friends, though आपका उड़ीसा कोस्ट में एक आइलैंड है जिसका नाम है व्हीलर आइलैंड, you know it. Wheeler Island is now named as Dr. APJ Kalam Island, where you have Agni 5 and all these are tested. Missile testing range hai. Nearby, there is a place known as Chandipur. Chandipur regions, very interestingly, during the high tide regions and low tide regions, if you will see every day that the water goes up to 3 kilometers inside and again come. 3 किलोमीटर तक पानी चला जाता है समुद्र के अंदर, फिर आते हैं. You can walk even inside the ocean floor, I mean. 3 किलोमीटर अंदर जब जाते हैं. This is a very unique phenomena. Why it happened, you know? ये ocean का floor है, नीचे ऊपर उठ रहा है. This is known as upwarping. Upwarping, emergent coast. East coast of India is emergent coast, my friend. This is what is upwarping. Gradually it is happening. We are unable to see this. We feel the things gradually. Another things we can say, you know, there is a sun temple known as at Konark. Sun temple is there at Konark in Odisha. It was built up inside the ocean. Today it is 4 kilometers away from the ocean. यानी कि नीचे से पानी दो फैक्ट हो सकता है. One is the water is gradually drying in the ocean, or second is the continent is rising up. Water कम नहीं हो रहा है. It is in fact the continent which is move upward from the below. Ocean floor is rising up. This is known as emergent coast. My friends, you remember the coast of east coast of India is emergent coast. Please remember, east coast of India is emergent coast. East coast is emergent coast, my friend. Likewise, you have downwarping is there submerged. अभी मोदी जी ने गए थे ना यार, वो राम मंदिर के टाइम पे, he went inside and worship somewhere like, you know, inside the Dwarka. Dwarka is completely submerged today. दिल्ली वाले भाई लोग, आपका द्वारका नहीं, आई एम टॉकिंग अबाउट गुजरात द्वारका. डाउन वार्पिंग अंदर ही चला गया है. द द्वारका सिटी इज नाउ सबमर्ज्ड. द व्हाइट इज दिस कोस्ट इज सबमर्जेंट कोस्ट. माय फ्रेंड्स, वन मोर थिंग आई कैन से, इफ यू लुक एट दिस पार्ट, ये जो हमारा इंडियन पेनिनसुला है, इसको देखा है ना आपने सही से? हैव यू सीन दिस? आपको बताना चाहूंगा, अपना मैप में देखो, अटलास अगर है, यहां पे देखो, ये जगह पे डेप्थ कम होगा, कलर थोड़ा फेडेड होगा. ये अरेबियन सी है, ये अरेबियन सी है, ये अरेबियन सी. एंड दिस साइड यू हैव बे ऑफ बंगाल, बे ऑफ बंगाल. कैन यू सी दिस दैट दिस रीजन हैज ए वाइडर कॉन्टिनेंट, इसको बोलते हैं कॉन्टिनेंटल सेल्फ. वाइड कॉन्टिनेंटल सेल्फ इन द व्हिच रीजन? इन द वेस्टर्न पार्ट, western coast, Arabian Sea coast. We have wide continental shelf here. The wide continental shelf in this region is primarily because this region is submerged. This region got submerged now under this, you know, a submergent coast hai. This area was earlier part of the continent got submerged. So it is known as the submergent coast, my friend. This is the submergent coast. Submergent coast. And that's the cause, you know, this region you have natural port also. आपने देखा होगा, you must have seen the things like here is Narmada, here is Tapi, these rivers, and most of the river while they are draining, they are forming a very deep profile at the mouth known as estuary, estuarine coast, estuarine coast, estuarine coast. Because estuary किसको कहते हैं? When a river valley got submerged inside the water, river का mouth जो है ना, उसका जो river जहाँ समुद्र में गिरता है, पूरे माउथ, पूरे एरिया जो है ना पानी में डूब गया. बिकॉज ऑफ व्हाट? डाउन वार्पिंग हियर. एंड दिस रीजन इज नोन फॉर दैट, लाइक यू नो, नेचुरल पोर्ट. ऑलवेज यू रिमेंबर, नेचुरल पोर्ट्स विल डेवलप व्हेन there is a deep profile at the mouth of these rivers. You have very deep profile known as estuary. There is no much deposition of sediment here, and these deep profile are responsible for giving good quality, good number of natural port in these regions. This is here is very important, you remember. On the contrary, this side, all the river which are flowing this way, you can see all these rivers here, whatever river they are draining in this part. You have Krishna, Godavari, Peneru, here it is, Kaveri, all these are forming delta, and these regions you have like gradually going up. This is here, it is going upward, this is moving upward. I mean, this one is emergent coast. This side you have the emergent coast, emergent coast, emergent coast. That's why I said here is the sun temple is now exposed. This is at submergent coast. This one is submergent coast is submerging, coast is emerging here. These are very gradual, it is happening, you are unable to see, you are unable to perceive, you are unable to look at this carefully, like okay. Upwarping gives more fertile land, your friend is saying. No, my friend, because upwarping doesn't mean always fertile land. This is from the ocean floor, we will have salt is there, salt pan. You have upwarping here. Likewise, you remember one thing, ये वाला एरिया जो है ना, ये वाला एरिया भी अपवार्प हुआ है, रिमेंबर, ये वाला एरिया ऊपर अपवार्प है, ये वाला रीजन कौन सा है, व्हाट इज दिस, व्हाट इज हियर, इट इज रन ऑफ कच्छ एरिया. रन ऑफ कच्छ, डू यू नो, run of Kutch, run of Kutch, run of Kutch is going upward, and this is like ये रीजन से टूट रहा है, ये फॉल्टिंग इज देयर, यहाँ पे फॉल्टिंग हो रहा है, ये सब फॉल्टेड लाइन डेवलप हुआ है. लेट मी टेल यू, ये नीचे जा रहा है, ये ऊपर जा रहे हैं. देयर इज ए केस ऑफ लाइक ऐसे faulting, here it is going down, it is going up, going down and going up. This is a very completely complicated things here, where you have the upper part, Rajasthan ke coast ke taraf. If you will go to a Rajasthan coast, a very interesting thing, it is going up, here it is going down, this side going up. It means it is an emergent one, and my friend, that's the cause. The run of Kutch is exposed from the sea floor. As you are asking, we will have, do you have fertile land? No, no fertile land. Fertile land nahi hoga. For an example, this is here, but maybe in future there is a possibility, of course. Friends, as I said, ये वाला जो है ना, यहाँ तक है, यहाँ पे एक फॉल्ट लाइन है जिसका नाम है मालदा फॉल्ट. ये मालदा फॉल्ट तक, ये मालदा फॉल्ट है, अप टू मालदा फॉल्ट, अप टू मालदा फॉल्ट, यहाँ तक ये अपवार्पिंग है, उसके ऊपर नहीं है, इस तरफ नहीं है, नॉर्थ ईस्ट के तरफ. रिमेंबर, and these are the things responsible for so many things. My friends, I request you all to read India Physical Geography. There is a chapter on drainage system, and you will find out in page number 27, I think. You can check it out, how the peninsular drainage is evolved, and in there it is given in detail. You are requested to see. You will find out the faulting here. This part is going down, यहाँ पे, here, during the Himalayan formation, this part is going this way. That's why you have a lot of stretch, and here you have formation of faulted valleys. Fault lines are developed. By the way, as I was talking about folding and faulting, here is your friend is saying, upwarping is the region of faulting, downwarping reverse faulting. No, upwarping, you see, compression is the region of, upwarping हम नहीं कहेंगे. Always you remember, downwarping reverse faulting जो बोल रहे हो ना आप, ऐसे नहीं है. Always you remember, downwarping और upwarping can be because of any cause. आप जो यहाँ पे देखा ना, you cannot conclude, ये downwarping नहीं है क्या, ये normal faulting में downwarping हुआ कि नहीं, ये बताओ, ये downwarping है कि normal faulting में. Now you cannot conclude like that, as you have said. और this is here is upwarping हुआ कि नहीं यहाँ पे, in case of reverse fault. आपका तो opposite हो, आपका जो perception है उसके opposite. Upwarping in case of region of faulting, downwarping reverse faulting. देखा आपने, upwarping और downwarping केवल faulting से काम नहीं है. There are a lot of other factors. नीचे जो है ना, on the mental layer we have a very dynamic layer. Today we will discuss, you will get the clarity by the end of today's session. I would like to say, inside the earth interior there is flow of different magma and all, and wherever it is there, from below अगर magma plume अगर है, ऊपर से नीचे से ऊपर thrust देगा तो upwarping हो सकता है, compression से भी upwarping हो सकता है. Okay, we'll look at this, my friend, just wait, we will get it. मैं पूरा आज क्लियर करा दूंगा, आप देखना, you will have the clarity on this subject if you have any problem. Is it clear to you? Folding, faulting is clear to you? मुझे इतना बता दो, बाकी मैं आगे चलता हूँ, देखता हूँ इस पे. Volcanism and earthquake also they are. मुझे ये सब डिस्कस करना है अभी. Folding, faulting, you got it. Volcanism and earthquake. So the western coast of India is submergent coast, but almost all rivers flow eastward because India is sloped towards eastern. So what is the actually happening? Okay. आपने अभी आप इफ यू हैव द एनसीईआरटी, कैन यू जस्ट लुक एट ड्रेनेज सिस्टम का बात किया था ना मैं, उसमें 3 कंडीशन लिखा है. एक पेज नंबर 18 में जियोलॉजिकल टाइम स्केल है, देखो इन पेज नंबर 18 में जियोलॉजिकल टाइम स्केल इन द फंडामेंटल्स ऑफ फिजिकल ज्योग्राफी, यू विल सी दैट. उस पर भी साइड पे जियोलॉजिकल टाइम स्केल. एंड क्लास 11th इंडिया फिजिकल एस्पेक्ट ड्रेनेज चैप्टर में देखो, यू विल फाइंड आउट वेस्टर्न लास्ट बट 1 पेज ड्रेनेज चैप्टर की, you will find out a paragraph is written about how and why the western the peninsular rivers how it evolved, clearly mention किया है. Your question is regarding this one and I do expect all of you will study today itself, जाके आज पढ़ लीजिएगा. वेस्ट कोस्ट ऑफ इंडिया में जो इस तरफ जो होने का मेजर कॉज क्या है. योर क्वेश्चन इज ऐसे क्यों इधर जा रहा है, बिकॉज देयर आर, अगर पूछ लिया तो अभी बता देता हूं भाई. एक चीज देखो यहां, this part is going down. Okay, let me show you this, that will be better for us. Okay, आप यहां देखो, here you can see, please look at this side. You have a plate known as, this is Eurasian plate, you know it, Eurasian plate. This side the Indian plate is going, Indian plate. They are converging here. Because of convergence क्या हो रहा है, Indian plate is going below the Eurasian plate, because Indian plate has part of the ocean also. As I told you in the last class, ocean crust is thin but more denser. Oceanic plates are more heavier, denser one. Indian plate has some part of ocean also. As compared to Eurasian plate, Indian plate is heavier or denser. So जब ये दोनों मिलेंगे ये नीचे चला जाता है. Here it is going down, here there is down warping. आप सोचो एक बात, इधर जा रहा है, इधर डाउन वार्पिंग है, तो मिडिल में क्या होगा भाई, मिडिल में यहाँ पे क्रैक डेवलप हुआ. दिस क्रैक्स आर कॉल्ड एज व्हाट, फॉल्ट लाइन. नाउ एट दैट टाइम व्हाट हैपेंड, इस तरफ जो है ना ये प्लेट जाके टकराता है, यहाँ पे इधर पटवार प्लेट और ये सब जो है, यहाँ पे हो गया आपका व्हिच नॉट पामीर है, यहाँ पामीर प्लेटू है, ये डेवलप करता है. इधर से थ्रस्ट होता है, ये थोड़ा ऊपर उठ जाते हैं, एंड दिस विल बी लाइक दिस, ये ऊपर आके ऐसे होगा. दैट्स द कॉज, यू नो, दिस साइड, ये जो रीजन्स है, ये पूरे रीजन्स थोड़ा उठ जाते हैं, एंड दिस लीड्स टू दिस साइड यू विल हैव हियर डाउन वार्पिंग. सो सब नदियां जो है ना, जो स्लोप, जनरल स्लोप जो होगा ना ऐसे होगा, जनरल स्लोप इज लाइक दिस, and that's why the rivers are flowing like this. And another cause आपको बता दूं, ये जो रीजन से यहाँ पे वोल्केनिक इरप्शन होके उससे पहले आपकी ये भी हुआ है, जो रियूनियन हॉटस्पॉट वोल्केनिक इरप्शन वाज देयर आल्सो. दिस इज आल्सो ए मेजर कॉज. सो उसका मेनी फैक्टर्स आर रेस्पॉन्सिबल फॉर दिस, नॉट ओनली वन, बहुत सारे फैक्टर्स. Run of Kutch, emergent, submergent coast this side, this lot of such type of, you know, factor responsible for this. By the way, let me come to this point again. Hope that folding, faulting and down warping and up warping you got it to some extent. कुछ तो पता चला आपको. Now ब्लॉक माउंटेन कहाँ कहाँ है, ये तो फोल्ड माउंटेन का बात किया मैंने. फोल्डिंग से फोल्ड माउंटेन हो रहा है, बिकॉज ऑफ फोल्डिंग फोल्ड माउंटेन हुआ. वेयर इज द ब्लॉक माउंटेन, नोट डाउन नाउ.
Block mountains. Where is the block mountain? In the prelim, they are asking question about examples also. What are the major block mountains? What are the major block mountains? Block mountains here are like number 1, Vindhya, Satpura, Western Ghat also block mountain. 3 are block mountains here. ये तीनों ब्लॉक माउंटेन है. Vindhyan range, Satpura range and Western Ghats. All these 3 are block mountains here. Again I am saying Vindhya, Satpura and Western Ghat, they are block mountain. We have same way, all these are in India. You have Salt range. Salt range is in Pakistan. Salt range is a block mountain. We have, as I was saying, Germany में Rhine, Rhone, the Rift Valley Rhine, as you know, Black Forest near this Rhine, Black Forest in Germany is a good example of block mountain. Now coming to the Rift Valley rivers. Rift Valley तो बहुत सारे डेवलप है इंडिया में. नर्मदा is a Rift Valley river. Tapi is a Rift Valley river. Damodar is a Rift Valley river. Narmada, Tapi, Damodar. We have Son river is a Rift Valley river. Narmada, Tapi, Damodar, Son. What else? The most important Rift Valley rivers, others Rift Valley rivers are. I told you about a river here in Rhine, Ruhr. River Ruhr and Rhine, they are in which regions? They are in Germany. These regions are all the Rift Valley rivers. So these are already the rivers which are developed, which are flowing through the Rift Valleys. They are Rift Valley rivers. They are flowing through the Rift Valley, so they are Rift Valley rivers. Okay. So these are certain things. I hope you got it. This part is clear. यहाँ clear है क्या सबको? Now I'll go for another things as you have mentioned, volcanism and earthquake. I'll do earthquake, volcanism sudden है, quick है, but before that we need to know about another things which is called as plate tectonics, which is there in our topic of discussion today. तो मैं एक काम करता हूँ, ये जो डिस्कशन में I would like to say certain things. Earthquake, volcanic plate tectonics hai. So to know about this plate tectonics, I would like to just give you an idea. The dynamic earth. My friends, the earth surface is very dynamic, and our earth, as I have already said earlier, our because of gradual cooling of the earth, different part, particularly the upper part, because of the rate of cooling is different in the upper part as compared to the inner part, there is a differences. When it is cooling, gradually it is squeezing. Because of the squeezing of this and cooling and squeezing, what is happening here? Because of cooling and squeezing of this entire earth, the forces from earth inside also coming up. This leads to misbalance or disbalance and the formation, fracturing of these, and these are called as, each of these are known as plate. Total earth is divided into several blocks known as plates. Okay, now we have named these blocks as the plates, but earlier the people were in fact the scientists they believe that there is a unified earth continental part known as Pangea. It got split up into several parts. Okay, question in the mains only they are important, but we should know the names at least. First, I would like to tell you, according to P. Taylor and Alfred Wegener, there was a super continent called as Pangea, surrounded from all sides by a super ocean, Panthalassa. Pan mean all, thalassa mean water. Pan mean all, Jia mean earth. Okay, Panthalassa. This Pangea got split up into two parts. क्या क्या था? One is Laurentia, another one is Gondwana land. So, earlier there was one supercontinent. This supercontinent was surrounded in all sides by, this is Pangea, Panthalassa. This one was Pangea. This Pangea got split up into two parts. One part moved northward, another southward. So, the Pangea which moved northward, another one is southward. The Pangea which moved northward and southward, this word, the northward going one was known as, this was as Laurasia or Angara land. or Laurasia. Southward was Gondwana land. Gondwana land. And in between them we have a water body known as Tethys Sea. Here you have the Tethys Sea. तो ये जो है ना, this is they got in fact divided due to forces, causes of drifting. उसने बहुत इंटरेस्टिंग बात बताए थे, पर्टिकुलरली अकॉर्डिंग टू अल्फ्रेड वेगनर. आपको याद दिला दूं, यहाँ पे दो नाम बताया मैं, पीजे टेलर एंड अल्फ्रेड वेगनर. अल्फ्रेड वेगनर रिगार्डेड द फादर ऑफ continental drift concept. Continental drift concept. You remember this. Father of continental drift is Alfred Wegener. P.J. Taylor, Peter Taylor जो है ना, he gave earlier, but no scientific idea he has given, like no theoretical idea he has given. Only Alfred Wegener has given. That's why the father of continental drift concept. According to Alfred Wegener, there is one supercontinent known as Pangaea, surrounded also by Panthalassa. This Pangaea got split up into two parts, Angara and Laurasia land and the Gondwana land. The causes of drifting, he said, very interesting. One, the tidal force of moon and the sun, very interesting. Another one, he said, polar fleeing force due to the earth's rotation. ये सब these are he said, but these are not theoretically or scientifically proved. ये scientifically accepted भी नहीं है. These are not at all scientifically acceptable even. We cannot accept this even scientifically. This is okay. So we have Tethys Sea developed, Tethys geosyncline developed because of drifting of two sides. दोनों sides जब drift हो गया तभी ये हुआ है. Because of drifting it happened. In fact, due to drifting, Gondwana land and Angara land, they got drifted because of these causes, as he said. Now what happened? The India here in Gondwana land itself, according to this. Now this was a theory. Subsequently another theory came out by Harry Hess known as sea floor spreading. By the way, ये जो theory में Gondwana land में कौन कौन सा थे? In the Gondwana land you have, it is like this, you see. This is Antarctica, this is Australia, this is India, this is Africa, this is South America, and all these, in fact, these they got drifted away. All of these they got drifted away from each other. All these combinedly, they said like this was the zone of what? This was as Gondwana land. उसको उन्होंने बोला था क्या? Gondwana land. Gondwana land, they got split up like this into different continental parts subsequently. ये तो theory है उनका. Later on another theory came out in the name of, this is what he said, and he said about the fossils evidences, or both are evidences he has given. Fossils evidences in which he said the same type of fossils which you will find in India, यहाँ पे जो मिलेगा यहाँ भी वही है. ये regions पे same fossils you will get. He said there is a Glossopteris which you will find in these regions as well as ये पूरे region में Glossopteris a plant fossils आपको मिल जाएंगे. So he talked many things about this. फॉसिल सब है, तो ये सब
These are, I think they are not going to ask you the evidences and all. In the mains, they have already asked. They will not give you questions on this. But yes, driving force they can ask. And what is that? Gondwana land, Langara land, you know. Which one among the following was a part of Gondwana? Ye to hai, Gondwana land mein. If at all they will give. These are the countries, continents, South America, Africa, India, Australia, Antarctica. Is it clear? Clear hai itna. Kafi hai. Now, another concept is known as sea floor spreading. This concept was given by Harry Hess. और एक concept आया जिसका नाम है sea floor spreading. Concept of sea floor spreading. It was given by Harry Hess. Harry Hess gave this particular concept. According to him, जैसे अभी हमने आपको अभी बताया था कि भाई if you look at the case of South America, and I'll give a small मैप बनाता हूँ, बेटर रहेगा ये कि भाई ये जो रीजन्स है, फॉर एग्जाम्पल what is this continent? You know it. According to Harry Hess, and Harry Hess during his findings, he found like a very interesting thing that this continental part here, you know, here he found that there is a mountain at the middle, and this mountain here at the middle, which is there, a volcanic mountain, he said. A volcanic mountain located at the middle of this Atlantic. This is the Atlantic Ocean. In the Atlantic Ocean, he found that the middle of this Atlantic there is a mid-Atlantic ridge. Mid-Atlantic ridge, a mountain at the middle of the Atlantic Ocean. And he found a very interesting thing. He found that this edge of the rock, if you'll see, is going, if you'll go away from here, the edge of the rock is gradually increasing. Edge of the rock is gradually increasing. ये आप ना जैसे ये middle part of the ocean से इधर जाओगे, edge of the rock is gradually increasing. He found in his survey. Who? Harry Hess. Harry Hess. He gave the concept of sea floor spreading. According to Harry Hess, the earth ocean floor are dynamic in nature. While he was studying the Atlantic Ocean floor, he found edge of the rock is increasing away from the center towards the periphery. Here he got it like 10 million, here it is 100 million, here it is 200 million, here it is 10 million, 100 million, 200 million. यहाँ पे जो मिडिल में जो है ना सब रिसेंट आया, आर मीन रिसेंट. अभी उस पे जैसे कि वोल्केनिक इरप्शन हुआ है, रिसेंट वोल्केनिक इरप्शन इज देयर, then rock of size are there increasing, their age is increasing away from the center. Then he found array it is only because of possible only if there is spreading of this and continuous volcanic eruption is there. He said the total earth की जो है ना ये वाला area जो पहले joint था, they got splitted up and then that's why only it is developed. Now यहाँ पे भी देखो आप, you can see here, आप यहाँ पे देखिए ना ये regions पे, ये क्या हो रहा है Red Sea में, this is the Red Sea regions here. तो रेड सी में क्या हो रहा है, दिस इज द रेड सी, आई सेड रेड सी एज इफ समबडी हैज ओपनड अप वेरी यू नो फोर्सफुली, समबडी हैज डन लाइक दिस. यहाँ पे ये देखिए, ये इधर पे आप दीज रीजन्स हियर लाइक यू नो दीज आर द रीजन्स हियर there is a forces here, tensional force यहाँ पे है. तो यहाँ पे ये भी बताते हैं कि this theory says that earlier this particular ocean was formed because of the divergence. Both sides there is a divergence, maybe for that reason it has happened. And the sea floor, Atlantic Ocean was developed because of this. Sea floor is spreading, this concept given by Harry Hess, and this paves the way for a dynamic earth concept of plate tectonics subsequently. My friend, where you are saying Indian tectonic plate is splitting in the two beneath Tibet, sir, kindly explain. This is a recent discovery which you have done. I will discuss in the plate tectonics. ये जो concept है अभी एक opinion है, it is not proved yet. It was only in studies paper में आया था जो बीच में, and there are some American and Soviet American scientists, they are saying that this is happening now. By the way, देखते हैं क्या है. But the most important point here is like Harry Hess gave the concept of ocean floor spreading or sea floor spreading. Alfred Wegener gave the concept of drifting container. दोनों याद होगा. Now, another concept which I will discuss in detail about this will be about your, in detail अगर discuss करेंगे तो हम आगे देखते हैं, is about the plate tectonics theory of plate tectonics. आपको बताना चाहूँगा बिफोर गोइंग फॉर दिस, अभी तक जो भी हमने करा रहे हैं जियोमॉर्फोलॉजी का क्वेश्चन इज वेरी लेस. क्लाइमेटोलॉजी में ज़्यादा क्वेश्चन आते हैं तो वेटेज थोड़ा कम देते हैं. स्पीडली जाने का मेजर कॉज है, इम्पोर्टेंस इतना ज़्यादा नहीं है, मगर आ भी सकते हैं बिकॉज सो मच ऑफ थिंग्स एज यू हैव सेड अबाउट द हिमालयन रिसर्च एंड ऑल. सो टू गिव द लिंक आई नीड टू नो, आई नीड टू टेल यू सर्टेन थिंग्स अबाउट दिस बेसिक थिंग्स. आई होप यू गॉट इट नाउ. सो यहाँ पे जो हम लोगों ने डिस्कस कर रहे थे इन दिस पर्टिकुलर पार्ट, आई सेड अबाउट दिस आई थिंक क्लियर टू यू. वल्कानिज्म एंड अर्थक्वेक अभी हम करवाएंगे विद द प्लेट टेक्टोनिक्स. ये भी आज तो ये तो है नहीं ये एक्सोजेनेटिक का, बट आई विल गिव यू द बेसिक कंसेप्ट्स ऑन दैट. नाउ आई एम सेइंग इन दिस पर्टिकुलर रीजन्स द कॉन्टिनेंटल ड्रिफ्ट कंसेप्ट, ड्रिफ्टिंग ऑफ द कॉन्टिनेंट, द कंसेप्ट इज गिवन बाय Alfred Wegener. Prior to this, Major P. Tyler also gave. Pangaea and Panthalas I talked about. Splitting of the continent into two parts, and in between you have Tethys Sea. And do you know this Tethys Sea का बात जो कहे है अभी, ये Tethys Sea अभी भी है. ये वाला रीजन जो है ना Tethys Sea वाला एरिया है. कौन सा? ये Mediterranean Sea is a part of Tethys Sea. The Himalaya was a part of Tethys Sea, which got subsequently folded. And how and why it folded, what exactly has formed, we'll see. You got it now? We'll continue from this concept of plate tectonics now. This is a concept, in fact, which consider the concept earlier given concept of Alfred Wegener and Harry Hess, a combined concept which includes, I can say, the basic philosophy of continental drift, seafloor spreading, and there is an Arthur-Holmes convection current theory. So please note down here. A comprehensive theory which includes the basic concepts of continental drift given by continental drift, sea floor spreading, and convection current.
theory. Convection current theory was given by Arthur Holmes. Arthur Holmes. Remember, this one sea floor spreading was given in 1961. 1961. Continental drift theory 1912. Author of convection current theory in 1934-36 around 1936. Now, this theory is the second theory. Sea floor spreading is the latest one, 1961. All this theory, a combined version of all these, a combined version of all this concept here, okay, is in the theory of plate tectonics. Now, what exactly is this theory talking about? What exactly this theory in fact explain? My friend, to be very frank, this is a revised version of the same thing. It's just like old wine in new bottle, nothing else. The same basic concepts are there. Continental drift and sea floor spreading, whatever concept, and with the convection current theory of Arthur Holmes, whatever they have given, the same thing in a very systematic manner it was explained. It was in a very systematic manner it was given. So, what is there? Like, let us see in the theory of plate tectonics, what is there? Let us see here. According to this theory, like the entire Earth surface. This theory is given by, as you know, Mr. Morgan Wilson, Parker, Mackenzie, Wilson, Tujo Wilson, La Pichan, L. Cyber. You don't have to remember all these names, but ये तीनों तो नाम याद करना पड़ेगा. Morgan, Parker, and the Mackenzie. These three people, they initiated, gave the concept of, in 1967, 66, 67, in fact, they gave the concept of plate tectonics. Plate tectonics. They gathered all the information, whatever available information earlier there, and they gave this concept of plate in 1966, 67. Morgan, Parker, and Mackenzie, these three people combinedly. By the way, Tujo Wilson, La Pichan, and L. Cyber, they also contributed. Tujo Wilson, he gave the Wilson cycle concept. Tujo Wilson defined what is a plate, okay, and all. ये तीनों जो हैं, तीनों प्राइमरी वर्क किया है, तीनों लोगों, मॉर्गन, पार्कर एंड मैकेंजी, ओके, ये नाम याद रखिए. मगर एक और नाम you can memorize here, like Tujo Wilson. He gave the Wilson cycle, Wilson cycle on tectonic, and Tujo Wilson defined what is a plate. Okay, according to Tujo Wilson, which was subsequently given as a point of plate tectonics, Wilson, plates are fragmented parts of the Earth's lithosphere located above the asthenosphere. Located above the asthenosphere. According to Tujo Wilson, plates are fragmented part of the Earth's lithosphere located above the asthenosphere, which has the ability to move in different direction different directions based on the convection currents from the mantle, which has the ability to move in different direction based on the convection current from mantle. Again I am saying what exactly it is saying, that plates are according to Tujo-Wilson. What are these plates? According to Tujo-Wilson, plates are the fragmented part of the Earth's lithosphere located above the asthenosphere, which has the ability to move in different direction based on the convection current from the mantle. So, if I will say this particular thing here, if this is the Earth's surface, if this one is the asthenosphere, at the middle part you have the, here is the core of the Earth. Okay, this is the core of the Earth. Now, what will happen? As per this, like the okay, this type is the Earth surface, and here you have the asthenosphere. If this is the asthenosphere here, this is the asthenosphere. If this is the asthenosphere, above this entire part is known as lithosphere. इसको बोलते हैं क्या? Lithosphere. So, according to this theory, this lithosphere is segmented into different parts. These are segmented and fragmented here into different parts. Because of the convection from below, they are fragmented and segmented into different parts. Now, let us say this is a ocean here. Here you have the water bodies. Is a water bodies here. This is the water body. Here you have the water bodies. This is the ocean floor, part of the ocean floor here. Now, what happened? As per this system, like here, this is convection current cell. What is this? Convection current
cell. Now this convection current cell is there, here it is splitting, it is strike over this region, and this particular regions you have splitting up of this part, here you are splitting up of this part. यहाँ पे क्या हो रहा है बताओ? Here what is happening? This side you have, that's why convergence is there. Here you will have folding. Because of this you have folding here. Here also you have folding. Why? Or reverse folding maybe. Which force is there? Compressional force is here. Which force? Compression. Here it is compression. And this side you have the tensional force. Tensional force. Here you have tensional force. तो यहाँ पे देखो, यहाँ it is giving tensional force and here is compressional force. There is a possibility even it can have like compression or it can goes like this, like यहाँ पे टूट भी सकता है ये, it can break. So we have a plate here. These are the plate. This segmented part is a plate. All the fragmented and segmented part are called as plates. These plates are moving on the basis of what type of convection current is there. You see here, faulting and folding both are associated with this type of characteristics here. Divergence you will have. Divergence leads to faulting here. Divergence leads to faulting के बाद क्या होगा? ये टूट जाएंगे. One plate will develop here. One plate, new plate will develop here. This is a plate. Total Earth is divided into several plates. Our Earth is divided into, Earth's surface is divided into several plates. Now, as I just have mentioned about this type of plates you will have. If I'll go for an image here, image of plates. हम देखते हैं एक प्लेट का ऊपर. You can see the total Earth is divided into several plates. You can see here. Total Earth is divided into several plates. You can see. These plates are going in different direction. They are going away from each other. They are coming towards each other. This is based on what? ये जो है ना, ये कहाँ पे कैसे प्लेट देखो आप. How the plates are moving from one another. ये they are coming towards each other. Here they are divergence is there, somewhere convergence, somewhere divergence you are having. On this we have somewhere divergence and somewhere convergence also. As we know, inside the Earth interior, in the Earth interior we have different molten material, and these molten materials are essentially responsible for this type of, as all of us were well aware about this. Inside the Earth interior, we have the molten material, and here you have like convection current in the water. जब आप पानी को गर्म करते हो, whenever you are boiling the water, the bubbles from below goes up again, come like this. Have you seen this? Same way from the Earth interior, here it will start, okay, goes up, then it will go like this. So in this way, here if it is there, I have given an example, anywhere it can be. Now they will form a complete cycle here, complete cycle of this one, complete cycle of this. So you have the convection current cell will be there, and these convection current cell in the mantle are responsible for, convection current cell in the mantle are responsible for the divergence or convergence and the plate movement. And this is here is the most important, most fundamental thing about this particular concept. Now ये जो plates का बात किया मैंने, I have just said about the plates. In the plates you can see here, the plates are, all these plates
they are moving in different direction, they are responsible for many things. ये नाचका प्लेट है, ये देखो ये सब प्लेट. You can see about Eurasian plate this side. Here is the Indian plate, how it is converging. ये Eurasian plate है, Indian plate they are converging. African plate के साथ diverge कर रहा है, देख रहे हो यहाँ पे. So volcanic eruption will be there. Different plates are moving in different direction based on the convection currents inside the earth interior. So mental में जो convection current है, that is more important factor. What is more important is the convection current which is present inside the earth interior in the mantle. That plays a very significant role on this, right? It plays a very important role, very significant role it plays. Please do remember, this leads to, there are different possibilities even. So let us look at now. These plates are of two types. दो तरह की प्लेट है. One continental plate. Continental plate, they are located above the continent, located on the continent, on the continental region, continental part. It is less denser. Okay. So you have like example of this plate, American plate. Then you have another plate, you have one is American plate, African plate. We have also plate here like Indian plate. We have also plate like Antarctican plate. All these are very good example here of continental plate. Same way we have another one is oceanic plate. Oceanic plate, they are part of it includes the oceanic surface. So here it is thin and more denser one, thin and more denser. Okay, if you look at this plate, oceanic plate, if you look at this thin and more denser, I said oceanic plates are thin and more denser. These are an example of this one. You can say Pacific plate, Nazca plate. You know about Nazca, Nazca, Nazca plate, etc. All these are good example here. Pacific plate and Nazca plate. Best example of these plates here. So we can see this in the map itself. We can see these plates. There are two types of plates in fact, major plate and minor plate. आप मन याद रखने में परेशानी हो सकते हैं. It will be difficult for you to memorize these names, but I would like to tell you a trick. PEAA, PIA, okay, Pacific, Eurasian, American, Australo-Indian. Australia and Indian make common together, and you have African, and Antarctican plate. These are the plates here. 1, 2, 3, 4, 5, 6. 6 major plates. Minor plate, if you will see, minor plates are like, if I will say the minor plate, we have the very important one, ABC3, PJNS. मैंने कहा अरेबियन, बिस्मार्क, कैरोलिना, कैरिबियन, कोकोस, फिलीपींस, जुआन डी फुक्का, नाचका एंड स्कोटिया, दीज आर द प्लेट्स हियर. आपको सब याद करना नहीं है. व्हाट यू हैव टू डू, अरेबियन प्लेट यू मस्ट रिमेंबर, बिस्मार्क, कैरोलिना, कैरिबियन, कोकोस प्लेट 6. यू मस्ट रिमेंबर दिस फिलीपींस, जॉन डिफोका यस, नाचका, स्कोटिया यस. ये 4 प्लेट याद होगा. यहाँ पे यू मस्ट रिमेंबर पैसिफिक, यूरेशियन, ऑस्ट्रेलो इंडियन, ये तीनों याद होगा एटलीस्ट. यू जस्ट लुक दिस प्लेट्स एंड ट्राई टू लोकेट दिस प्लेट्स लोकेशन also you can see in your map or atlas. Here is a question, sir. Convectional current happens by what causes? Thermal gradient, because of high temperature. जैसे हम पानी गर्म करते हैं तो जैसे जाता है thermal convection, thermal convection. Okay, because of change in the temperature. जैसे ही when the magma goes upward from the earth interior goes up, heat release होगा, it cool down and it become denser. When it is cool, it become denser. So it will goes up, cool down, and again it will sink down because of this, because of cooling. Very hot, hot, then warm, then again hot, very hot, like this. There is a cyclic way. There is a change in the state of the matter. I mean there is complete convection current, like as you know, as मैंने आपको example दिया, I have given the example of boiling the water. While you are boiling the water will goes up again, that's like a cyclic way, there will be complete circulation. Same way it will happen. Okay. Minor plates में Arabian plate, Bismarck, Carolina, Caribbean, Cocos, Philippines, Juan de Fuca, Nazca and Scotia. These are the very important plates here. The most important plates are located in these regions. Block mountain reverse faulting, Rift Valley, normal faulting. Is it correct? You tell, while you are giving the answer, can you specify where is normal faulting? Normal faulting tension में होगा. Okay, मैंने बार बार बोला हूँ. पेज नंबर, आप एक काम करो, having problem in this folding faulting ना, I would like to recommend you G.C. Leung, Go Cheng Leung, Certificate Physical Geography. Here you can see page number 15, 16, 17. पेज नंबर 15 आप देखिए, उस पर डायग्राम दे रखा है. आप पढ़ते ही नहीं लग रहा है. यू हैवंट स्टडीड एनीथिंग ना, कोई बात नहीं. आई हैव सेड दिस पर्टिकुलर थिंग, नो फोल्डिंग faulting, you shouldn't have any problem on that. नॉर्मल फॉल्टिंग ऑलवेज, मैंने कहा नॉर्मली क्या होगा, टेंशनल फोर्स फॉल्टिंग, ऑलवेज नॉर्मली इट विल हैपन. टेंशनल फोर्स फॉल्टिंग, कंप्रेशनल फोल्ड, कंप्रेशनल फोर्स में क्या होगा, फोल्डिंग और रिवर्स फॉल्टिंग. ओके, P4, PA4, these are the here major plates, minor plates. ये सब मैं कहीं ना कहीं इस साल जो है ना, last couple of years, if you see disturbances more in these regions, so मैंने कहा ये 3 plate and वो 3 plate. You must remember this. Philippines plate also we have. Sorry, Juan de Fuca, Philippines, Nazca, Arabian plate. 4 देखना है. 4 plate को देखिए. We'll find out many things on this. Convection current is due to thermal gradient, temperature factor. Geothermal gradient से बनेंगे. Okay, as you have just seen about this minor plate and major plates, let me show you the earth, in fact the India map. In this you will find out here total earth is divided into several plates here. You see, these are the plates. These plates are moving in different direction, going in different direction. Okay, ये पूरे प्लेट सब है. इंडियन प्लेट देखो, दिस इंडियन प्लेट इज मूविंग इन दिस डायरेक्शन, इंडियन प्लेट इज गोइंग इन दिस डायरेक्शन, ऐसे. और यूरेशियन प्लेट ऐसे आ रही है. सोमाली प्लेट इज गोइंग इन दिस डायरेक्शन. Divergence, it is going in this direction. Okay, so you have like here, that's why fold mountain of which one? Himalayan fold mountain is developed here. Because of this only Himalayan fold mountain is developed here. Compressions की वजह से हुआ है. So यहाँ पे क्या होगा? Here folding होगा on reverse faulting. Reverse faulting you will find out in Greater Himalaya also. But यहाँ पे ब्लॉक माउंटेन रिफ्ट वैली फॉल्टिंग अगर टूटता है प्लेट तो फ्रॉम बिलो यू हैव वोल्केनिक इरप्शन आल्सो विल बी देयर. ओके, सो दीज आर ओशियनिक प्लेट. ओशियनिक प्लेट, कोकोस प्लेट इज ओशियनिक प्लेट. कोकोस प्लेट ओशियनिक प्लेट, नाजका प्लेट ओशियनिक प्लेट, पैसिफिक ओशियनिक, कैरिबियन ओशियनिक. नाउ नॉर्थ एंड साउथ अमेरिकन प्लेट आर कॉन्टिनेंटल प्लेट. African plate, अच्छा, Caribbean plate, Somali plate, you can see part of ocean also there. Indian plate, continental plate, Australian plate, continental plate, but part of ocean. Philippines plate, oceanic plate, Eurasian plate, continental plate, Antarctican continental plate. These are here. These plates are moving in different direction because of convection current, and there is possibility. So now I will go for what are the mechanism of plate movement. Mechanism क्या है? Mechanism of plate movement. Mechanism of plate movement. Mechanism of plate movement. These plates are moving in different direction because of different causes. These plates are moving in, or plates are lithospheric plate. Lithospheric plates are moving in different directions based on the convection current from mantle. Okay. During this process, what happened? When they are, let us say here is a plate which is going down. Let us say here is an oceanic plate. Another one is here is the continental plate. Oceanic plate goes down. This is the continental plate. Continental plate. Here is the oceanic plate. So the oceanic plate is moving in this. This is here. So what will happen here? At this region, this is like ocean. This will goes down. When it goes down, it will melt away. Melting of this. After melting, what will happen? It will have the force, it will come up. This will come up. This will is magma and give pressure, and there is possibility even of volcanic eruption here. ये volcanic eruption होगा. But you see here what is happening? One plate is subducted below another plate here. ये oceanic plate heavier है and continental plate is lighter, so it is going down. It will melt, all the material will melt away because every 32 meter, कल बोला था ना 32 meter depth, there is 1 degree Celsius temperature बढ़ता जाएगा. 32 meter depth, 1 degree Celsius temperature increases. In this way, if you will see, after certain depth, there is a complete possibility, that it will give pressure from below. The molten material will give pressure and it will go very quickly, it will go inside. Now what will happen? Because it can goes very quickly and this process will continue. ये continue करेगा कब? जब तक ये पूरे प्लेट को नहीं खा गया है. This is known as this is because of what? This is because of the gravity, it will goes down. So this is known as the slab pull and ridge. Slab pull due to gravity मैकेनिज्म ऑफ प्लेट मूवमेंट में पहला तो है ये पॉइंट है कि लिथोस्फीरिक प्लेट्स आर मूविंग इन डिफरेंट डायरेक्शन बेस्ड ऑन द कन्वेक्शन करंट फ्रॉम मैंटल, नंबर 1. सो क्या क्या है, पहला तो है कन्वेक्शन करंट है. फर्स्ट फैक्टर इज कन्वेक्शन करंट फ्रॉम मैंटल. सेकेंड फैक्टर इज स्लैब पुल ड्यू टू ग्रेविटी. ग्रेविटी की वजह से, बिकॉज इट इज हेवियर एंड गोज डाउन, देन यू हैव, इट विल melt away, so it will goes up again. And another one is ridge push. Another factor is ridge push factor. Ridge push, slab pull, ridge push factor. Ridge push क्या है देखते हैं अभी. If the plate is here, it is subducted, it is going down, melting and gravity की वजह से अंदर आते हैं, इसको बोलते हैं slab pull. Are you clear with the slab pull factor? Convection current. Convection current, I have already explained this. This is the convection current. Okay, first factor. Second factor is slab pull. Slab pull क्या है? This among these two, denser one will goes down because of gravity. Gravity will pull down and then it melt away. After melting, it will give pressure, so it will, this plate will move up. So again it will goes down because यहाँ friction कम हो जाएगा. देखो यहाँ the continental plate के साथ इसका friction with the continental plate will be less, it declines. So when it give pressure from below, this will goes deeper inside, it will go deeper inside. Got it? Now because it goes deeper inside, it melt away. After melting, it will form, it melt away and it will form what? Volcanic eruption will be there and volcanoes will form here. Volcanic eruption and volcanoes will be there. Here you will have volcanic eruption and volcano will form here. You remember this. I hope you got it. Slab pull factor is there, you got it. It is accompanied by another factor known as ridge push. What is that ridge push factor? Slab pull and ridge push. ridge push factor क्या होगा देखो आप. Slab pull तो I hope you got it. So what happened? this is the core of the earth, let us say, and this is, here is an oceanic plate. This is an oceanic plate. This is an continental plate. Here is a continental plate. This is a continental plate. See here, when these two plates, when it moved up, like you see here, convection current leads to movement of these plates in these regions, as I have mentioned about this. Okay, so see, the oceanic plate is going, OP mean oceanic plate will goes below the continental plate. See here, why it will goes below the continental plate? Because so the convection current cell will be like this, you see here. What happened when oceanic and continental plate meets? ये continental plate है, oceanic plate is denser one, so it's subducted below, and then this one. This will now melt. ये यहाँ पे melting होगा. Melting होने के बाद क्या करेगा? It will give pressure here. After melting, it will give pressure and it will move upward. यहाँ से ऊपर उठ जाएगा. It will move upward. Why? Because when it move upward, give pressure, what will happen here? If it will give pressure, ये friction जो है ना यहाँ पे, friction will be less. ये plate के साथ friction कम होगा. It will goes deeper inside, melt away. So what is happening here? Here it is melting, giving this. But ये जो है ना, this is, here is new volcanic eruption will be there at this particular place. You have volcanic eruption. Here you have volcanic eruption. Yes or no? So because of more and more volcanic eruption, it will give pressure also from both side. Pressure देगा. So ये push कर रहा है. Ridge. This is known as a ridge. What is this ridge? This new volcano is a ridge. The ridge is pushing here both side. So ये हो गया आपका ridge push. क्या बोला मैं इसको? Ridge push. Here you have the pictures of ridge push. It is giving pressure. Ridge push. And here it is slab pull. Below which is going it slab pull. Slab pull and ridge push. This is the process through which the plate will move and the mechanism will be different, as I just have mentioned. Ridge push, slab pull. Okay, very good questions by one of your friend. Due to pressure, it goes in depth. Okay. But how this molten material goes up in the form of magma? My friends, which molten material? ये बोल रहे हो? So what happened here? It is at around 400 kilometer maximum. 400 to 400 kilometer nearly, you know, 70 से start होता है, 700 में पूरे completely molten हो जाते हैं. तो pressure, it cannot go deeper inside here. क्योंकि जो मैग्मा के जो सर्कुलेशन है ना, ये कभी अगर थोड़ा स्टफ हो जाता है थोड़ा सा भी, दिस मैग्मेटिक सर्कुलेशन में थोड़ा इम्पैक्ट पड़ेगा, देन ओनली इट विल हैपन. इट इज नॉट एवरीवेयर. यू टेल, लेट मी टेल यू व्हाट विल हैपन हियर. बिकॉज ऑफ दिस, ये स्लैब तो ये तो चलता ही रहेगा, ये थोड़ा ऊपर उठ गया तो इट विल गोज डीपर इनसाइड. दिस विल गेट हियर. हियर देयर इज सम डिस्टर्बेंसेस समटाइम्स मे हैपन. रीच प्लस स्लैब पुल का आप ridge push and slab pull, you can see this.
in the video. One point it is going up, another point it is coming down, ridge plus and slab pull. It is here, it is going down slab pull. Asthenosphere में ये हो रहा है, देखो आप, slab pull, it will goes down. Here ridge will push, ridge is pushing, ridge push, sea floor spreading, slab pull. Both whenever these two factors are there, this will have this particular characteristics. Pressure is there, ये जो है ना pressure ज़्यादा होगा इसका जो push करेगा, and this will continue. In fact, this will continue. This process will continue. This is a factor here. By the way, as I have just mentioned about all these, so the plate, there are different possibilities here. Question तो उससे आएंगे. There are, due to the plate movement, as a consequence of convection current, cell formation and ridge push, slab pull processes. Due to plate movement as a consequence of convection current, cell formation and ridge push, slab pull processes, three possibilities arises. Three possibility arises. क्या क्या है? First, two plates will go away from each other. दो प्लेट आपस से दूर चले जाएंगे. Two plates will go away from each other. Or divergence plate boundary formation. Second is, two plates will approach towards each other. और क्या बोलेंगे इसको? Convergent plate boundary. They will form these two things, divergent और convergent. पहला तो दो यही रहेगा. So in case of divergent plate boundary, two plates will go away from each other. Divergence plate boundary formation. Two plates will approach towards each other, convergent. And the third one is, one plate slide past another. One plate slide past another plate. or transform fault boundary here. One plate slide past another plate. One plate is moving in direction, another is moving in this direction. So here is the plate boundary, and this plate boundary is transform fault plate boundary. This is known as the or transform fault plate boundary. Can you see this diagram here? You will get to know about this. After getting this diagram, you can see this. There are three possibilities. Two plates will move towards each other, they will go away from each other. There are three possibilities. They will go away from each other, they will go away from each other, they will come towards each other, or the one plate will slide past another plate. So, divergent plate boundary, this is here is called as the divergent plate boundary. Here it is divergence, here it is convergence, and here is transform fault. Three things: divergent, convergent, and transform fault plate boundary. Divergent, convergent, and transform fault plate boundary. Three types of plate boundary you are having: divergent, convergent, and transform fault. Okay, done. I hope you got it. Three types of formation. Now, what will happen if there is divergence? Number one, divergent plate boundary. Divergent plate boundary, it will form what? First is faulting hoga. Faulting, what type of fault? Normal faulting. Second is new rift valley formation. Faulting what? Rift valley formation. Then you may be have like new river valley, new water body, or even new sea. New, my example, you can give some river valley, new river valley, like Narmada Valley. Example is there. Example. New water body where lake, let us say, Lake Tanganyika. You know where is Tanganyika in Africa? Great Rift Valley के अंदर है ये. New water body, new sea. Example, Red Sea. Gulf of Aqaba, New Sea, Gulf of Aqaba, etc. Gulf of Aqaba, New Sea, everything is there. Like Gulf of Aqaba, New Sea. Okay, these are the things as I have just mentioned. Hope you got it. नहीं समझ में आया क्या? Because of divergence it will have. Example I will give you. Lake Tanganyika in Africa, New Sea, as I have just mentioned here. Let me show you few diagrams here. Few diagrams and this one I will show you. That will be okay for you, I think. You see the Great Rift Valley of Africa. If you look at this image, you will find out. This is here. This is here is the things like you see. This is the Rift Valley. How in reality, the picture you can see Rift Valley pictures. In Africa, you see. From National Geography, I have taken here. We can see this in this way. You see, this is because of divergence here. Red Sea is developed because of this Gulf of Aden. Red Sea, you can see this Gulf of Aqaba. This one is Gulf of Aqaba. ये जो regions है. This region is Gulf of Aqaba. Best example है ये Gulf of Aqaba है ना, ये Gulf of Aqaba. This region, Gulf of Aqaba is this one. Okay. Now a very important point I would like to say here. This entire region, it is a Rift Valley here. This part is a Rift Valley, you know. ये एक Rift Valley है. This is a Rift Valley. So this lake here, Lake Tanganyika is here. This is Lake Tanganyika. Lake Tanganyika. This one is Victoria. एक गोल वाला जो है ना Victoria है. This one is Tanganyika Lake. Lake Tanganyika, best example here. Okay. Got it? So new sea, new Gulf, new lake, new water bodies you are finding here. New water bodies you are here. New water body you are getting here. Red Sea and all. Best example. Hope it is clear. Faulting is there. ये जो है ये सब faulted line है. जितना भी मैंने कहा ये Rift Valley का ये क्या है? Faulted line है. All these are faulted lines. You can see this. You will get it like Great Rift Valley. This is Great Rift Valley of Africa. देखो कितना cracks आ रहा है ये. Because of this only. Rift Valley you are having. So many Rift Valleys, cracks, these are like, cracking because of the divergence. Cracks development and, subsequently a new fault line development. Normal faulting is there, normal faulting, the process of formation, normal faulting. Okay, faulting, Rift Valley, new river valley, new water body, new sea, all these things will be there because of this particular factor, divergent plate boundary. Is it clear to all of you? In India even, you can see, India में ये क्या है जी? देखो आपने देखा है ये ऐसे जा रहे हैं, ये ऐसे थोड़ा ये ऐसे है, ये टियर फॉल्ट तो इसीलिए है। देख रहे हो आप? The angle of force you can see, this leads to lot of cracks here. This is leading to lot of development of cracks in these regions. There are nothing but cracks. Formation is there. And a great fault line is developed already. And this fault line is known as Allahabad fault. Allahabad fault line developed here. This is here is टियर फॉल्ट लाइक डेवलपमेंट, डाइवर्जेंस से ही हो रहा है ये थोड़ा सा ऐसा है. You have so many such type of development, many part of the world you have such type of development. So what I am saying is, read value, divergent plate boundary, volcanic eruption will be there also. So you have volcanic eruption, that's the cause. Fourth point is volcanic, volcanoes or volcanism. Development of volcano will have this because of divergent plate boundary, you have the volcano. So divergent plate boundary, in this case volcanism will be there. Volcanism आप देखो ना, इतने सारे volcano in the African, ये जो triangle है, all these are volcanoes. These volcanoes are formed because of what? This volcanic development is primarily due to the divergence. This volcanic eruption is primarily due to the divergence. Friends, you must remember, volcano and volcanism. Volcanism is a product of tectonic activities also, volcanic eruption. Primarily here, you can see this example here. Numerous volcanoes are present here because of divergence of the plates. Plate divergence is the major cause or major factor behind this. Okay, I will go for the next one. Next we will see. ये डाइवर्जेंट प्लेट बाउंड्री है, वल्केनिज्म का ये बात किया मैंने, आई होप यू गॉट इट. नेक्स्ट वन, आई टोल्ड यू दिस वन. सी, डाइवर्जेंट प्लेट बाउंड्री is called as constructive plate margin. Plate margin, because new relief features develops here, develops in these areas due to volcanic eruption. Volcanic eruption, due to the volcanic eruption. Okay, due to volcanic eruption all these things happens. Is it okay? Divergent plate boundary are called as constructive plate margin. You remember this. I hope it is clear. Wherever there divergence, you have like this. Now coming to Second one, convergent plate boundary. Convergent plate boundary, here two plates move towards each other. So, three possibilities: continental plate, continental plate, continental plate convergence, continental plate convergence. In this case, whenever two continental plates converge with each other, what will happen? Because of pressure from both sides, folded strata you will get, fold mountain. Because of pressure from both sides, we have formation of the fold mountain. They form mostly fold mountains. Fold mountain formation will be there. Because of crustal doubling and compressional forces, we have fold mountain formation is very common here. This is the stage 1, this is in stage 2. In case of Indian, as you were asking about the case of Tibetan plateau, let me tell you, the Indian plate also formed, the Indian Himalayan mountain also formed in the same way. Himalaya was formed in the same way. I hope you got it. Now, if this is the Eurasian plate, and here you have the Indian plate. This is Tethys geosyncline. जियोसिंक्लाइन का मतलब होता है जैसे कि अर्थ के ऊपर ऐसे एंटीक्लाइन सिंक्लाइन अर्थ सरफेस में कहीं पे भी अगर सिंक्लाइनल वैली हो गया तो ये जियोसिंक्लाइन होगा. बट दिस जियोसिंक्लाइन हैज द पिकुलियरिटी ऑफ द सेडिमेंट विल गोज डीपर इनसाइड बिकॉज ऑफ ग्रेजुअली क्या होगा, पानी का लेवल जो है ना कोई भी जगह पे इन दिस पर्टिकुलर पार्ट द वाटर लेवल विल बी ऑलमोस्ट इक्वल बट द सेडिमेंट विल गोज डीपर इनसाइड. आप एक चीज देखो, जियो मतलब अर्थ, सिंक्लाइन सिंक्लाइनल वैली मतलब लो लाइंग वैली. ये जब फॉर्मेशन होगा दोनों साइड से जो इरोजन होगा, यहाँ दोनों से इरोजन होकर सेडिमेंट आएंगे तो सेडिमेंट जो है ना नीचे चला जाएगा. कॉन्सेप्ट के हिसाब से ये नीचे जाएगा तो उस टाइप ऑफ सेडिमेंटेशन होगा तो इसको बोलते हैं जियोसिंक्लाइन. ऐसे टेथिस सी में इधर से इरोजन होगा, इधर से इरोजन होकर यहाँ डिपोजिशन हो गया. दिस पर्टिकुलर रीजन वाज टेथिस सी. टेथिस सी में बहुत सेडिमेंट हुआ तो टेथिस जियोसिंक्लाइन बन गया. दिस टेथिस जियोसिंक्लाइन सब्सिक्वेंटली गॉट स्क्वीज्ड एंड इट फॉर्म द माउंटेन हियर. कौन सा माउंटेन हुआ? फाइनली यू हैव फॉर्मेशन ऑफ द हिमालयन माउंटेन जो है. सो ये बताते हैं कि यहाँ पर टेथिस सी का ये जो है ना टेथिस जियोसिंक्लाइन ही यही फोल्डेड होके हो गया क्या? माउंटेन, फोल्ड माउंटेन्स ऑफ हिमालय. यू प्लीज रिमेंबर दिस. सो बिकॉज ऑफ द कन्वर्जेंस ऑफ द टू प्लेट्स एंड सब्सिक्वेंट this has happened. Ridges are the ones only present in the oceanic plate. Yes, thank you. Bansikai sir, please explain if there is any difference between ridge and push and divergence.
नो, डाइवर्जेंस में क्या होगा वंशिका? डाइवर्जेंस इज द प्रोसेस थ्रू व्हिच द volcanic eruption will be there. After volcanic eruption, it form a solid, when the magma get molten, magma get solidified, तो उस पे जो है ना, and subsequently there is eruption from below, the solid magma, whatever you have ridge formed, it will push both sides. So ridge push, that's why ridge push. It will give pressure to the lateral pressure देगा. Sir, what about the Grand Canyon? Is it also an example of divergence? No. Grand Canyon is not a divergence. It is because of erosion. Erosional है. Erosion and subsequent upliftment. Okay. Friends, ये जो है ना, this is here is Himalaya, as you are saying. Himalaya is completely different. Himalaya is a fold mountain developed due to convergence of Eurasian and Indo-Australian Indian plate. This is the Indian plate. Indian plate and the Eurasian plate, both they meets. After meeting this successively, gradually there is formation of Tethys geosyncline and they form like this. I have just given this. Tethys geosyncline will form in this way. Then Tethys geosyncline, the sediments will get squeezed. They got layer by layer. They finally get this type of folded strata. Okay. Now, as per the new, there is like in a series of mountain. देखिए, if I will give pressure to this table, I cannot make it like smoothly at equal pace. I cannot give pressure. But if I will give jerk, it will be easy. Now, likewise, आप लोग exercise करते हो ना dumbbell को लेके, so if I will say that no, gradually you just lift and the gradually again this time if you will say that gradually you will do it, it will take. In fact, आपको बहुत stress होगा यहाँ पे. But quickly like this, it is very easy for you giving jerk and this. Likewise, ये जो plate move करता है ना, plate move करने के time पे when the plate is moving, plate cannot move in a equal pace. Sometimes it goes quickly, sometimes it is fast. Whenever it go quickly, if it move very quickly, because of this, what will happen? Differential movement is there. Maybe a crack may develop there. Quickly develop, if you give quickly, बीच में थोड़ा सा difference आ सकता है tensional force जैसा. But if it will give like it will goes in a smooth way, you will not able to get it. Like कुछ भी move कर रहा है ये, इतना में move कर रहा है, ये suddenly move करेगा तो बीच में यहाँ पे gap आ सकते हैं. Likewise, we have like here, while the formation of the mountain was there, the pressure was not equal. So when there is more pressure consistently, folded strata it developed. It developed a series of folded strata, series of mountain. The mountains here, as you know, a series of mountain it developed in the Himalayan part. This Himalayan part, mountains are like, if I'll say, if I'll tell you about the mountain, Karakoram, Ladakh, Jaskar, Greater Himalaya, Lesser Himalaya, Shivalik. So I am saying this is as Karakoram, Ladakh range, Jaskar range, this is Kailash range, then you have Greater Himalaya or Himadri range, Greater Himalaya, or Himadri. Here you have Lesser Himalaya, or Himachal Himalaya. Then you have Sub Himalaya or Shivalik. You have different ranges here. In between them, इनके बीच में यहाँ पे देखो बहुत सारे fault line develop होता है. Lot of fault line they develop here.
ये फॉल्ट लाइन का नाम आ सकते हैं, फॉल्ट लाइन का नाम पूछ सकता है। 1 ITSZ, ये MCT, MBF, and it is HFF. सीरीज ऑफ माउंटेन डेवलप किया यहाँ पे विथ सम important few, as I have just said, this type of fault line. What are these fault line? Let me tell you, fault line का नाम क्या है। First one, ITSZ, Indus Sangpo Suture Zone. Then you have MCT, Main Central Thrust. Then you have MBT, MBF, Main Boundary Fault. Main Boundary Fault, and HFF, Himalayan Frontal Fault. So these are like different name of the fault line here. So they can ask between two ranges what is the fault line and this. If at all in the difficult way they, because this Himalaya is in news nowadays, Himalaya because of certain findings, some of the geologists they are saying that this Himalaya, this is already after meeting both of these, now divergence is also going on. अभी divergence होने लगा है. That as my friends asked me, someone, let me tell you. Are you getting, my friends? All of you are okay with this? Any problem? Anyone having? Please let me know. Please go ahead. फोल्डिंग तो समझ में आ गया, रिवर्स फॉल्ट भी समझ में आ गया होगा आपको. You have given questions. Indian tectonic plate is splitting in two beneath the Tibet. Sir, kindly explain the recent discovery. See what is happening, and we have found, like, as it is India is rising, it is saying like Indian part of this one is now splitting, because already जो जहाँ होना था ना, already the convective shell or whatever it displacement was there, it's already they are formed and it got like welded. जैसे आपको बता दूं, earlier there is a saying, the plates are like gradually splitting somewhere, and where it meets two, and whenever there is less convection current from below, it welded up into one. ये welding भी हो रहा है. And then you have seen one thing that below, ये नीचे जो है ना, at the middle, at the lower part, at the new finding is saying below the Himalaya, there is a possibility that these plates already, which the plates which are already got welded up, rather now a repulsive force, like it is now splitting again it is splitting. Part of this one, it was already it was formed, and already the plate got shielded, already it is sealed in some part, not everywhere. It is saying that in the western part sealed हो गया है, and western part में पहले ये what is there, western part means this side, it is now splitting. Now these are based on the transform fault line, this is based on the divergent fault like features they got it. but it is not till date, not particularly verifiable by our Wadia Institute of Himalayan Geology and DN Wadia Institute in Himalayan Geology, as well as most of the Indian geologists, they are not in akin with this. Though some of the opinions are there, but Indian geologists को support अभी तक नहीं किया है, तो इसको theoretical form हम नहीं कर पाएंगे. It was just an views of some of the scientists it is. Okay, आप आगे आइए, देखिए we have one more. Sir, please explain the Himalayan range map from Google. Oh sure. Himalayan ranges जो है काराकोरम लें, लद्दाख, जस्कर, कैलाश, ग्रेटर हिमालय, लेसर हिमालय, सब हिमालय जो बताया मैं, बीच में ये सब फॉल्ट लाइन्स है, मैं यही बोला. सो लेट मी, एज यू आर सेइंग अबाउट फ्रॉम द गूगल, ओके श्योर. Now in the Himalayan ranges, if you look at, somebody has given, I don't know who is this, but well, Himalayas map. गूगल को काहे लेगा भाई, मैं किसका ये नहीं कराऊंगा. आप देखो यहाँ, आई विल ड्रॉ दिस. गूगल से परफेक्ट तो हम हैं. यहाँ देखो, Geography of India, in that I will discuss in detail about this. I don't want to copy it from somewhere. This is what I have given. I have just their line I have done because it will be easy for you. It is not the main class that I will give you in detail of this, but जितना दिया गया I think more than sufficient है आपके लिए. This is I am saying as the Karakoram. आपको इंडिया मैप में कराएंगे उस पे. काराकोरम रेंज, दिस इज हियर इज लद्दाख रेंज, दिस इज कैलाश रेंज, दिस इज जस्कर रेंज. आप रिलेटिव लोगों के देखिए, अपना एटलस पे देखो. If I'll see this in Google, most of the institutes they are claiming that they are their own. Okay, you must have seen this. National Geographic का भी कॉपी करके अपना इंस्टीट्यूट का नाम दे देता है लोग. What can I do? I don't want to use that. Karakoram, Ladakh, Kailash, Jaskar, Greater Himalaya or Himadri here, Lesser Himalaya here, Lesser Himalaya, and this is here is Shivalik, and this region is known as Purvanchal Himalaya. Purvanchal Himalaya. In the India part, I will discuss on this. The what is more important is you can see this region. I said you have a fault line. Here you have a fault line. Here you have a fault line, and here HFF fault line. Page number 35 in your atlas. Can you just check it out? If you have Oxford Atlas of 4th edition, is 5th edition 37 page number. You can see Oxford Student Atlas. आप देखो अपना atlas में है. Please see these things. Everything is given. You can see that you need to memorize. By the way, these are the serially, successively one by one you are having all these fault line and the development of these type of one by one, what I can say, different mountains you will get. Okay. So the Himalayan ये जो movement है, for that reason you have this type of development of this
mountains here I said, and I hope now it is clear to you that this is Greater Himalaya, Lesser Himalaya, शिवालिक, देस्कर, कैलाश. वो आपको अगर पीर पंजाल, धौलाधार रेंज से परेशानी है, I'll discuss this in the India part. Just wait for that. In the Indian part, I'll discuss. As I have said, all these parallel ranges of the mountain from north to south, you can Karakoram, Ladakh, Jaskar, Kailash, and all, these are like because of thrust angle, which is different from both the sides. That was the most problematic things. Between these two plate, or between these two, from the south, you have one plate, which is the Indian plate and the Eurasian plate. Whenever they are converging, both of them are converging here, and this is because of this convergence only, a series of mountain, as I just mentioned. So, Karakoram, Ladakh, Jaskar, Kailash, this is Himadri, then Lesser Himalaya and Shivalik. All these ranges are, they are parallel to each other and they are forming here. I'm just saying, this is here, in between you have fault lines are there, fault line development of fault line you are having. These fault lines, whatever I said, fault lines, whatever you have, these fault line, parallel fault lines, they are, they are the region, they are the major cause for the frequency of earthquake, which is more in the Himalayan regions. Friends, I have just taken up only one area, that is ocean, continental plate, and I have just given some example. The major fold mountains of the world are there formed because of continental and continental plate convergence. Both continental plate convergence. Okay. Second type is, second one, we have continental and plate and oceanic plate convergence. Oceanic plate convergence. Continental and oceanic plate convergence. Continental plate, oceanic plate convergence, as I just mentioned. Here what happened? For an example, let us talk about the Nazca plate. Nazca plate, and you have, as you know, all of us were well aware about, in South America. This is the South American regions. This is South American regions. Here you have the plates of, this is the Nazca plate, this side you have the plates, Nazca plate, here is South American plate, this is South American plate, this is Nazca plate. When these Nazca plate, South America plate, they are converging, here there is formation of a mountain, and this mountain is called as, here is Andes mountain. This is the Andes mountain here. Okay. So, this is a fold mountain is formed, and as well as here we have a trench. The name of this trench is here, it is called as the Peru-Chile trench. Peru-Chile trench. Peru-Chile Trench. Okay. This is your South America and Nazca plate. As I said, both are converging here. And what exactly you can see in your atlas, you will get. Continental plate, oceanic plate convergence. As I just have mentioned about this, Andes mountain, you have also few volcanoes here, like volcanoes. Do you remember this? Like here is Cotopaxi, Chimborazo, Ojos del Salado, Cotopaxi, Chimborazo, Ojos del. These are the volcanoes you are having. So three features are there. Peru-Chile trench is there. There is a trench is present, a fold mountain is there, and a volcano. Whenever oceanic and continental plate, they are converging. Whenever oceanic and continental plates are converging, the oceanic plate being very thin but heavier one, it will goes down. The continental plate on the contrary rides over this. This leads to subduction here. Subduction leads to formation of a trench, as you know. The plate which goes down inside, it melt away, and finally it forms a series of volcano here in these regions. Fold mountain strata and volcano also they form. Fold mountain and volcano, as well as I am saying trench. Wherever one plate moved below another plate, it form a trench. Again, if I can show it here about the convergent trenches and all formation. In this case, you can see here, if I'll the Britannica, it is something like nicely given in the Britannica part. You can see here, you see oceanic plate and oceanic plate both are converging here. Subduction, after subduction, rising of magma, volcanic eruption will be there. Here is oceanic and continental plate both are converging here. You have like in this particular point, here it will rise because of melting, and you will have continental crust first, when both of them they meets, folding will be there. Accretionally prism we call a
particularly a relief features form at the point where both of them they meets, then the fault, then the this side folding takes place, and fold mountain will have a trench also it will form. So we have volcano, fold mountain and trench, all the three things will be there. And as I have just mentioned about it, this is the best example. I will go for a diagram here on this. You see, if this is the oceanic plate and here it is the continental plate. Stage 1, both of them they meets here. Now stage 2, the sediments get accreted here, known as accretionally prism बनते हैं. यहाँ देखिए आप, it will have like in this way it will move downward, it will be like this. Okay, the oceanic plate will goes below the continental plate, which continental plate is less denser, right? Here what happen, while it goes down, it deposits some sediments here. These sediments known as accretionally prism, what you call accretionally, ACCRETIONARY, accretionally prism. You remember this. This accretional prism is the sediments which got deposited there when one plate is going below another plate. This is like got filled up with this, then because of continuous pressure, this will get folded up into a mountain here. You got it now? ये compact होगा, बहुत pressure से folding होगा, और subsequently ये तो folded हो गया. This will go, third case में क्या होगा देखिए आप. Later on what will happen, it will have a accretionally prism, सब चला गया उधर folded होके, तो यहाँ पे एक थोड़ा सा, this will be like this, you see here, this will be, here you have melting of this material and it will move up. As I told you, here you have volcanic eruption also. A volcano may develop, a volcano. Here you have a trench may develop here, and a fold mountain is there. Three things you have developed here. This got folded accretional prism, तो यहाँ पे क्या बन जाएंगे, ये trench बन गया. And this is a fold mountain. Volcano will be there, fold mountain will be there, trench will be there. Three types of landform they are forming, you see here. Trench are a very deep platform at the coast deepest trench is Mariana Trench, sorry. Deepest trench is Mariana Trench. Deepest trench is Mariana Trench. Trench which is deepest one is Mariana, you know it. ओशन में जो सबसे डीपेस्ट पार्ट ऑफ द ओशन इज ट्रेंच. वेरी डीप एंड लीनियर लैंडफॉर्म, लीनियर वैली करो, लीनियर वैली developed inside the ocean at the convergence plates of oceanic plate and continental plate. Trench is a very deep and linear valley developed inside the ocean at the convergence place of oceanic plate and continental plate. Wherever oceanic and continental plate, both of them are converging, wherever both of them are converging, जहाँ पे दोनों तीन, all these plates are converging, both the plates are converging, at that particular regions, one plate going down and there the regions, you know, ये जो trench हुआ, very deep valley, this is very deep valley are known as trench, Mariana Trench. Okay, there are different trench at different regions of the ocean. At different places you have different trenches. ये है trench. Trench is the deepest part of the inside the ocean. You will get the trenches like this. Trenches are like this, you see, inside this. So, trenches are very deep platform. These are the trench here. These are the trench, very deep platform you will have, where two plates meets. दो प्लेट जहाँ मिलते हैं, oceanic and continental, the oceanic plate being very hard, very denser, वजन ज़्यादा होता है ओशन प्लेट का और नीचे चला जाता है और यही ट्रेंच डेवलप होते हैं. बिकॉज ऑफ दैट ओनली द ट्रेंचेस डेवलप. Trenches develop due to this cause only. I hope you got it now. You got it, my dear. Trench क्या होता है आपने समझ में आया क्या? You are asking me. One question which I got earlier, that क्या रीज क्या ओशन में होता है? सी ये ओशनिक रीज का बात करता है, प्लेट टेक्टोनिज्म, बट रीज कैन बी ओवर द कॉन्टिनेंट ऑल्सो. रीज आर दोज पर्टिकुलर माउंटेन लाइक फीचर्स वेयर वन साइड इज स्टीपर एंड अदर साइड इज जेंटलर, उसको रीज कहा जाता है. लीनियर वैली मीन लाइन लाइक, यू नो, लीनियर वैली मतलब क्या है? लंबी होगा, वेरी लाइन लाइक, लीनियर वैली का मतलब. ओके, एक्रिशनली प्रिज्म, वेरी गुड. व्हाट इज एक्रिशनली प्रिज्म? लेट मी टेल यू. ये बहुत जगह मेंशन नहीं है एक्सेप्ट जियोलॉजी बुक्स. एक्रिशनली प्रिज्म क्या होता है? व्हेन एवर टू प्लेट्स मीट्स, देखो ओशनिक प्लेट इज गोइंग बिलो द कॉन्टिनेंटल प्लेट, So in the oceanic plate, if there is there is sediments and all, because it will go, it will press like, below it will go, friction will be there. So because of the friction, while it goes here at the margin, there is deposit of sediments. That particular sediments are known as accretionally prism. These are called as the accretionally prism. So वो भी ज़्यादा प्रेशर के वजह से क्या होगा, बिकॉज ऑफ कंटिन्यूअस प्रेशर इट विल गेट फोल्डेड अप accretionally prism, then it become very hard, then trench will form. If there is no accretionally prism also, trench can form. Any example of ridge on continental plate? Yes, there are. Anywhere if you have a mountain with, मगर वो रीज जो ना वोल्केनिक तो है ही, बट उसको रीज कहते हैं. ऐसे एक साइड ऐसे होता है, ये जेंटलर स्लोप, you have a steep slope. आप कहाँ से हो, दिल्ली से हो क्या? You know where is रीज रोड इन दिल्ली? दिल्ली यूनिवर्सिटी के पास रीज रोड देखा है? If you are going from Kingsway campsite, you go to the campus, your Delhi University campus, gently slope towards other side, steep slope. कमला नगर के साइड पे steep slope ही होगा उस तरफ, है ना? So one side is steep, ridge road इसीलिए कहते हैं. Anywhere one side, हिमाचल प्रदेश शिमला के पास है, ridge road है उधर भी. Anywhere one side is gentle, other side is steeper, ridge कहते हैं. ये होगा ओशियनिक रीज होता है. रीज पुश जो फैक्टर है ओशियनिक रीज, रिमेंबर दैट इज रिलेटेड विद ओशियनिक रीज, नॉट विद द ओशियनिक. ये छोटे छोटे होते हैं, रीज आर वेरी स्मॉल, वेरेवर डाइवर्जेंस इज देयर इट विल फॉर्म रीजेस. Example you said, there are any mountain, we have so many ridge road, in different areas you are having so many ridge road. Anywhere if there is. Now oceanic ridge क्यों नाम देते हैं? Because ocean में आप देखो यहाँ पे, if there is volcanic eruption here, now what will happen? The material will get erupted here, ऐसे जाएगा ना materials. This side steep slope, this is gentler slope, steep slope, gentler slope. ये ridge 1, a ridge 2, they are parallel. Two ridges developed from there. In a from ये होगा, देखो आप मिड ओशियनिक रीज का बात करेंगे, मिड ओशियनिक, मिड अटलांटिक रीज. अटलांटिक ओशियन में फ्रॉम नॉर्थ टू साउथ द एंटायर रीजन यू आर हैविंग दिस टाइप ऑफ मिड अटलांटिक रीज. यू विल फाइंड आउट वेयर इट इज in the entire regions of, I can say, रीज का अगर 3 डायमेंशनल we can see this ridge here is like, ये जो रीज देख रहे हैं ना, इट इज बिटवीन दिस टू वोल्केनिक इरप्शन से बनी है. ये मिडिल में देख रही है, एट द मिडिल दिस इज वोल्केनिक इरप्शन इज देयर. ये मिडिल में वोल्केनिक इरप्शन हो रहा है. एंड दिस साइड इज लाइक, इफ आई सी दिस थिंग्स, ऐसा है. दिस साइड gentler slope, this side you have steeper slope. ये steep होगा, gentler slope होगा. This will be like this. Here it will be like this. So that's why it is known as ridge. पेयर ऑफ रीज, इधर एक रीज होगा इस पे, इधर एक R1 है तो ये रीज 2 है, 2 रीजेस ऐसे पैरेलल ही है। इट इज लीनियर वन बिकॉज ये पूरे जो है ना, ये पूरे एरिया में ये एक साइड रीज एक साइड है। दिस इज लाइक दिस, सो यू विल फाइंड आउट लाइक दिस वन। आई होप नाउ इट इज क्लियर टू यू। Now in case of oceanic continental, I mean convergence, we have like this. Third type, sir, planets should have cleared independence neighborhood. For example, moon orbits around the earth, but no independence exists. But this is not a case of Plato, hence it was removed from the planet. Yes, there are 3 conditions for the planet, my dear. 3 condition होता है। आप जो है ना, ये प्लेटू जो है नेपच्यून का पाथ से ले ये चला आता है, आपको पता होगा, ये याद होगा। प्लेटू नेपच्यून का पाथ में होता है, उधर भी वेरी इलिप्टिकल, दैट वाज द कॉज, क्लियर पाथ नहीं है, दिस इज द मेजर कॉज। ओके, डियर सर एंड मैनेजमेंट टीम, प्लीज प्रोवाइड क्लास पीपीटी along with some additional material. कैन यू प्लीज कॉल मी दैट पर्सन हु सेड दिस, मेरे को फोन करके बात करिए। आप एक काम करो, माय फ्रेंड हु आस्क्ड अबाउट दिस, एडिशनल मटेरियल क्या चाहिए मुझे बोलो, ये आई विल टेल यू द रेफरेंस। यू डू वन थिंग, आई एम गिविंग माय नंबर, text me if required anything. Okay, you must connect immediately, I mean after the class you just call me. Okay, you shouldn't have any problem on this. Okay, we'll see, जो भी होगा सपोर्ट देंगे, डोंट वरी। जेंटल एंड स्टीप डिफरेंस क्या है? अरे भाई, इधर पे अगर मोर एंड मोर इरप्शन ऑफ द मैग्मा होगा तो ये क्या करेगा, इधर पे बहेगा कि नहीं? द मैग्मा विल गोज डाउन बेस्ड ऑन द ग्रेविटी। हियर कंटिन्यूअसली इट इज फ्लोइंग, कंटिन्यूअस मैग्मा इज कमिंग, सो इट विल हैव लाइक इट कैनॉट गिव लाइक, यहाँ पे ऐसे हो सकता है, बाद में तो ऐसे आएगा ना, बिकॉज ऑफ व्हाट? बिकॉज ऑफ continuous eruption, it will due to gravity it will goes down, so different, ज़्यादा दूर होगा, दूर तक तो नहीं जा पाएगा ना, definitely final appearance will be like this. Here steep रहेगा इधर, क्योंकि continuous force is more here, so it goes up. These are very basic things. Okay, then that's why definition of ridge is, one side it should have steep slope, another side we have gentler slope. General definition of a ridge. Okay, these are mountain, dome, whatever there, with one side is, it is two ridges here. यहाँ पे एक ridge होगा, ऐसे एक ridge होगा. This is a ridge. One side steeper, one side gentler is known as a ridge. Generally, this is the general definition of a ridge. General definition of a ridge it is. Anyway, oceanic continental, oceanic I haven't done. So 2 things only we have done here up to this. हम 2 चीज कर रखे हैं। कन्वर्जेंट में क्या क्या बनाया? कन्वर्जेंट में आई सेड अबाउट कॉन्टिनेंटल प्लेट कन्वर्जेंस। इस पे सबको क्लियर है क्या? कॉन्टिनेंट प्लेट कन्वर्जेंस इज क्लियर टू ऑल ऑफ यू? यस और नॉट? कहाँ चाहिए बताओ? It shows, okay, fine. Now, second one was continental plate, oceanic plate is clear or not? Oceanic continental. Tell me, is it clear to you? थर्ड वन, कॉन्टिनेंटल प्लेट कन्वर्जेंस मैंने कहा
I hope you got it. Okay. Third one, Tisra. Now I'll go for the third one. This is about the oceanic plate convergence. Oceanic plate convergence. My friends, you remember one thing. This is the PT crash course. So I just require one thing from you also. You must study. You must study. Without studies, how it will be possible? So repeatedly I have to move. In fact, I know for each and everything, for each planet, I still remember I used to take earlier each planet, one planet, at least half an hour I used to discuss. But here it is not needed. For lot of things are there about universe, lot of things are there about these things. हमें थोड़ा skip करना पड़ेगा, नहीं तो नहीं कर पाएंगे ना complete. I know a lot of things. So whenever you are not getting, please let me know. But you must do this. Our focus is prelim. आपके यहाँ पे क्या आएगा? मैं बोला कि प्लेट का नाम, द कन्वर्जेंस ऑफ द प्लेट. So what are the landform they develop? That can be asked. Why it is known as oceanic convergence, oceanic continental, where what type of landform is there? They can ask. That's why I am giving you this explanation. Oceanic plate में क्या होगा? Two oceanic plate while they meets. This is an oceanic plate. Here also another oceanic plate. Whenever two oceanic plate meets with each other, whenever two oceanic plates meets with each other, this is stage 1. What will happen? One plate will subducted below another one. One plate will moved below another one. Now what will happen here? Both the plates, as you know, they are over the ocean. ये ocean के नीचे ही है. Accretionally prism development in the case may be there, may not be there. Because here what happened, if it is there even, there will be a mountain may form inside. But very common thing here, it is the formation of a trench. Trench formation is very common here. Here you will get a trench and here you will have a volcano. Here you will get a trench and here you have a volcano. How it is? It will melt away and this may leads to the formation of a volcano here. Okay. So volcanic island can be developed here. A series of, when you imagine a case when the plate is moving in this way, plate is gradually moving in this way. If the plate will move, one thing will happen, a series of mountain may develop. A
a series of mountain may develop here. There is possibility of a series of mountain, development of a series of mountain, and ये जो है ना, when it is above the sea level, it will form an island. It will form an island. Now imagine a case, a series of island if it will develop, 1, 2, 3, series of island it will develop, and this is known as an island arc. क्या कहते हैं इसको? Island arc. Island arc. A series of islands. A series of islands develop here in a linear way. In a linear way. Linear way mean like a line, you know, एक line जैसे one line में linear way. Okay, series of islands in a linear way develop island arc. Friends, as I was talking about the previous year question which you must have seen, the number of question is very less from geomorphology. Rock से question आते हैं, earth interior से आया है. But if you will not cover this, though you will get hardly one question or may not get the question, but we need to cover this. Okay, इसको थोड़ा सा देखना पड़ेगा, even if it is not that important, but we need to know, because or else you will not able to see some conceptual things. Sir, do the oceanic plate also differ in their density? Which one plate subducted on another convergence? Yes, of course. दो प्लेट कभी भी समान नहीं हो सकते. Two plates never they will have the same density. Two plates definitely will have different density. But if the difference is more between these two, then one plate will subducted below another one. Okay, and the plate which moved down, it got melt away and it forms the volcano. Volcanic eruption will be there. One plate will get subducted below another one and volcanic eruption possibility is there. One plate will go below another one and volcanic eruption possibility is there. Okay, a series of volcano may develop. This is known as the island arc. It may form an island. So island in arc like form in a linear way, because the earth is round, so it will goes down. One plate is going down. A linear way, series of a line, in a line, you know, different volcanic island will form, known as island arc. My friends, one more thing you remember, this type of island arc will form an archipelago, a group of island, archipelago. The best example, Indonesian archipelago, Pacific plate, and you can say Indo-Burmese plate. You have like, can you see this two plates here? There are different plates between these two. You have Indonesian archipelago. Images, if you will see, that you will find out a very interesting thing, that in this case two plates are there. So both the plates they meets and one plate subducted below another plate. Can you see that Indo-Australian Sunda plate is there? These plates moved. Just 1 minute, we will see. We have a group of, here if you will see, a group of such type of, this is the plate here, Sunda plate, and this is Philippines plate. Sunda plate is a continental, part of the continental plate, and this Philippines plate is oceanic plate. Both of them they are meeting. It is not clear here, but one is Sunda plate, Philippines plate. This side you have Pacific plate. Three plates are there. Sunda, Pacific, Sunda plate, Philippines plate, Pacific plate. This is Pacific plate, this is Sunda plate, This is Philippines plate. When these plates are moving, आप ये दो प्लेट को देखो इधर के इधर आ रहे हैं, and this is the cause leads to, you know, here you have volcanic eruption. We have so many here islands you are having. Here there is, this plate is moving in this direction. In fact, though it is in this direction, it is converging here also. There is convergence. A very complicated geologic formation you are having here. Oceanic plate convergence leads to this type of formation. Oceanic plate convergence. Now do one thing, you remember, whenever there are two plates, oceanic plate are converging, the heavier one will goes down, lighter one will move up, and subduction will be there. Subduction leads to, even inside the ocean, one plate will get melt away and it forms this type of volcanic island. Okay, this type of volcanic island. Volcanic island बनाएंगे ही बनाएंगे. अभी आपको एक चीज याद करना है. One thing you please remember that, let me see if we have a better map of these regions. Just wait. Plates along Pacific. Plates. Let me see the images if I will get it. Yes. You can see here. Again, it is not given here. Here. देखो आप, this is Mariana plate, this side Philippines plate, small plate, these are, it is not given in fact. This side you have the plate, part of the Eurasian plate got split up and formed the Sunda plate. जो सुंदा प्लेट है ना, ये कॉन्टिनेंटल प्लेट है. जो फिलीपींस प्लेट है ओशियनिक प्लेट है. जो आपकी द प्लेट ऑफ व्हाट यू कॉल पैसिफिक इज ए ओशियनिक प्लेट. सो बिटवीन दिस प्लेट्स इन फैक्ट देयर इज कन्वर्जेंस, देयर इज फॉर्मेशन ऑफ दिस टाइप ऑफ landforms here. आप देखो इधर क्लियर है, here it is clear. You can see this. This is Pacific plate. फिलीपींस का डायरेक्शन देखिए अभी से. Anyway, Pacific plate is moving faster. This one, ये है आपका सुंदा प्लेट. This plate here it is सुंदा plate. This is Sunda plate. And this one is Eurasian plate. You should know the only concept. Concept इतना पता होना चाहिए. Whenever there is oceanic and oceanic plate, the denser oceanic plate will goes below the lighter one. The oceanic plate which is heavier one is subduct, and this leads to melting and subsequent volcanic eruption. आप देखो यहाँ पे जापान के पास ये देख रहे हैं ना, this is Japan here, this is Philippines plate is going in this way, this is Eurasian plate. They are meeting, forming the, because of volcanic eruption, here you have the Japan is here. This region also got, because of volcanic eruption only you have this type of development. All these are, Java is a volcanic island, you remember. All these are volcanic features here, and they are part of the Pacific Ring of Fire. A sub part of the Pacific Ring of Fire. So what we will get in case of oceanic plate convergence? Oceanic plate convergence में तीन चीज होगा. A trench, a volcano, or a volcanic island. That is the island arc. Volcanic island or island arc. So we have this type of things you will find out in and around the what you call Pacific Ocean.
Let me brief you again that the plate tectonics is a dynamic phenomena which goes on with, it is a dynamic phenomena, plate tectonics, and it depends on the energy from below, from the convection current from the below, and so many things. A series of island in a linear way, मैंने कहा कि island arc है. So island arc will definitely develop in this case. In the Pacific, whatever island arc you will get, they are primarily because of these particular processes. Now let's look at one more things. The third possibility, see, whenever oceanic and oceanic continental, three possibilities I have already done. So third, oceanic plate convergence, oceanic continental, continental, all the three is over. Okay. So this is about the convergence. Now I will go for the divergent plate boundary. What is there in the divergent plate boundary? Continental, oceanic. Now I will go for oceanic. Oceanic we have done. Okay, now I will go for another. C हो गया ये. Next type. So I told you about divergence, I told you about the convergence. Now third type is transform fault boundary. Transform fault boundary. My friend, remember one thing, in case of transform fault boundary, one plate slide past another plate. Here one plate slide past another plate. If there are two plates here, one plate slide past another plate. One plate will move in this way. I said one plate slide past another plate. So what will happen here? We have a fault line here. Transform fault. See here, only earthquake and fault line develops. Only earthquake and fault line develop. Frequency of earthquake will be more in this case. More and more frequency of earthquake you will have in this case. So these are certain things about your transform fault boundary. Whenever one plate slide past another. Best example is San Andreas fault. Example is San Andreas fault near California in USA. USA की कैलिफोर्निया के पास है सैन एंड्रियास fault near California in USA. San Andreas fault in California, near California in USA. San Andreas fault. Okay, I hope it is clear. Only fault line होगा, earthquake होगा और कुछ ऐसे ज़्यादा landform नहीं है. I hope you got it. San Andreas fault जैसे मैंने आपको पहले बताया था कि it will only crack will develop and there is earthquake only. There will be no volcanic eruption because ये टूट के displace नहीं हो पाएंगे. Weak zone never develop. So these are certain things about the plates and their movement. So because of plate tectonics or plate movement, we have fold mountain. Because of this, we have volcanic eruption, we have earthquake also. So let us talk about first, what is this earthquake? Earthquake क्या है? What is an earthquake? Earthquake and volcanism, two important points here. Let me tell you, earthquake is shaking of the ground due to sudden release of the stressed energy from the earth interior. है ना? According to the elastic rebound theory, according to the elastic rebound theory of rate, earthquake is earthquake is the shaking or vibration of the earth's crust due to sudden release of the stressed energy from the earth interior, stressed energy from the earth's interior. Okay. When any rock strata attains its optimum level of its carrying capacity, it breaks its carrying capacity, it releases the stress energy in terms of P and S wave. In the last class I did said primary wave and secondary wave. When these waves travel through the rock strata, shaking of the ground takes place. This shaking or vibration of the ground is known as earthquake. I hope it is clear to you. According to elastic rebound theory of rate, earthquake is the shaking or vibration of the earth crust due to sudden release of the stressed energy from the earth's interior in the form of primary, secondary wave, etc. Okay. Got it now? The place of origin of the earthquake is known as focus or hypocenter. The place of the origin of earthquake is called as focus or hypocenter. The place of origin of the earthquake is called as focus or hypocenter. Vertically above the focus on the earth's surface, epicenter is located. So, if this is the earth here and here is the place of hypocenter or focus, here is the epicenter. This is the epicenter. Hypocenter is below, epicenter is above this. On the surface is the epicenter, below you have hypocenter. Okay. So, maximum energy you will find out at focus or hypocenter, and vertically above this you have epicenter. What are the causes of earthquake? Elastic rebound theory, remember rates has given this. The accumulated stress got released in terms of energy, and while they move, this earthquake will be there. This is what this theory is talking about. Rates elastic rebound theory of rate. Okay. So, this is here is one part. So, I need to say one thing here. यहाँ तक क्लियर है कि नहीं? पहले मुझे जस्ट लेट मी नो दिस, बिकॉज आई फील somewhere like, because you are asking for material and so many things. So, I think that you have some confusion. If it is there, let me know that. I just want to know. I have I am this very important, and I need to know this, because class note, whatever I have given, you can see that with this, try to solve the material whatever I have just, I prescribe this because you need to look at some of the questions at least, previous year questions and all, you must practice. So, the regarding earthquake questions, what type of question they will give you? They will give questions on like causes of earthquake, reservoir induced earthquake, okay. Elastic rebound theory, okay, fine. What happened while I will give stress to this one, I will drag this, let us say, or I will give more pressure, it will break gradually. But when I am giving pressure, there is a carrying capacity of this material. It will carry the stress up to certain limit. When it attains its optimum limit, beyond which it cannot carry, then only it will break. While it will break, it will give, while it will break, it will release the energy. So, you will have a sound, maybe we will get. So, energy cannot be created nor be destroyed, it only changes from one form to another form, you know it. So, what will happen here? This energy, the body wave or surface wave will turn, they in fact, they will travel through the rock strata and they started shaking. So, what happened is, when carrying capacity, whenever it will attain the carrying capacity, it will break. जब a rock break करेगा, then only you will have the hypocenter. The place where the breaking of the rock takes place is the origin of the earthquake, known as the hypocenter or focus. Maximum stress to no stress attainment is there in this region, known as hypocenter. So, according to elastic rebound theory, earthquake or major cause of earthquake is stress inside the rock strata. So, when the stress get released in terms of primary and secondary wave, these moves inside this rock strata and shaking of the ground takes place. This is called as what? Earthquake. This is what I want to say. Hypocenter or focus is here, above this you have the epicenter. Okay, I hope Banshika you got it now. So, these are very important few things here which I need to say, like one very important point here, place of the earthquake. What are causes of earthquake? You see here, the causes of major causes of earthquake is, they are like, first one in natural causes, plate movement, plate tectonics, volcanism. Then we have crustal deformation, crustal deformation. Due to any cause, if there is crustal deformation, you will have earthquake. Okay. Then isostatic imbalances, there is also a factor. The stress creation is due to isostatic imbalances. You will have to know about the factor. A बहुत important, isostatic imbalances is the factor, how it is. Iso mean equal, stasis means standing. My friends, according to the principles of isostasy, every part of the earth surface is in a position of equilibrium. Mountain, plateau, plain, everything are exerting same pressure over the asthenosphere. देखिए ये क्या बोलता है, ये जो concept है isostatic equilibrium, if this is the asthenosphere here, this is asthenosphere, this is asthenosphere, all right. Then above this you have mountain, plateau, all this. So everything is in a already in a balanced position. You have everything is in a balanced position here. ये ocean है, this is continent है, everything is in a balanced position. Naturally astrosphere के ऊपर से ये सब balanced है, right? Now let us say this mountain get eroded. ये mountain erode होके इतना हो गया, and material जाके यहाँ deposit हो गया. You got it? This got eroded and this material got deposited here. Now what will happen? This will make imbalances. It will sink down because more and weight, and it will goes up because of less weight. Are you getting the things? Aravalli was once upon a time height was nearly 7 kilometer. Today it is 700-800 meter. So आपका जो ये जो material था, it got eroded and deposited somewhere. So Aravalli regions is now lighter than the nearby areas. So Aravalli will rise and the rest area will sink down. So जहाँ पे ये area जो है ना already balanced था, this will come here according to the principle. ये material यहाँ पे आके गिरा. So here you have more weight. This will have less weight, will go up. देखो owing machine जैसे सब कुछ balance way में है. According to the principle, if it is going down, this is going up. You will have a what type of things? Imbalances here, and there is a possibility that it will have stress creation here. Here there will be stress, and this stress may leads to subsequently earthquake here. Here it may leads to earthquake also. It may leads to the earthquake. Okay, ये जो stress होगा उसकी वजह से earthquake हो सकते हैं. This is a findings after the concept of isostacy. We got to know many things, and we are saying isostatic imbalances can be also a factor. It can be also a cause. Another one you can have like this type of factors are there. We have second category of factor is anthropogenic. Anthropogenic factor. Here first one is, of course you know that nuclear mining, nuclear test and all, you know, mining and nuclear testing. But one more important thing is construction of large dam construction and reservoir induced earthquake. Reservoir induced earthquake. What does it mean? You will use the reservoir induced earthquake mean if you will construct a reservoir somewhere, there will be isostatic imbalances. सब कुछ तो balanced था, already it was balanced. You constructed a dam there, so there is more pressure, imbalances will be there and it will create earthquake. मैं एग्जाम्पल देता हूँ, यहाँ पे कुछ नहीं था, लेट अस से ये डैम बनाया तो आप क्या करेंगे यहाँ पे, because of the more water here it got stored, weight will be more, it will give stress and you will have an earthquake because of this. Okay, so tomorrow I will repeat with this one. I will discuss from this causes of earthquake, isostacy. Tomorrow again I will tell you, but I hope you got some idea at least. Now we have to discuss few answers and so many things are there. I will plan it out. Whatever is there, question answer, tomorrow I will deal. Abhi to, because time is there, so we don't have time now. So we will do one thing, question answer and all, we will do all those things tomorrow, both the test. I will just let me cover substantial part for at least a good discussion. That's what I want also. Okay, so thank you very much.